Let O be the origin and the point A be represented by this complex number root 3 plus 2 root 2 iota, and point B is representing the complex number Z2 such that root 3 times mod Z2 is same as mod Z1, and argument of Z2, this is argument of Z1 plus pi by 6. Then we have to identify the correct statement about this triangle AOB where O is origin. Now, this is a problem on basic concept of modulus and argument of a complex number. The complex number Z1 is given and point A is representing this complex number. So, A will be nothing but root 3 uh, 2 root 2, x coordinate root 3, y coordinate 2 root 2. And Z2 is another complex number which is satisfying these two conditions. One is for modulus and the other one is related with the argument of complex. Argument of Z2 is argument of Z1 plus pi by 6. So let us plot these points in complex plane and then try to identify which type of triangle we are getting and what is the area of that triangle. So first let us plot this point A representing complex number Z1. Let us say this is some point A presenting Z1. Coordinate of A will be x coordinate root 3 and y coordinate 2 root 2. Also, argument of Z1 will be nothing but angle made by this line OA with x-axis, and modulus of Z1 will be the distance between these 2 points O and A. So clearly you can see that mod Z1 or the length OA, this will be distance of point root 3 to root 2 from origin. So it will be 3 plus another 8, so that will be root over 11. This is our real axis and this one is imaginary axis. So point A is at a distance of root 11 unit from origin. Now Z2 is represented by point B and the relation is that modulus of Z2, this will be modulus of Z1 divided by root 3. So the distance of point B from origin will be root 11 by root 3. And also argument of Z2 is argument of Z1 plus pi by 6. So if this is argument of Z1, let us call this angle as some angle alpha. Then angle made by the line OB, point B is representing Z2 with x-axis, that will be uh, alpha plus pi by 6. That means this angle has to be pi by 6. Right, this angle will be pi by 6. And here we have this point B representing the complex number Z2. And modulus of Z2 is nothing but modulus of Z1 by root 3. Mod Z1 is root 11. So that means this length will be root 11 by 3. Right. Now we are getting this triangle O is origin and we have this triangle AOB. Now there are two problems in this. One, we need to find the area of triangle, and other one we have to find the, when two sides are 11 and root 11 by 3, we need to find the third side, and then we need to check whether it is Asclepian triangle or we have isosceles triangle. Right. So first let us calculate area and see whether any option is matching or not. So for finding area of any triangle, the standard formula is half product of any two sides. So one side is OA, another side is OB, and into sine of angle between those two sides. So that means sine pi by 6. This is standard formula for finding area of any triangle. Area of triangle AOB, so half of OA into OB into sine of angle between OA and OB. Now this will become half of, one side is root 11, another one is root 11 by 3, and the angle is 30 degrees, sine 30 will be 1 by 2. So ultimately this will become 11 and that divided by 4 root 3, right? 2 into 2, 4 and root 3. So 11 by 4 root 3, that is the area of triangle. Now as you can see that none of the options are matching. So I mean option A and B area is different. So these two are incorrect option. Now let us find the third side of the triangle and then try to identify that out of these two options C and D, which one is the correct option. So let us say this third side AB is lambda. Now in order to find this third side, we can use cosine formula. So that means cos of pi by 6, right? Cos of this angle will be OA square plus OB square minus AB square, and that divided by twice of OA into OB. OA square means 11, OB square means 11 by 3, and then minus lambda square, right? That is cosine formula, that cos of any angle is sum of square of two adjacent sides minus the opposite side, and this divided by twice of OA into OB, right? OA is root 11 and OB is root over 11 by 3. So using this formula, we can find the value of lambda. Once you simplify this one and do the calculation, you will find that lambda will be root over 11 by 3, right? So that means this third side is root 11 by 3. Now this angle was pi by 6 and these two sides are equal. Side OB is same as side AB. So if two sides are equal, clearly it cannot be a scalene triangle. It has to be isosceles triangle. And also if this angle is pi by 6 and the two sides are equal, this angle is also pi by 6 and here we'll get 2 pi by 3. So it is obtuse angle isosceles triangle, and therefore the correct answer for this problem will be fourth option, right? The right answer for this problem will be option D. So this was not a difficult problem. The important concept was to be familiar with the concept of argument and modulus. Modulus is distance from origin. Argument is the angle made by that uh, point joining origin with the x-axis. So once you plot these 3 points, then after that for area of triangle we have a standard formula, half of product of any two side into sine of angle between those two sides, and using cosine formula we calculated the third side. Finally, the correct answer for this problem is fourth option. If alpha and beta are the roots of this quadratic equation in Z, where iota is root over minus 1, then we need to find the value of this expression. 16 into real part of this complex number, alpha raised to 19 plus beta raised to 19 plus alpha raised to 11 plus beta raised to 11, and that divided by alpha raised to 15 plus beta raised to 15. The second term is also same, but here we need imaginary part of that complex number. Here we need real part. Now for this equation, the roots are alpha and beta. First, we need to simplify this expression and then we'll see what are the real and imaginary parts of this one. So for a moment, let us say that this complex number is omega, right? This complex number alpha raised to 19 plus beta raised to 19 plus alpha raised to 11 plus beta raised to 11, and that divided by alpha raised to 15 plus beta raised to 15. Let us call this complex number as omega. So we have to think that how we can simplify this one. And remember, alpha is the root of this quadratic. So alpha will satisfy this quadratic equation, right? Now see here what we can do is that in denominator you have alpha raised to 15 plus beta raised to 15. So try to create the same thing in numerator. From these two terms, alpha raised to 19 and alpha raised to 11, you can take alpha raised to 15 common, and that means we have alpha raised to 4 plus 1 by alpha raised to 4. We'll see how to find the value of this one. And similarly, from the remaining two terms, you can take beta raised to 15 common, and that means you have beta raised to 4 plus 1 by beta raised to 4. This will be the numerator part of this complex number omega, and that divided by, in denominator, we have alpha raised to 15 plus beta raised to 15. This is the complex number omega, right? And now because it is given that alpha is the root of this quadratic equation, so we'll try to find the value of alpha raised to 4 plus 1 by alpha raised to 4. And same thing we can do for beta also. So if alpha is the root of that given quadratic equation, we can say that 2 alpha square minus 3 alpha minus 2 iota, this will be 0. In place of z, we can substitute alpha because alpha is the root of this equation. And now we have to think that how we can create this term alpha raised to 4 plus 1 by alpha raised to 4. So for that, take this 3 alpha on other side. So that means 2 alpha square minus 2 iota. This will be 3 alpha. Now divide everything by alpha and also take 2 common. So then it becomes alpha minus iota by alpha, and this will be 3 by 2. We have divided by alpha on both sides, and we have also, we have divided everything by 2 alpha, right? So this is what we are getting. And now we can square. The reason we are writing in this form is because if I use a minus b square formula, then in twice ab term alpha and 1 by alpha, this will cancel. So we'll get alpha square plus 1 by alpha square or minus 1 by alpha square, and then after one more square we can create this term. So if I square this one, we'll get alpha raised to 4, and then iota square by alpha square. Iota square is minus 1, so minus 1 by alpha square, and then minus twice AB. Now in minus twice AB term, alpha will cancel, and on right hand side we have 9 by 4. So this is what we are getting for alpha square minus 1 by alpha square. Now the same relation you can write as alpha square minus 1 by alpha square. This equals to 9 by 4 plus 2 iota. And we can square one more time to get the value of alpha raised to 4 plus 1 by alpha raised to 4. If I square this one, we'll get alpha raised to 4, 1 by alpha raised to 4 minus 2. And the right hand side will be 81 by 16 minus 4. And then the twice AB term will have 4 will cancel, so I think we'll get 9 iota from here. Right, this will be the twice AB term, 2 into 2 iota into 9 by 4. So finally the value of alpha raised to 4 plus 1 by alpha raised to 4, this will be 81 by 16 minus 2. So 81 minus 32, that will be 49 by 16 plus 9 iota. So this is the value of alpha raised to 4 plus 1 by alpha raised to 4. Now remember, beta is also the root of same equation. So for beta raised to 4 plus 1 by beta raised to 4 also will have the same value. And that means this complex number, now you can write this complex number omega as alpha. I mean, these two will have same value, because I mean you can replace alpha with beta and then do the same sequence of steps. So beta raised to 4 plus 1 by beta raised to 4, that will also have the same value. So that you can take common. So then we are left with alpha raised to 15 plus beta raised to 15, and this multiplied by 49 by 16 plus 9 iota. Because alpha and beta were the roots of same equation, so there will be same relation in terms of beta also. And this divided by alpha raised to 15 plus beta raised to 15. Now these two terms you can cancel. So ultimately omega is 49 by 16 plus 9 iota. And now the problem is we have to find the value of 16 into real part of this complex number multiplied by imaginary part. So for this problem, the answer will be 16 into real part is 49 by 16, and then imaginary part is 9. Now 49 into 9, so this will be 21 square, which is 441. Right, so the correct answer for this problem will be first option. So this was a problem where, I mean, it was important to take alpha raised to 15 and beta raised to 15 common, and then from the given equation, first we need to calculate alpha square minus 1 by alpha square, and then again you have to square that one to create this term alpha raised to 4 plus beta raised to 4. Once we had values of this term, then we calculated omega. Omega was 49 by 16 plus 9 iota. So real part will be 49 by 16, imaginary part will be 9. After calculation, we'll get 441, and hence the correct answer for this problem will be first option. If alpha is a root of this quadratic equation, x square plus x plus 1 equals to 0, and the value of this sum alpha raised to k plus 1 by alpha raised to k square of that, where k is from 1 to n, this is 20, then we have to find the value of n. Now clearly you can see that if alpha is a root of this equation, we know that root of this equation is omega, and omega is square. Right, if I have this quadratic equation x square plus x plus 1 equals to 0, so the root of this quadratic equation will be omega and omega square, and where omega is minus 1 plus root 3 iota by 2, and similarly omega square is minus 1 minus root 3 iota by 2. So in JEE Main you'll find the problems where they will give this complex cube root of unity in different ways. Sometimes they will give that alpha is this complex number minus 1 plus root 3 iota by 2. Sometimes they'll mention that alpha is a root of this quadratic equation. So you should be aware of the fact that if alpha is a root of this equation, then alpha is nothing but imaginary cube root of unity. Right? You can take any one of these two values of alpha. You can say either alpha is omega or omega is square. Any one of the two values will work. Here let us say alpha is omega. For this problem, we are taking alpha as omega. If you want, you can take omega square also. It will have the same effect. Now, regarding omega, we know these two properties that omega cube is 1, right? We are familiar with these two results that omega cube is 1 and sum of all the cube roots of unity, that is 1 plus omega square, this is 0. We are familiar with these two results. So here, this is a problem basically on this formula 1. We have to observe that alpha is omega or omega square and then this property. Now it is given that sum of this series, this is 20, then how many terms we need here, right? K is from 1 to n. So what is the value of n if sum is 20? Now let us try to figure out that if we take different values of k, then what are the terms we are getting here? If I take k as 1, then alpha raised to k means omega, and 1 by alpha raised to k means 1 by omega square of this one. This will become omega, and 1 by omega, that will be omega square, because omega cube is 1. Omega plus omega square will be minus 1, and minus 1 square will become plus 1. So if k is 1, the first term will be 1. Now let us take k as 2. If k is 2, the term will be, we are calculating this one, alpha raised to k plus 1 by alpha raised to k square. So if k is 2, the term will be omega square plus 1 by omega square of that one. Now again, 1 by omega square is nothing but omega, because omega cube is 1. And omega square plus omega will be minus 1. So this will become plus 1. Now remember, in this problem, the most common mistake is to think that every term is 1 and therefore we need 20 terms to make this sum 20. But remember, omega cube is 1. So if I take k as 3, then we'll get omega cube plus 1 by omega cube square of this one. Omega cube is 1, another one square. So this will become 4. So first two terms are 1, but the next term will be 4, right? Whenever k is multiple of 3, then each term will become 1 and therefore 2 square will become 4. And when k is not multiple of 3, then you will get this value 1. So here, basically, uh, if I have to find this sum, if I have to find the number of terms so that sum becomes 20, so first term is 1, second term is 1, and the third term will be 4. Now the same thing will repeat if you take k as 4, 5, and 6. At 4 you will get 1, at 5 you will get 1, and at 6 it will become again 4. Because if I take k as 6, then omega raised to 6, that will be 1. 1 by omega raised to 6, another one, 2 square will be 4. So now we have to see that how many terms are needed to get a sum of 20. So clearly you can see that if I take these three terms, sum will be 6 plus another 6, 12 plus another 6, 18, and we need two more terms, right? Then we can get a sum of 20. If I have to create a sum of 20, then we need these many terms. Now, as you can see that 3 plus another 3, 6 plus 3, 9, and then another two term will make it 20. So therefore, the value of n, this will be 9 plus 2, that is 11. And that should be the correct answer for this problem, right? So this was a problem where first we have to know that for this equation, the roots are omega and omega square, and therefore alpha has to be either omega or omega square. And we have this relation that omega cube is 1 and 1 plus omega square is 0. So when you take k as 1 or 2, the term will be 1, but if you take 3, then you will get 4. And whenever k is multiple of 3, you will get 4. Whenever it is not multiple of 3, you will get 1. So therefore, uh, total 11 terms are needed to get a sum of 20, and hence the correct answer for this problem will be 11. If z is a complex number, then we have to find the number of common roots between these two equations. Now, this is a problem from Singhese, and it was asked in JEE Main 2024. And here basically, in order to find number of common roots, first we'll solve this second equation. Right? We'll try to find all the roots of this cubic equation, and then we'll try to see whether those roots are also the root of first equation or not. Also, in order to solve any cubic equation, or in fact any polynomial equation of degree more than 2, whether it is cubic, quadratic, biquadratic, and so on, one root we need to get using hidden file method. and then from there we can get the remaining roots. So if I have to solve the second equation, one root we have to find using hit and trial. And for using hit and trial, mean constant term is 1, so we have to check with either +1 or -1. Right? We need to check only with the factors of constant term. So in place of z, if I substitute -1, because z equals to +1 will not work, right? We have all the positive, we have all the terms with plus sign in between, so it will not have any positive root. So let us check with z equals to -1. In place of z, if we substitute -1, the first term will be -1 plus 2 minus 2 plus 1. So it will become 0. That means z equals to -1 is a root of this cubic equation. And if z -1 is a root, this will imply that z plus 1, this will be a factor of this cubic. Right? For a cubic, we can have three linear factors. One of the linear factors will be z plus 1. So now we'll try to split the terms in such a manner that we can create z plus 1 as common factor, so that from there we can get the quadratic factor. So given equation is z cube plus 2z square. Now because we need z plus 1 as factor, so 2z square I'm writing as z square plus another z square. So that from first two terms we can get z plus 1 as common factor. Now again we have z square next term, and if I need z plus 1 as common factor, next term must be z. So that from these two again you can take z plus 1 common, and because we had 2z here, z we can write as z plus 1, this equals to 0. And now you can see that you can take z plus 1 common from all of these three terms, right? We can take z plus 1 common from here, from this one, and from these two terms. If you want, you can divide this cubic by z plus 1 and then get the quadratic factor, but this will be another easier method of finding the quadratic factor. So from first two, you will get z square. From next one, you will get z plus 1 equals to 0. And now clearly you can see that for this equation, if first term is 0, z equals to -1, this we have established earlier. And if z square plus z plus 1 is 0, from there you will get the roots as omega and omega square, where omega is the imaginary cube root of unity, omega and omega square. So basically for the second equation, these are the three roots, -1, omega and omega square. And now we need to check -1 we got from z plus 1 and omega square from this next quadratic equation, z square plus z plus 1 equals to 0. Now we need to check whether these numbers are also the root of first equation or not. So let us check one by one. If I take z as -1, then -1 raised to odd power, that will be -1. -1 raised to even power plus 1 plus 1. Right? So we are getting left hand side as 1. So -1 will not satisfy. Right? -1 cannot be common root because it is not root of first equation. If I take z as omega, let us check with z equals to omega. Remember, omega cube is 1. So if I take z as omega in first equation, the left hand side will be omega raised to 1985 plus omega raised to 100 plus 1. Now because omega cube is 1, we can divide this by 3. And if I divide this by 3, the remainder will be uh, 5 by 3. So remainder will be 2. That means this term will become omega square. And next term omega raised to 100 will be same as omega, because omega raised to 99 will be 1 plus 1. This will be 0. That means omega is a common root between the two equations. Omega is a root of second equation and it will also satisfy the first equation. Similarly, let us check with z equals to omega square. Now, if omega is a root, omega square, this will also satisfy, because in place of z, if we write omega square, then this term will become omega square raised to 1985. When you divide by 3, the remainder will be 1. So first term will become omega. And similarly, this term, second term, omega raised to 200, omega square raised to 100. And when you divide by 3, then you will get omega square. 198 is multiple of 3. So this will become omega square plus 1, which is again 0. So as you can see that z equals to omega and omega square, both of these numbers will satisfy the first equation also. So therefore, this is also a common root, right? So for second equation, there are three roots, -1, omega and omega square. The two roots, omega and omega square, will also satisfy the first equation. and therefore the number of common roots for this system of for these two equations, this will be 2, and hence the correct answer is second option, right? So this was not a difficult problem. Again, just solve the second equation. One root you need to find using heat and trial method, and once you get that root, the other two roots are omega and omega square, and then we need to verify from the first equation. So only the other two roots, omega and omega square, is satisfying the first equation, and therefore those two are the common roots, and hence the correct answer for this problem is second option. Let the complex numbers alpha and 1 by alpha conjugate lies on these two circles respectively. That means alpha is on the first circle, z minus mod z naught square equals to 4, and 1 by alpha conjugate is on second circle. Also, you can see that these two are concentric circle because for both of them the center is at point z naught, right? So then, and it is given that z naught is 1 plus iota. Then the question is, what is the value of 100 alpha square? 100 into mod alpha square, right? Modulus of alpha square. Now, there are different methods of solving this problem. One approach will be that point alpha lies on first circle. So that will give you one equation in alpha, and z naught is already given. And similarly, 1 by alpha conjugate lies on second circle. And by solving those two equations, you can try to find value of mod alpha. However, there is another interesting approach of solving this problem using geometrical method. So here, if you notice, for these two circles, they have same center. These two are concentric circle. So we are going to plot these two circles, and also for simplicity I'm drawing the complete circle in first quadrant. However, the actual diagram will be a portion of the circle will be in may not be in first quadrant because center is at 1 plus iota, center is at 1 1, and the radius is 4 unit. Here the radius is 2 unit. But just to explain the idea and to keep the diagram simple, I'm drawing this in first quadrant. So let us say these are the two concentric circles, and this is the center of these two circles at point z naught. Now, before we attempt this problem, there is one important concept that for these two complex numbers, alpha and 1 by alpha conjugate, the argument is same. Right, this is one important point because 1 by alpha conjugate, this you can multiply and divide by alpha, and then it becomes alpha by mod alpha square. And if you multiply a complex number by some positive number, its argument will not change. So this complex number 1 by alpha conjugate is nothing but alpha by mod alpha square, and mod alpha square is always positive. That means these two complex number will always have same argument. That means they will lie on same straight line passing through origin. Now it is given that alpha lies on the first circle. Alpha lies on this smaller circle. For smaller circle, the radius is 2 unit. This is 2 square, and for the bigger circle, the radius is 4 unit. So on first circle, we have the complex number alpha on the inner circle. So let us say this is some point A representing the complex number alpha, and this is another point B representing the complex number 1 by alpha conjugate. And because these two have same argument, they will lie on the same straight line. Let us say argument of each one of those two is theta. So they will lie, I mean, this point O, A, and B, these three will be collinear on a same straight line. And now using simple geometry in one or two line, you can get the answer for this problem. Let us join the center of the circle with origin, and also join the center of the circle with this point B. Let us call this point at some point C, and also join this point C and A. Now, if this angle is theta, we are going to use cosine formula, right? We are going to use cosine formula in two triangles. One triangle OAC and the other triangle OBC. In these two triangles, we'll use cosine formula, and from there, in few lines, we can get mod alpha square. Right, let us say mod alpha is lambda, and also this point was the center of the circle, so this will be 0.11. That means OC, this length is root 2 unit, radius of inner circle is 2 unit, and the radius of outer circle, this is 4 unit, right? So if I write cos, and let us say that modulus of this complex number mod alpha, this is lambda. Some modulus of this complex number is lambda, and that means modulus of 1 by alpha conjugate. This will be nothing but 1 by lambda. Now, if I write cos theta in this triangle OAC, then this thing is lambda. So we'll get lambda square plus root 2 square and minus 2 square, right? And this divided by, cos theta is, so sum of the square of two adjacent side minus the opposite side square, and this divided by 2 root 2 lambda. This is cos theta in the triangle OAC, right? In triangle OAC, cos theta will be lambda square plus root 2 square minus 2 square, and that divided by 2 root 2 lambda. And now let us find cos theta in this triangle OBC. So in triangle OBC, the length OB will be modulus of this complex number 1 by alpha conjugate. So that is 1 by lambda square plus this other side, this will be 2 unit, root 2 square, so that is 2. And this opposite side, this is 4. So minus 4 square, and this divided by twice of these two adjacent sides. So that means 2 root 2, and this multiplied by 1 by lambda. So this is the relation that we are getting. And now by solving this equation, one can easily get the value of lambda, and lambda will be nothing but mod alpha. So from these two equations, root 2 you can cancel, right? 2 root 2 you can cancel. So then this becomes lambda square minus 2. And on right hand side, you will get, if I multiply this with, this becomes 2 root 2 lambda. So lambda square we can multiply, and then we have, uh, this will become 2 minus 16. So it is 14. So that means here we'll get 1 minus 14 into lambda square, right? 2 root 2 will cancel from both sides. And then this right hand side, we'll get 1 lambda and another lambda from here. So we'll have lambda square. So 1 and minus 14 lambda square. So from here you can see that 15 lambda square, this will become 2 plus 1, 3. That means lambda square is 1 by 5. And lambda square is nothing but modulus of alpha square, right? So lambda square becomes 1 by 5. The question was we need 100 into alpha square. So 100 and alpha square means lambda square, right? Mod alpha square means lambda square. Lambda square was 1 by 5. So this will become 20, right? 100 into 1 by 5. So that should be the correct answer for this problem. So in this problem, basically the important concept is that the argument of these two complex numbers are same. One is alpha, another one is 1 by alpha conjugate. So therefore, if point O, point A and the point B, these three are collinear points. They are on same straight line. Now you have two triangle. One triangle is this triangle OAC. This is one triangle. So find cosine theta in this triangle. And then the other triangle is O, and then you have BC, right? This triangle OBC. Now find cos theta in this triangle, and then by equating those two, we can get the value of lambda square. And once we get lambda square, 100 into alpha square will be 100 into 1 by 5, that is 20. And that is the correct answer for this problem. The number of elements in this set Z is set of all complex numbers of this form A plus iota V, where A and B are integers, and uh, the modulus of this complex number Z minus 3 plus 2 iota, this is between 1 and 4. Now we know that this inequality, this will represent a region between two circles, one of radius 1 unit, another one of radius 4 unit, and the center of the circle will be at point 3 minus 2. So basically we have to find that how many points are there with integral coordinates. Z is a plus iota b, and a and b, these two are integers. So basically we need to figure out the number of points whose x coordinate as well as y coordinate is an integer, and the points lies between these two concentric circle. Now one simple trick, and you can save significant amount of time in calculation. Here, instead of plotting this circle with center at point 3 minus 2, we are going to shift the origin. That means we are going to use shifting of origin, and will make the center of the circle at origin. Right now, this for these two circles, the center is at point 3 minus 2. So instead of 3 minus 2, we'll make the center of the two circle at origin. Or let us say we'll take this complex number as some other complex number omega. So then it becomes mod omega. The inequality becomes mod omega greater than 1 and less than 4. And now this will represent all the points inside a circle with center at origin and radius, two concentric circle, one with radius 1, other one 4 unit. And because we are shifting the origin by integral coordinates, right? Earlier the center is at 3 minus 2. Now we are making the center at origin. So basically we are shifting center from 3 minus 2 to 0, 0. So both x and y coordinate we are shifting by integral coordinates. So therefore number of points with integral coordinate in this set will not change. So now let us plot these two circles and then try to identify that how many points are there with integral coordinate inside these two circles. So one circle center at origin and radius 1 unit. So that will be a smaller circle. Let us say this is the first one. And the other one will be a circle with center at same point origin, but the radius is 4 units. So this will be a slightly bigger circle. So let us say this is the second circle. This one is the real part of real axis or the x-axis, and this one is imaginary axis. Now, for the bigger circle, the radius is 4 unit. For a smaller one, the radius is 1 unit. Now, between first we'll count all the points which are inside the bigger circle with integral coordinate, and then we'll remove those points which are not inside the smaller circle, right? This inequality will represent regions between these two circles, outside the inner circle and inside the outer circle. Now let us draw different lines. This is y equals to 1 line, the next line y equals to 2 line, and another one y equals to 3 line. Y equals to 4 line will be just touching the circle at this point. So there will not be any points with integral coordinate here. And on negative side also, number of points on these, because the figure is symmetric about x. So number of points on y equals to 1 and minus 1 will be same. Number of points with integral coordinate on 2 and minus 2, these two will be same. And similarly, number of points with integral coordinate on the line y equals to 3 and minus 3, these two will be same. This line is y equals to 1 line. This one is y equals to 1. Here we have y equals to 2 and so on. Now, on this line x-axis, the coordinate of this point will be 4, 0 because the radius of bigger circle is 4. This point will be minus 4, 0. So if I talk about this line y equals to 0 or the x-axis, starting from minus 3, 0, minus 2, 0, minus 1, 0, 0, 0, and in this manner up to 3, 0, right? So on this line, starting from minus 3 up to plus 3, total will have 7 points, right? So number of points on this line, here if I write the answer here or count the number of points with integral coordinates. So on y equals to 0 line, we are going to get 7 points. When this point is 4, 0, so just before that one, you'll have 3, 0. Remember, we need points only inside the circle, not on the circle because there is no equality here. So from minus 3, 0 to plus 3, 0, total there will be 7 points. We are not, at a later stage, we'll remove the points which are inside the smaller circle. First, let us count all the points which are inside the bigger circle. So on y equals to 0 line, we have 7 points. Then on y equals to 1 line, remember this outer circle will be x square plus y square, and this equals to 4 square 16. So if y coordinate is 1, the x coordinate will be root 15. So for this point, the coordinate will be root 15 and 1. And similarly on negative side also minus root 15 and 1. Now again, root 15 is a number bigger than 3. So that means 3, 1 will be inside the circle. Minus 3, 1, this is also inside the circle. So minus 3 up to plus 3, including this point 0, 1, total you have 7 points. And same number of points on y equals to minus 1 line. So that means twice of 7 points on one y equals to 1 line, another 7 point on y equals to minus 1 line, because the graph is the curves are symmetric about x-axis. Next possibility, if I take y as 2, then x square will become 12, x will be root 12. So x coordinate root 12, y coordinate 12. Now again root 12 is bigger than 3, right? Root 9 will be 3, so root 12 is more than 3. That means 0.32 is inside the circle. And similarly minus 32, that is also inside the circle. So from minus 3 up to plus 3, you'll get another 7 points on this line y equals to 2. And finally this line and on y equals to minus 2 also will have same number of points. On y equals to minus 2 we'll get another 7, so therefore I have taken 2 outside here. Now next possibility, if I take y as 3, if y is 3, x will become root 7. Now root 7 is smaller than 3 and bigger than 2, right? So the point 2, 3 will be inside the circle, point 1, 3 is inside the circle, and so 2, 3 and minus 2, 3, right? This point will be minus 2, 3, minus 1, 3, and so on. So from minus 2 up to plus 2, right? Again, I'll repeat, root 7 is less than 3 and more than 2. So the point just inside the circle will be 2, 3, and on negative side, minus 2, 3. So from minus 2 up to plus 2, you'll have 5 points. 5 points on line y equals to 3, another 5 on y equals to minus 3. So these are the number of points with integral coordinates inside the bigger circle. Now we need to remove those points which are not satisfying this condition that modulus is greater than 1. That means the points which are either inside the smaller circle or on the smaller circle. So clearly you can see that there will be 5 such points, right? Those points will be, one will be the origin, and you have other 4 points, 1, 0, 0, 1, minus 1, 0, 0, minus 1. So there are 5 points which are either inside the smaller circle or on the smaller circle, and total we have these many points inside the bigger circle. So the number of points with integral coordinate outside the smaller circle and inside the bigger circle, that will be this number. Now 7, this you can calculate, 7 into 4, so that will be 28 plus 7, 35, plus another 10, 45, minus 5, so that will be 40. So that should be the correct answer for this problem. The right answer for this problem will be 10. And in this question, the important concept was that once you shift the origin by integral number of coordinates, right, instead of minus 3 minus 2, we are making the center of the circle at origin. And that means in place of this complex number, we are writing another complex number omega. So the number of points with integral coordinate will not change, right? And first count, whenever we need number of points with integral coordinate either inside a circle or ellipse, then you just draw a number of parallel lines and count how many lines, how many points are there on y equals to 1 line, 2 line, and so on. So finally we got 45 points inside the bigger circle. 5 points were either on the smaller circle or inside that circle. So our final answer will be 45 minus 5, which is 40, and that should be the correct answer for this problem. Let the minimum value v naught of this expression v equals to mod z square plus z minus 3 square plus z minus 6 iota square, where z is any complex number. This is attained at z equals to z naught. So the minimum value of this expression is v naught, and this expression we are getting when the value of z is z naught. So then the question is, what should be the value of this expression, right? Modulus of square of modulus of this complex number plus v naught square. Now this is a problem on distance formula in complex plane and one interesting property of triangle. Here if you see this expression mod z square plus z minus 3 square plus z minus 6 iota square. Now we know that if I have mod z minus z1, then this is nothing but distance between the complex numbers, distance between the points representing the complex numbers z1 and z2. So if I talk about mod z minus 3, this will be distance between point 30 and the complex number z. Mod z will be distance of the complex number from the origin. And similarly, this third term, mod z minus 6 iota, this will be distance of point z from the point 0, 6, right? 6 iota will be represented by 0.06 on y-axis. So basically here, if I take these 3 points, let us say there is one point A representing origin, another point B, and let us say this point is 3, 0. The second term is z minus 3 square, and another point C representing the complex number 6 iota. So the point will be 0, 6. Now let us say P is a point which is representing the complex number Z. So mod Z is nothing but the length PA, right? Mod Z will be PA. Similarly, mod Z minus 3, this will be length PB, and mod Z minus 6 iota, this will be length PC. Now V is nothing but, now you can see that this V will become mod Z is PA, so mod Z square means PA square plus PB square. The second term will be PB square plus PC square. So this is V. Now we know that if we have 3 points A, B, C and P is a point such that PA square plus PB square plus PC square, this is minimum, then that point P is nothing but the centroid of the triangle, right? So that means here V will become minimum if P is the centroid of this triangle, and from there we can get the value of Z0, right? So these are the 3 vertices A, B, C. So therefore Z0 must be Z1 plus Z2 plus Z3 by 3. That is the standard formula for finding the centroid. So this divided by 3, that will be the centroid Z0. Now here if you add these 3 numbers, 0 plus 3 plus 0 divided by 3, so that will give us 1. And uh, 0 plus 0 plus 6 divided by 3, so that will give us 2 iota. So this is the complex number Z0. Now, this is standard result that you can remember, that PA square plus PB square plus PC square, that is minimum if P is centroid. There is another way of solving this problem also. In place of Z0, you can write, in place of Z, you can write x plus iota y. And using a square completion method also, you can find the least value of this one. That means in place of Z, if we write x plus iota y, then that given expression V, this will become Z square means x square plus y square. Mod Z minus 3 square means x minus 3 square plus y square. And mod Z minus 6 iota square, so that means x square plus y minus 6 square. This is the expression for V. And now you can make perfect square when you can take 3 common from x square term. So you will get x square, and from here you will get 2x. For creating perfect square, you can do plus 1 minus 1. And similarly from y term, you can take again 3 common. So you'll get y square minus 12y, but we have taken 3 common, so minus 4y. For creating perfect square, plus 4 minus 4, and plus from here you will get 9, and 9 plus 36, so that will give us 45. So this is the expression for V. And now using a square completion, you can write this as x minus 1 square first 3 terms, x square minus 2x plus 1. Similarly, 3 times y minus 2 square, and then the constant term will be minus 12 minus 3, so minus 15, 45 minus 15, so that will be 30. So this is the expression for V. Now again you can see that these two terms, they are perfect square, so they will be either positive or 0, right? They cannot be negative because x and y are real numbers. So if this term is always greater than equal to 0, similarly this term is also always non-negative, then clearly you can see that minimum value of this function V or V naught, this is nothing but 30. And the point where this will become minimum, this is uh, if I make x minus 1 0, then x will be 1 and y will be 2. So that means z naught is nothing but 1 plus 2 iota. So using this approach also you can get the value of z naught. But if you are familiar with this result that the point is centroid of the triangle, then directly you can see that z naught will be 1 plus 2 iota. So now V naught is 30, z naught is 1 plus 2 iota, and we need to find the value of this expression. Now here in place of z naught, you can substitute 1 plus 2 iota, and let us call this complex number as some complex number omega. So in place of z naught, when you substitute 1 plus 2 iota, you will find that omega will become 8 plus 6 iota, right? Replace z naught with 1 plus 2 iota, because Z0 will be the centroid of the triangle, or using a square completion method, in place of Z0, we can write 1 plus 2 iota. And after simplification, you will get this complex number omega as 8 plus 6 iota. Now the question is, what is the value of this expression? V0 we have obtained earlier. V0 was 30. And if omega is 8 plus 6 iota, then this is modulus of omega square. So 8 square plus 6 square, that will be 100 plus another 30 square, which will give us 1000. So the correct answer for this problem will be first option. Right. So this was a problem where if you are familiar with this result that the point will be centroid, then directly you can see Z0 and from there you can get V0. Otherwise, in place of Z, you can write x plus iota y, and then you can create perfect square. And perfect squares are never negative. It will be either positive or zero because x and y are real numbers. So least value of V, that is V0, that will be 30, and Z0 is 1 plus 2 iota. Substitute the value of Z0 here and you will find that this complex number omega will be 8 plus 6 iota, and therefore the value of this expression will be 1000, and hence the correct answer for this problem is first option. For all Z belonging to complex number C on the curve C1, which is represented by this equation mod Z equals to 4, let the locus of point Z plus 1 by Z be another curve C2. Then we have to find number of points of intersection between C1 and C2. So basically, the first curve C1 is mod Z equals to 4. So this will represent all the points on a circle with center at origin and radius 4 unit. And if Z1 is a point on curve C1, then we need to figure out what will be the locus of points Z plus 1 by Z. That means if Z1 lies on curve C1, then we have to find the curve on which all these points Z plus 1 by Z will lie. So see, if Z is a point on this circle, right? If mod Z is 4, then we can always take Z in Euler's form as, in Euler's form, complex number Z is R e iota theta. So we can take Z as modulus of Z is 4. So 4 into e raised to iota theta. And for different values of theta, we'll get all the points on this circle mod Z equals to 4. Now, we need the first locus is obviously straightforward. It is a circle. We need to identify the second locus, and then we need to plot the graph of those two and identify the number of points of intersection. So let us say omega is the complex number, which is representing omega is this complex number Z plus 1 by Z, right? Now, if I want to find locus of this point omega, then write omega as x plus iota y, and then we have to find some equation in x and y, right? So if omega is z plus iota z, in place of omega we can write x plus iota y, and z plus 1 by z, z is 4 into e raised to iota theta, 1 by z will be 1 by 4 into e raised to minus iota theta, right? Now e iota theta means cos plus iota sine, so this first term will be 4 into cos theta plus iota sine theta, and the second term will be e raised to minus iota theta means cos theta minus iota sine theta. So this is the complex number x plus iota y. Now we know that if two complex numbers are equal, then their real part as well as imaginary parts are equal. That means the real part x, this will be 4 cos plus 1 by 4. So 4 plus 1 by 4, that will be 17 by 4 cos theta. And similarly, if I equate the imaginary part, then y will be 4 sine minus 1 by 4 sine. So that will be 15 by 4 sine theta. Now clearly you can see that this is parametric equation of ellipse. X equals to a cos theta and y equals to b sine theta. And if I need equation of this ellipse, then you can write cos and sine from here and then square and add. So clearly you can see that you will get x square by 17 by 4 square. This will be cos square theta from this first equation. Let us call this equation 1 and 2. So if I need equation of ellipse in Cartesian form, then separate sine and cos and then square and add. So x square by 17 by 4 square, that will be cos square, and sine square will be y square by 15 by 4 square, and sine square plus cos square, that will be 1. So this is the equation of ellipse that we are getting. right? So this is your curve C2, right? Curve C2 is the ellipse, and because A is more than B, this ellipse will have major axis along x-axis. And the second curve C2, this was the first curve C1, this was mod z equals to 4. Mod z equals to 4 means x square plus y square equals to 4 square. Right, in place of z, if you write x plus iota y, then this is the equation that you are getting. So now we have one circle and one ellipse, and we need to identify at how many points these two curves are going to intersect. So let us plot their graph. The circle is x square plus y square equals to 4. So it will have center at origin and radius 4 unit. This is our x-axis and this one is y-axis. So this is the circle that we are getting. Now for ellipse, you can see that for circle radius is 4 unit, and for ellipse the vertex is at 17 by 4. So it will be passing through this point, right? That will be one point on major axis of the ellipse, one vertex. And this number 15 by 4, this is the point where it will touch, it will intersect y-axis, right? When x is 0, y will be 15 by 4, which is less than 4. So the ellipse is passing through these 2 points, right? Ellipse, the graph of that ellipse will be something like this, right? This is the ellipse that we are getting. And as you can see that these two curves are intersecting at 4 points. The question was that at how many points these two curves will intersect. So clearly these two are intersecting at 4 distinct points, and therefore the number of points of intersection between C1 and C2, that will be 4, and hence the correct answer for this problem is first option, right? So this was you can say an interesting problem where first we had to identify the locus of this point z plus 1 by z, where z is a point on curve C1. So in order to identify that locus, let us say z plus 1 by z is omega. Replace omega with x plus iota y, and then by equating the real and imaginary part, we got these two equations. Now these are parametric equation of ellipse, and in order to get the equation of ellipse, you can square and add these two equations, find sine and cos theta, and then square and add. Finally, we are getting 4 point of intersection between these two curves, and therefore the correct answer for this problem will be first option. Find the number of triangles whose vertices are vertices of a regular octagon. Octagon means a polygon having 8 sides. So we have to find the number of triangles whose vertices are vertices of a regular octagon, but none of whose side is a side of octagon. So this is one interesting problem. And here the important line is that there should not be any common side between the octagon and the triangle. Now see here, if I want to create triangle which do not have any side common with the side of octagon, so basically we have to select 3 vertices, and the condition is that no two should be consecutive, right? For example, suppose if I select points like 1, 3, and then 5. So then we'll get a triangle which has no side common with the octagon. However, if you select any two consecutive vertices, for example, if you select 1, 2, and then 5, so then this side will be common between the triangle and the octagon, right? So there are different methods of solving this problem. One of the methods will be that first we'll count the total number of triangles, and then we'll remove those triangles which have either one side common or two side common, right? Now, finding total number of triangle is not difficult. There are 8 points. All of them are non-collinear, right? No three of these points are collinear. So therefore, total number of triangles that you can create is 8C3. Now let us try finding how many triangles are there which have one side common with the octagon, right? First, I mean, there are 3 possibilities. Either the triangle will have no side common, or it will have one side common, or it will have two sides common. So from the total number of triangle, if I remove those triangles which have either one side common or two side common, then we'll get those triangles which have no side in common. So if we talk about number of triangles having one side common, so for example, let us say if I select point 1, 2, and then the next point we select is this point 4, right? So then there is one side common between the triangle and the octagon, and that side is the side joining these two vertices 1 and 2. So if I need number of triangles having one side common, then we need to select two consecutive vertices, and the third vertex should not be consecutive, right? Now in how many ways we can select two consecutive vertices? So either you can select 1 2 or 2 3 or 3 4, and in this manner up to 8 1. So these are the different ways in which you can select two consecutive vertices, right? So if n1 is the number of triangle having one side common, then n1 will be select any two consecutive side. For example, 1 2 or 2 3 or 3 4 and so on. Once you have selected 1 2, 3 and 8 you cannot select, because then you will get three consecutive vertices and then you have two sides common, right? So 1 2 already selected, and then 3 and 8, these two you cannot select. So now from the remaining four vertices, these four vertices in this example, if I have selected 1 2, then 3 and 8 we cannot select because we need only one side common. So from these four vertices, select any one vertex. So 8 into 4c1. 8 is the number of ways of selecting two consecutive vertices, and then 4c1 is number of ways of selecting any one from these four vertices. So this will be 32. So total there are 32 triangles which will have one side in common. Now let us try to find how many triangles are there which will have two sides in common. Now this one you can very easily see that if I need two sides in common, so then we have to select three consecutive vertices, right? For example, if we select the vertices 1 2 3, or if we select 2 3 4, then we'll get two sides in common. So now how many ways are there of selecting three consecutive vertices? So either you can select 1 2 3, or you can select 2 3 4, or 3 4 5 and so on, to 8 1 2. Right, these are the different ways in which you can select three consecutive vertices. Now clearly you can see that there are 8 different cases. So number of triangles having two sides common, that will be 8. And now our answer will be total number of triangles, this is 8c3, minus the number of triangles having one side in common, minus the number of triangles having two sides in common. 8c3 is 56 minus 40, that will be 16. So that should be the correct answer for this problem, right? So this was a problem where first we had to find total number of triangles, and then we had to remove those triangles which have either one side in common or two side in common. Number of triangles having one side in common 32, number of triangles having two sides in common 8, and therefore number of triangles having no side in common 8c3 minus 32 minus 8, which is 16, and therefore the correct answer for this problem is second option. Find the number of 5-digit numbers greater than 50,000 that can be formed using the digits starting from 0 up to 7, 0, 1, 2, 3, 4, 5, 6, and 7, such that sum of digit at first place and the last place is not more than 8. Now, while solving problems of PNC, you should read the statement very carefully. Here we need number of 5-digit numbers which are strictly greater than 50,000, and that can be formed using these 7 digits, these 8 digits. Sum of digit at first and last place should not be more than 8. Now, let us say the number is on first place you have alpha, then the digits in between x, y, z, and on unit place we have beta. So the condition is that alpha plus beta, sum of digit at first place and last place, this must be less than or equal to 8. Right? Must not be more than 8. So that means the sum should be either 8 or less. Now here first let us see what are the different ways in which we can select alpha and beta. How many different cases we can create. So because we need number greater than 50,000, so on first place we can take 5 or more, right? We cannot take a number which is smaller than 5 on first place. So here I'll write alpha, different possible values of alpha, and then we'll see what are the different values for beta. Remember, alpha is first place, beta is the last place, beta is unit place. We need number greater than 50,000. So obviously alpha cannot be a number which is less than 5. Alpha will be either 5 or 6 or 7. So if alpha is 5, right, what are the possible values of beta? Remember, alpha plus beta should be less than or equal to 8. So beta you can take either 0 or 1 or 2 or 3. We cannot take a number greater than 3 because alpha plus beta has to be smaller than 8. So this is one case. Another possibility will be, let us say alpha is 6. Right? We need number greater than 50,000. So in first place, we can have either 5 or 6 or 7. If alpha is 6, then alpha plus beta less than or equal to it. That means beta will be either 0 or 1 or 2. These are the three possible values. And finally, if alpha is 7, beta will be either 0 or 1. So in first case, we are getting four different cases, right? Alpha 5 and beta 0, 1, 2, 3. Similarly, in next case, we are getting three different cases. And finally, we are getting two different cases when uh, alpha is 7, right? Alpha 7, beta will be either 0 or 1. So these are the number of ways of filling the first and last place. 4 plus 3, 7 plus 2, 9. So there are 9 different ways in which you can fill the unit place and the first place, satisfying the condition that sum of digit is not more than 8 and also the number is bigger than 50,000, right? Now, for remaining three places, there are no restriction. For x, y, z, we can take any value. Total 8 integers are given, starting from 0 up to 7. Total 8 digits are there. So for x, we have 8 option. For y, we have 8 option. And for z, we have another 8 option, right? So 9 ways of filling the first and last place together, satisfying that condition. And then for the digits in middle, x, y, and z, we have 8 options each. But remember, here it is given that we need only those numbers. We need 5-digit numbers which are strictly greater than 50,000. When you take alpha as 5, beta as 0, and xyz also as 0, 0, and 0, then you will get a number which is equal to 50,000. Right? We need numbers which are bigger than 50,000. But when alpha is 5, beta is 0, and here I'm taking all the different possibilities for xyz. So this 8 will mean that x can take any value starting from 0 up to 7. So if I take xyz as 0, 0, 0, alpha 5 and beta also 0, then we are getting a number which is exactly 50,000. We need numbers bigger than 50,000. So that one case we need to remove from here. And many times in JEE Main, if you want to save time, you can do rough calculation. Here you can very easily see that your answer must be odd number, right? 9 into product of these numbers will be even, minus 1 odd. So these two options you can eliminate without doing any calculation. Also, you can see that these two options, they are not very close to each other, right? So, I mean, here this number will be 72 into 64. Now, if I take 80 into 70, I'll get 5600. These numbers are much smaller than that, right? So, I mean, this one you cannot get. 5700 will be much more than this number. 64 into 72. Now, 80 into 70 is 5600. And this is bigger than 5600. So, we cannot have that option also. So, I mean, calculation is not difficult. You can do. But without doing calculation also, in many problems, you can get the correct answer. So because answer is odd number, two options eliminated. This is a number bigger than 5600. Clearly, this is less than that number. So therefore, the correct answer for this problem will be fourth option. So this was not difficult problem. Just take different cases. First alpha, beta, and this was one important point that because one number is exactly equal to 50,000, we need numbers bigger than 50,000. So therefore, we have to do minus 1. You can see that one option is without this minus 1, but that will be incorrect option. So the right answer for this problem is option D. Find the number of 7-digit numbers which are multiple of 11 and are formed using these 7 digits 1, 2, 3, 4, 5, 7, and 9. Now, this is a very interesting problem, and in recent year in JEE Main, there are few PYQ where you need number of numbers which are multiple of 11. So first of all, I mean the condition for a number to be divisible by 11 is that sum of digit at odd place, sum of digit at even place, difference of those two is multiple of 11. For example, if I have this number 25927 and if I want to check whether this is multiple of 11 or not. So first find sum of digit at odd place. At odd place we have 2, then 9 and then 7. Sum of these three digits will be 9 plus another 9, that is 18. And at even place, you have other two digits, 5 and 2. Sum of these two digits will be 7. And now take difference of these two. If the difference is either 0 or multiple of 11, then the number is multiple of 11. For example, here O minus E will be 11, which is multiple of 11. Therefore, this number is also multiple of 11, right? So here we need number of all 7-digit numbers which are formed using these 7 digits, and they are multiple of 11. Now, let us say that the 7-digit number is n, and we have A, B, C, D on even place and alpha, beta, gamma on odd place. So that means, or A, B, C, D on odd place, alpha, beta, gamma on even place. So A, alpha, B, beta, and then we have C, gamma, and then you have D. Let us say this is the 7-digit number that we have. O is representing sum of digit at odd place. So O will be A plus B plus C plus D, and E is representing sum of digit at even place. So E will be alpha plus beta plus gamma. Now here, if I calculate O plus E, then this will be nothing but sum of all these 7 digits. Right? First we'll see what are the digits that we can place at odd place and even places. So O plus E, this will be sum of all these 7 digits. If you add all these numbers, you will get 15 plus another 16, so it will be 31. So this must be sum of all the digits, right? Sum of digit at odd place plus sum of digit at even place. Also O minus E, if I want to make the number multiple of 11, then O minus E, that must be either 0 or multiple of 11. So O minus E will be either 0 or it will be 11 or it will be 22. We cannot have 33 because if sum is 31, difference cannot be more than 31. So these are the different possibility. Now again here, uh, if I add, let us consider the first possibility that O plus E is 31 and O minus E is 0. So if I add these two, 2 into O will become 31, which is odd number, right? So that means O will be 31 by 2, but O is representing sum of 4 digits. So therefore O cannot be fraction, right? And hence we cannot have this case, right? We cannot have O minus E as 0. Now, using similar logic, you can show that O minus E, this cannot be 22 also, because if O minus E is 22 and O plus E is 31, then 2O will become odd number, which means O will be a fraction. So the only possibility is that O minus E must be 11. And now solve these two equations, right? So O plus E is 31, O minus E is 11. If you solve this one, you will get O as 2O will be 42, so that means O will be 21. And if O is 21, E must be 10. Right? Sum of digit at odd place 21, and which will imply that sum of digit at even place will be 10. This is one possibility. However, you can, I mean, instead of taking 11, you can take plus minus 11. Here we should ideally take modulus, but we'll interchange these two. So this will be one case. And another case will be that O is 10 and E is 21. In this case also the number will be multiple of 11. So now we need to consider these two different cases. One case where E is 10, E is sum of digit at even places, so that means alpha plus beta plus gamma. This is 10, this will be one case. And another case will be where O is 10, that means sum of digit at even places will be 10, right? So now we have to see that in how many ways we can select three numbers from there so that sum of those numbers is 10, right? So one possibility is that you can take 1, 2, and if I take 1 and 2, we got 3, we need another 7. So one possibility is that at even places, we can have 1 to 7 and remaining 4 digit at odd place. Another possibility will be instead of taking 1, 2, if I take 1, 3, we need 6, which is not there. Next, we can take 1, 4 and 1, 4, 5. So we can take another 5. So this will be next possibility. 1, 5 will be 6. So we cannot take any other number. Next one, we can start with 2. So if I take 2 and 3, that will be 5. Another 5 will make it 10. So 2, 3 and 5. This is another possibility. We have to pick three numbers from here so that their sum is 10. Right. So 2, 3 and then 5. If I take 2, 4, we need another 4, but we cannot repeat. So this will be the next case. Then 3, 4, 5 will be more than 10. Right? 3 plus 4 plus 5, that will be more than 10. So these are the only three cases that you can get, right? These are the only three ways in which you can select three numbers from here so that their sum is 10. Now let us say n1 is the number of numbers in this case, which are multiple of 11. So n1 will be three cases we are getting, and in each case, these three numbers we can arrange on three even places in 3 factorial number of ways. And remaining four digits you can arrange on four odd places in 4 factorial number of ways. So in this case, you will get 3 into 3 factorial into 4 factorial. 3 factorial number of ways of arranging these three digits, 4 factorial number of ways of arranging other four digits, and three such cases we are getting. So this will be, after calculation, you will get 432 from here. So these are those numbers which are multiple of 11 and for which sum of digit at even place is 10. Now let us consider those cases where sum of digit at odd place is 10. That means a plus b plus c plus d. This one is 10. So now we need four numbers from that set, and sum of those four numbers, that should be 10. So clearly you can see that if I take the first four numbers 1, 2, 3 and 4, then only we can get a sum of 10, and we cannot have any other sum because in this case we are taking the four smallest number. So that means 1, 2, 3, 4 on odd place, remaining three digits on even place. So if n2 is the number of numbers in this case, n2 will be nothing but 3 factorial into 4 factorial. So 24 into 6, that will be 144. So in first case, we got 432 number. In second case, we'll get 144. And therefore, our final answer will be sum of these two. So 130, 144 plus 432, that will be 576. And therefore, that should be the correct answer for this problem. So in multiple of 11, this is the standard process that you need to follow. Find sum of all digits, that will be O plus E. And then O minus E, you have different cases. But for O minus E, we can take only odd value if O plus E is odd, right? Ultimately, when you add these two, then 2O must be even. So if O minus E is either 0 or 22, this will not work. So only possibility is O minus E is 11, or minus 11 also will work. So for that, we have interchanged here, right? So we got O as 21, E as 10, that is one case. Another one, 10 and 21. Now, in first case, alpha plus beta plus gamma 10. So we had to pick three numbers from here so that their sum is 10. We got these three cases. In each case, you can create 3 factorial into 4 factorial number of numbers. Right? These digit at even place, remaining 4 digit at odd place. So in first case, 432. Similarly, in second case, 144. And finally, after adding those two, you'll get 576, which is the correct answer for this problem. Find the number of natural numbers which are lying between these two numbers 1012 and 23421, and that are formed using these digits 2, 3, 4, 5 and 6. Repetition of digits is not allowed, and the number should be divisible by 55. Now in recent year in JEE Main, there are few PYQ where you have to find number of numbers which are multiple of 11 or multiple of 55. So we'll see how to solve these type of problem. Before we attempt this problem, there are few important points. First one is that a number is divisible by 55. 55 is 5 into 11. So a number will be divisible by 55 if it is multiple of 5 as well as multiple of 11. Right? If the number is multiple of these two numbers, 5 and 11, then it must be multiple of 55. Also, a number is multiple of 5 if the digit at unit place is either 0 or 5, but here we do not have 0. All the given digits are non-zero digits 2, 3, 4, 5 and 6. So at unit place we have to keep 5 only, then only it will be multiple of 5. Also, a number is multiple of 11 if the difference of sum of digit at odd place and even place is multiple of 11. Right? For example, let us say if I have let us take a 4-digit number A, B, C, D, and if I want this number to be multiple of 11, then at odd place we have these two digits. Let us say O is representing sum of digit at odd place. So at odd place we have A and C, and these are the digits at different places. D is digit at unit place, similarly C at 10th place, and so on. So at odd place we have A and C, at even place we have B and D. And now if difference of these two, that is O minus E or E minus O, if that is either 0 or 11 or 22 and so on, either 0 or some multiple of 11, then the number will be multiple of 11, right? So also you can notice that here we have to find only those numbers which are lying between these two numbers 1 0 1 2 and 2 3 4 2 1. Now remember, number lying between these two number will be either 4-digit number or 5-digit number. But the smallest 5-digit number that you can create using these 5 digits, that will be 2 3 4 5 6. And this number is clearly bigger than this one. So therefore, here we have to find, there will not be any 5-digit number formed using these 5 digits, which will lie in this interval. So we have to focus on 4-digit numbers only. Also, the smallest 4-digit number will be 2, 3, 4, 5, which is bigger than this number 1, 0, 1, 2. So any 4-digit number formed using these 5 digits will lie in that given interval. So here basically we have to find number of 4-digit number formed using these 5 digits without repetition of digits which are divisible by 55. So as I said, it should be multiple of 5 as well as multiple of 11. Also for multiple of 5 at unit place we must have 5. And for multiple of 11, the difference of these two, sum of digit at odd place and sum of digit at even place, that must be either 0 or 11 or 22. Also you can notice that here uh, O minus E cannot be 11 or 22 from the given digits. You cannot, the maximum value of O minus E you can create is that if I take 5 and 6 at odd place and 2 and 3 at even place. So sum of digit at odd place will be 11, at even place 2 plus 3 5, and their difference is 6. So from the given digits you cannot get a difference of 11 or 22 and so on for O minus E. So O minus E has to be 0, which means that sum of digit at odd place A plus C, and this must be same as sum of digit at even place B plus D. So this is one important relation that we have to satisfy here. Now let us see what are the different numbers that we can create using those 5 digits, because there will be only few numbers. If I need number to be multiple of 5 at unit place, we have to place 5. And now we'll see what are the different ways of filling the 10th place, 100th place and 1000th place. So at these two places, unit place D and 100th place B. So for B, we have number of, first we'll decide for B and then we'll try to satisfy that B plus D, that must be same as A plus C. So for B, the different options will be, we have 5 at unit place. So 5 we cannot keep at any other place because repetition is not allowed. So at 100 place, either you can have 2 or you can have 3 or you can have 4 or you can have 5, right? These are all the 4 cases that you can create. At unit place we have 5 and at 100 place we have 2, 3, 4, 6. Now if I have these two numbers, let us take the first case. If I have 2 and 5 at unit place and 100 place, so their sum will be 5 plus 2, 7. So now we need to pick two numbers from here so that their sum is 7. Now clearly you can see that if you select 3 and 4, you can get a sum of 7. So that means at one place you can keep 3, another place you can keep 4. And remember, two numbers you can create here by interchanging these two. One number 3 4, another number just interchange these two, so that will be 4 3. Similarly, if I have 5 at unit place and 3 at 100 place, so then again their sum will be 5 plus 3 8. Now let us see how we can get a sum of 8 here. So 3 5 we have already used, so the remaining digits are 2 4 and 6. If I take 2 and 6, we can get a sum of 8. So that means here we can place 2, this number will be 6. Again interchange these two, you'll get another two numbers in this case. So next two number 2 6, then 6 2. 5 at unit place, we have to make number multiple of 5. So at unit place, we have to fix 5. Now at 100 place, we have these four options. And in each case, we are trying to satisfy that A plus C must be same as B plus D. So now 4 plus 5, that will be 9. 9 you can create using 3 and 6. So you can have 3 6, another number 6 3. So other two numbers you can get in this case. And finally, if I have 6 and 5, 6 and 5 will be 11. Now, using any two of the remaining three digits, 2, 3, and 4, you cannot get a sum of 11. So that means in this case, you will not get anything. So finally, there are three cases, and in each case, you can get two numbers. And therefore, the number of numbers which are multiple of 55, that will be 6. Right? So this was an interesting problem where first uh, we have to know that number will be multiple of 55 if it is multiple of 5 as well as 11. For multiple of 5, the digit at unit this must be 5 because there is no 0 involved here. And then for multiple of 11, a plus c must be same as b plus d. From there we got three cases. In each case you can create two numbers, and therefore total number of numbers this will be 6. And that is the correct answer for this problem. All the arrangements with or without meaning of the word farmer are written, excluding any words that has two are appearing together. So we are creating only those words in which two are not together, and then these arrangements are listed serially in alphabetical order as they are written in dictionary. So then the question is, what is the serial number of this word, right? So this is an example of dictionary problem. But there is one additional condition that here we are creating only those words in which two are not together, right? We are creating only those words, excluding the word which have two are appearing together. And then we have to find the serial number or the rank of this word farmer in that list. Now, for solving such type of problems, we have to use basic method only. So the given word is FARMER. This is the given word. And here, first if I arrange the letters in alphabetical order, we'll get A, then we have E, F, then you have M and 2R. Now this word is starting with letter F. In dictionary, first you will have words starting with letter A, then E, and then you will get to F. So let us try to find how many words are there which are starting with letter A and do not have two are appearing together, right? So if I fix E on first place, total we have 5 letters and two of them are identical. So total number of words starting with letter A, this will be 5 factorial, that divided by 2 factorial. But this also includes those words in which two are together. So now we have to remove those cases in which two are together. So A fixed on first place. And now if I want to count how many words are there which have two are together, so then we'll count these two letters as one single unit, right? We have one unit of two identical R, and then we have three unit of these three letters, right? So these four units you can arrange on four places in 4 factorial number of ways. And also there is only one way of arranging these two R, right? Even if you interchange these two, because the letters are identical, you'll get only one word from there. So the number of words starting with letter A, that is 5 factorial by 2 factorial. But out of those many words, there are 4 factorial words which have 2 are together. So therefore, we have to remove those cases. So now uh, 5 factorial by 2 factorial, 60 minus 24. So total there are 36 words starting with letter A, and those words will not have any two are appearing together. Now after A, the word formation will begin with letter E. Now with E also, we have to do the same thing. Words starting with letter E that do not have two are together. So first we'll count total number of words starting with letter E, and then we'll remove those words which have two are together. So starting with E, again if you fix E on first place, 5 factorial by 2 factorial. If two are together, count them as one single unit. So then we have 4 factorial, and because the letters are identical, there is only one internal arrangement of those two are. So with E, you will get another 36 words, and all these words will come before this word. So first you have A, then you have E, and then after that, the word formation will begin with letter F. So now let us see how many words are there which are starting with letter F. Now with F on next place you need A, and in alphabetical order also you will get A only. So on first place we have F. On second place we got A because that was in alphabetical order. On next place you need R, but before getting R you will get E and M. So first you have FAE, then you will have FAM, and then the word formation will begin with FAR, right? Now with FAE again, how many words are there? So if I fix three letters, remaining three letters will be MRR. And if I have to ensure that two R are not together, so I mean either you can do that total, you can create 3 factorial by 2 factorial number of words. And if two R are together, then you can create two words. So this will be nothing but 1. Or directly also you can see that if you want to arrange these three letters and uh, two R should not be together. So that means M must be in middle and R on either side. Similarly from FAM also you will get the same thing, right? M we have to keep in FAM. So you are left with ERR. So E in middle and the remaining two on either side. Or you can say total, you can create 3 factorial by 2 factorial. And if two R are together, then two words. So therefore only one word here. And then after FAM, the word formation will begin with FAR. So now the first three letters FAR. On next place we need M. Before getting M, you will get E. And with FARE, how many words are there? And now remember, you cannot have two R together because one R is here. So now two letters left on two places. You can arrange them in 2 factorial number of ways. After that, you will get FARE, and after E will get M. Other two letters are in alphabetical order, right? So the rank of this word will be when this word will come on, sum of all these numbers plus 1. So when you add all of these, 72 plus 4, 76, and plus 1, because these many words we have formed before getting to this word. So the rank of this word will be 77, and that should be the correct answer for this problem. So in dictionary problem, you should always know the basic method, because in these type of problem using shortcut technique you cannot solve such problems. So first we start, I mean this word was starting with F, so first started with A, and only those words which have two are not together, right? So total minus two are together. Same thing for A, then E. After that, A we got on second place because that was in alphabetical order, FAE, FAM, and so on. And this plus 1 is important because these many words we have formed before getting to this word. So the rank of this word will be sum of all those numbers plus 1, which is 77. And that is the correct answer for this problem. If all the words with or without meaning formed using the letters of word Kanpur are arranged as in a dictionary, then we have to find the word on 440th place. Now in JEE Main, there are number of PYQs on dictionary problem, and in recent year you will find that instead of finding the rank of the word, they will ask to us to find word on a given place. For example, here we need the word on 440th place. Now the given word is this one. By rearranging the letters of this word, total you can create 6 factorial, 720 words, right? All these letters are distinct. So total 720 words you can create. Now we have to find the word on this. When you arrange all those words in alphabetical order, we have to find the word on 440th place. Now the trick to solve these type of problem is first we have to get close to this number 440, and then we can use something called 1 2 3 method to find the word at this particular place. Once we get close to this number, then it becomes slightly tricky that which word will come on this place. So for that we'll use 1 2 3 method. We'll discuss what is this 1 2 3 method of solving such type of problems. So see here, when you arrange the letters in alphabetical order, the first word will be A, K, N, and then you have P, R, U. Out of all those 720 words, this will be the first word. Now, first we should get close to the number 440. So all those words which are starting with letter A, that will come in the beginning, right? So words starting with A, if I fix A on first place, you have 5 distinct letters which you can arrange in 5 factorial, that is 120 different ways. After A, the word formation will begin with letter K. With K, you can get another 5 factorial, which is another 120. 120 plus 120, this will be 240. So first 240 words will be either starting with A or starting with K. After that, word formation will begin with letter N. within another 5 factorial, that is 120, 240 plus 120, that will be 360, right? So the word on 360th place, that will be the last word starting with letter N. Now after that, word formation will begin with letter P. We have to get close to 440. We have reached till 360. Now after N, the word formation will begin with letter P. Now with P, if you make another 5 factorial, then you will cross this number 440. 360 plus another 120 will make it 480. We need the word on 440th place. So the word on that place will be starting with letter P, right? So now P fixed on first place, but on second place, first you'll get PA and then PK, PN and so on. So with PA, you can create 4 factorial, that is 24 words. 360 plus 24, this will be 384. So the word on 384th place will be the last word starting with PA, right? After PA, we'll have words starting with letter PK, right? First PA, then you'll get PK. With PK, another 4 factorial, another 24, 384 plus 24, that will be 408. We are getting very close to this number 440. PK, then we have PN. With PN, you can create another 4 factorial, 24. So 408 plus 24, that will be 432. And now after this, after Pn, the word formation will begin with Pr, right? So word on 433rd place, right? 420 words you have created using Pn. After Pn, you will get Pr. So word on 433rd place, that will be starting with these two letters P and R. Now if I ask which word will come at this particular place, then these two letters and remaining 4 letters in alphabetical order, right? The first word starting with PR will come on this place. So if I need first word starting with a given set of letters, then those letters followed by other letters in alphabetical order. So that means we have PR, and then you have A, K, NU. This is the word on 433rd place. Now you can see that by rearranging these 4 letters, you can create 24 next word, and therefore the first 2 letters will be PR. Now you can see that if I interchange these 3 letters, we can create another 6 words. So starting from 433, right, 432 plus another 6, that will be 438. So on 438 place also you will have words starting with letter PRA, right? And in fact, I mean 432 plus another 6, so 438. Now the word on 438 place, that will be the last word starting with PRA. 433rd, first word starting with PRA. 438, last word starting with PRA. So if I need last word, we can arrange the remaining letters in reverse order. That means you have U, and then you have N and K. Now on 439th place, you will have after PRA, the word formation, I mean first you have PRA, then you will get PRK, right? First 2 letters will be PR, then PRA, 6 words. Now after PRA, you will get P, then you have R, and after A, K, right? So this will be the word on 439th place, starting with PRK. Now the first word starting with PRK, that will be PRK, and then remaining 3 letters A, N, and U in alphabetical order. So here you can write A, then N, U. And now this 1, 2, 3, I mean, you can see the next word very easily, that just interchange these two, you will get the next one. But here I'll explain that how you can get all the other words. For example, instead of 439, if the question was find the word on, instead of 440, if it was to find 442 or 443, then how to get that particular word? So for that, you can use this 1, 2, 3 method, because with letters, it becomes difficult to see that which letter will come first and which one will come next. But with numbers, you can very easily see that next 6 words will be starting with PRK. Now by arranging these 3 letters, you can create another 6 words, right? So the first one is this one, 1, 2, 3. Next one will be 1, 3, 2, right? If I have a given, if I have these 3 numbers 1, 2, 3, so the smallest number will be 132. Next smallest one will be 132. Then you have 213. Then you will have 231. Then 312, and then 321. So the next 6 words will be in this order, right? The first one is 1 is representing A, 2 is representing N, and 3 U. So next one will be 1, 3, 2. That means you have P, R, K, and then you have 1, 3, 2. That means A, U, N. Right? If I need the next one, 441, then just use that same method. 1, 2, 3, 1, 1, 2, 3, 1, 3, 2, then 2, 1, 3. 2, 1, 3 means first three letters P, R, K. This is fixed. 2, 1, 3 means you have N, A, U. Next one will be N, U, A. And then you have 2, 1, 3, 3, 1, 2 and 3, 2, 1. Right? So using this method, you can very easily see the next set of words. Here we are interested in word on 440th place. So that will be PR and then you have KAUN. Right? So therefore, here the correct answer will be PR and then you have KAUN. So the second option. Right? So this was a very interesting problem. And in dictionary problem, I mean, in recent year, there are a few PYQ where you have to find the word on given place. First, get close to that number. And then once you are very close to that number, you can use this method, right? Because numbers, with numbers, it is very easy to see that which number is the smaller one, which one is the next bigger one, and so on. So for this problem, the correct answer will be option B. If all the 6-digit numbers of this form x1, x2, x3 up to x6 with the condition that x1 is less than x2, x2 is less than x3 and so on to x6, they are arranged in increasing order. So the smallest number is first, then the next bigger one and so on. So the question is that we have to find the sum of digits in the 72nd number, right? We have to find sum of digit in this number. Now, this is another problem on the concept of dictionary problem. Not exactly dictionary problem, but based on a similar concept that we are arranging all of these 6-digit numbers in increasing order. Then we have to find then which number will come at this place, right? Once we get the number at 72nd place, then the question is we need sum of the digits in that number. Now, see here it is given that we have to arrange these numbers. I mean, this number is x1 is less than x2, x2 less than x3, and so on. Now, the digits that we can use is these are all the digits starting with 0, 1, 2, 3. Then you have 4, 5, 6, 7, 8, and 9. These are the 10 digits that we can use for creating those numbers. Now, once you decide that which digits you are selecting, right, the number will be fixed because we have to arrange those digits in increasing order. For example, let us say if you have decided that uh, if you have decided that we are using these 6 digits, so then there is only one number that you can create using these 6 digits, right? We have to arrange all these digits in increasing order. So the number will be 1, then followed by 2, 3, 4, 5, and 6, right? So let us see which number will come at the 72nd place. I mean, if we talk about the first number will be this number. You have 1, and then you have 2, 3, 4, 5, 6. Remember, we cannot use 0 here. 0, I mean, we cannot use because we have to arrange the digits in increasing order. So if I have 0, we have to place 0 on first place. But the moment you place 0 on first place, the number is not a 6-digit number, right? So here we have to create only those numbers which are formed using the non-zero digits. And you cannot place 0 after 1 because then you will not satisfy this condition, right? So the first number will be this one. Similarly, the second one will be you have 1, 2, 3, 4, 5, and last digit 7, and so on. So in this manner, the question is find the number on 72nd place. And once you have this number, then we need the sum of digit in that number. So see here, all the numbers which are starting with digit 1, that will come in beginning, right? So we have to figure out that how many numbers you can create which are starting with digit 1. Remember, we have to create 6-digit number. If I fix 1 on first place, then we have to select 5 more digits. And 1 is fixed on first place, 0 we cannot use. So that means we have 8 digits left, right? From the remaining 8 digit, starting from 2 up to 9, you can select any 5 digit. And remember, once you decide that these 5 digits we have selected, there is only one way that you can arrange those digits. because x1 has to be smaller than x2, x2 less than x3, and so on. We have to follow this pattern. So the number of numbers starting with digit 1, that will be nothing but 8c5. 8c5, after calculation, that this will give you 8 into 7. 3 factorial and 6 will cancel. So 8 into 7, 56. That means the first 56 number will be starting with 1, right? And if I talk about the number on 56th place, then it will be the last number starting with 1, right? The biggest number starting with 1. So the biggest number starting with 1 will be, we have 1 here, and then 9 on unit place, and then you can just take the remaining digits. So 8, 7, 6, and 5. This is the biggest number starting with 1, right? Because remember, we have to arrange those digits in increasing order. So there is only one way in which you can arrange those digits in increasing order. So this is the 50, this is the number on 56th place. We need the number on 72nd place. So after 1, the number formation will begin with 2. Now with 2, how many numbers you can create? So again, 2 fixed on first place. And remember, if 2 is on first place, we cannot use 1 also, right? Because once you decide that first digit is 2, then the next digit has to be bigger than 2, right? So that means 2 fixed on first place, 0 and 1 you cannot use. So now only 7 digits are left. And from those 7, if you select any 3, then you can create, sorry, if you select any 5, right? 2 on first place, and then for remaining 5, 7c5, right? So these many numbers will be there starting with the digit 2. Now 7c5, this is 21, and 56 plus 21 will make it 77. So, and we need the number on 72nd place, right? So therefore here 7c5, another 21 will make it 77. So we have to see that uh, how many are there starting with 2, 3, right? Because if I consider all the numbers, then we are getting a number which is more than 72. So, I mean, first you have numbers starting with 2, 3, then you will have 2, 4, and so on. So now let us see how many numbers are there which are starting with the digit 2, 3, because those numbers will come first, right? First you will have 2, 3, then 2, 4, and so on. So with 2, 3, if I fix 2 and 3 on first 2 places, now only 4 place left, and 2 and 3 we have used, 0 and 1 we cannot use, so 6 digit left. 6 digits left, and we have to select any 4, so this will be 6c4, which is 15. And now 56 plus 15 will make it 71. That means the number on 71 place, this will be the last number starting with 2, 3. And again, if I need the last number starting with 2, 3, you can have 9 on unit place, then 8, 7, and so on. The last number starting with 2, 3 will be 2, 3, and then you have 9, 8, 7, and 6. And on 72nd place, you'll have first number starting with 2, 4. Right, because we have created all the numbers starting with 2, 3. So on 72nd place, we'll have first number starting with 2, 4. The first number starting with 2, 4 will be 2, 4. And then the next the smallest numbers in increasing order. So 2, 5, 6, 7, 8. This will be the number on 72nd place. Now the question is, what is sum of digit in that number? So if you add all of these, you'll get 15 plus 10, 25, plus another 15 plus 6 plus 4, 10, 25 plus 7, that will be 32. So that is sum of all these digits, right? So this was a very interesting problem where because we have to satisfy this condition that digits are in increasing order, so simply we have to select the digit. Once you select a given set of digits, there is only one number that you can create using those digits. So this is the number on 72nd place. Sum of the digits in that number is 32, and therefore that should be the correct answer for this problem. Some couples participated in a mixed double badminton tournament. If the number of matches played so that no couple played in a match is 840. So then we have to find that how many participants were there in that tournament. Now, mixed double means that in a single match there will be 4 players, right? uh, 2 players in one team, another 2 player in other team. And also mixed double means out of those 2 players, one will be male, other one female, right? So let us say that total there will be n number of couples, and it is given that the total number of matches, this is 840. So it will see if there are n couples, how many matches we can have in terms of n, and by equating that with 840 we can get the value of n. Also remember, we need total number of participants. So if there are n couples, the number of participants will be 2 into n, right? Now let us say the different couples where one is x1 y1. Similarly we have x2 y2, right? x3 y3. We'll write few more x4 y4, and in this manner up to xn yn. Let us say these are the n couples. Now see here, if no couples are participating in a match, right, then in every match you'll have four players, and all those four players will be from different couples, right? You cannot have same couple playing in any match, right? So, and because it is mixed double, so total we need four players. So let us say from these n number of couples, we are selecting any four couple. So that can be done in NC4 number of ways, right? First we'll select four couples, and then from those couples we'll select one person. So then we can ensure that in no match two couples are playing together, right? So NC4, we are selecting any four out of these n couples. Let us say you have selected x1 y1, x2 y2, x3 y3, and x4 y4. Remember, we are not selecting players using NC4. We are selecting any four out of these n couples. Now, once you have selected these four couples, you have to select two male and two female, right? So let us say these are the four male, x1, x2, x3, and x4. So select any two from these four. Maybe you have selected x2 and x4, right? These two male you have selected. So then you cannot select y2 or y4, because in the same match we cannot have a couple playing together or against each other. So once you decide that these two male you have selected, x2, x4, the other two female must be y1 and y3, right? So for NC4, number of ways of selecting any four out of these n couples. Then for C2, number of ways of selecting any two male, or you can select female also. So for C2, number of ways of selecting any two male. And once you have decided, you have selected x2 and x4, the other two female must be y1 and y3. So there is only one way of selecting female. Now remember, between these four selected players, right, these are the players that you have selected, x1, x4, y1 and y3. So clearly you can see no couples have been selected. Now between these two also you can create two different matches. One possibility will be that you have x1, y1 playing against x4, y3, right? You can combine x1, y1 in one team, x4, y3 in another team, or you can have x2, y3, right? That will be one team, and another team will be x4, y1. So once you select these four players, ensuring that no couples have been selected, out of those four players, there are two male, two female. So you can create two matches among them, right? So this will be the total number of matches, and this is given as 840. And now we have to solve for n. NC4, this will be n factorial by 4 factorial n minus 4, so that you can write as n, n minus 1, n minus 2, n minus 3, and then n minus 4 you can cancel from numerator and denominator. In denominator we have 4 factorial, 4c2 will be 6 into 2, and this is given as 840. So now from here we need to get the value of n. So n, n minus 1, n minus 2, n minus 3, and on right hand side 12, so you'll get 2 from here, and 840 you can further break this. So when you write this as product of consecutive integer, you will get 8, 7, 6, and 5. Remember, we do not have to create a biquadratic equation and then solve. On left hand side, we have 4 consecutive integer. Right hand side, you can split as product of 4 consecutive integer. When you write 840 in terms of its factors, and also 1, 2 from here, so then finally you will get this number, right? And by equating the corresponding term, you can clearly see that n must be 8. But remember, we had to find the number of persons and not number of couples. So if there are n couples, the total number of persons will be 16. So that should be the correct answer for this problem. Right, so this was one interesting problem where, first we have to see that in every match there are four players involved. and none of them are from the same couple. So first select any four out of those n couples, and then four male, four female, select any two male. Once you decide these two males have been selected, for female there is no option because y2, y4 you cannot select. So for selecting female, only one option. And once you have these four pairs, you can create two matches among them. So finally, this was the equation. And after that, it is calculation only. N is 8, so therefore number of pairs that will be 16. And that is the correct answer for this problem. Find the number of triplets XYZ where XYZ are distinct non-negative integers satisfying this condition that their sum is 15. X plus Y plus Z, this is 15. Now, sometimes in JEE Main, you'll find that there are problems for which you can get the correct answer without actually solving the problem, simply by looking at the options carefully. This is one of those problems. So first we'll see how you can get the correct answer for this problem without actually solving this one, and then we'll see the proper method of solving this problem. So see, the given equation is x plus y plus z, this equals to 15. And the question is that in how many different ways you can select x, y, z so that they are non-negative integer, means they are either positive integer or 0, and their sum is 15. So for example, one possibility will be that let us say x is 0, y is 1, z is 14. Or if you want, let us say x is 1, y is 2, z is 12, and so on. Now remember, here we are talking about number of different triplets. So the triplet XYZ is different from the triplet YXZ and so on. So if I have one solution as 0, 1, 14, you can get three factorial number of solutions from here by arranging these three numbers. Right, one solution is 0, 1, 14. So next one will be 0, 14, 1. Next one will be 1, 0, 14 and so on. So in how many ways we can arrange this one? 3 factorial. In how many ways we can arrange the next solution? Another 3 factorial. So any general solution you get, let us say there is one solution alpha, beta, gamma, and alpha, beta, gamma, they are distinct numbers. So you can arrange those in 3 factorial, that is 6 different ways. That means whatever answer you are getting, it has to be multiple of 6 only. Now there is only one option which is multiple of 6. 136 is not multiple of 6. This one is also not multiple of 6. Only this fourth option is multiple of 6. And therefore, that should be the correct answer for this problem, right? So this will be the objective approach of solving this problem when the options are given, because our final answer has to be multiple of 6. Only one option is satisfying that condition, and therefore that should be the correct answer. Also, the proper method of solving this one will be that first you can find the total number of solution using the standard formula, and then we can remove those solutions in which all the three variables are same or any two variables are same. So let us say if n1 is the total number of solution of this equation without any restriction. Here the restriction is xyz must be distinct. So first let us find the total number of solutions. So that will be number of ways of distributing 15 distinct objects among 3%, and non-negative means each person can get 0 or more. So 15 plus 3 minus 1, C 3 minus 1. This will be total number of solution without any restriction. So that is 17C2, 17 into 8, that will be 136. So this is total number of solution. Remember, we need only those solution in which x, y, z are distinct. So now there are two cases which we have to remove. One case is where all the three variables are same. X, y, and z, all three are equal. So if x, y, z all three are equal and x plus y plus z is 15, there will be only one case here that x, y, and z, all of them are 5, 5, and 5. And another case that we have to remove is second case when any two of the three variables are same, right? That means x and y, those two are equal and is different from z. Let us take one example, this one, and then we'll see how to arrange those. So if x and y are equal and is different from z, the equation will be 2x plus z, this equals to 15. And now the different values of x that you can take is it will be either 0 or 1, 2, 3, 4. 5 we cannot take because if we take x as 5, z will be 5, that we have already considered earlier. So then next one you can take 6, then 7, and you cannot take x as 8. In that case, z will become negative. So these are the 7 different solutions we are getting, right? So if n2 is the number of solution where any two variables are same and is different from z, so one solution will be, for example, x is 0, y is 0, z is 15. Now in how many ways we can arrange these three numbers? So obviously 3 factorial by 2 factorial, right? So corresponding to this one solution, you can get 3 different solutions. Similarly, corresponding to next one, you can get another 3 and so on. So 7 cases, each one will give us 3 solutions. So that means 7 into 3, 21. So here, if I use that proper method, then total number of solution we got 136 minus there is one solution where all 3 variables are same, and there are 21 other solution where any two are same and is different from the third one. So 136 minus 22, that will be 114. Right, so that will be the proper method of solving this one. But as I said earlier, that because the answer has to be multiple of 6, only one option is satisfying that condition, and therefore that will be the correct answer for this problem. So the right answer for this problem is option D. Let ABC denote the outcome of 3 independent rules of a fair tetrahedral die. Tetrahedral die means you have 4 faces, and fair tetrahedral die means that chance of getting each face is same, and the different faces are marked with 1, 2, 3, and 4. The question is that if this quadratic equation ax square plus bx plus c equals to 0 has all real roots, the probability of this thing is m by n, where m and n, these two are co-prime numbers. That means there is no common factor between m and n. The greatest common divisor or the HCF of m and n, this is 1. So then we have to find the value of m plus n. So basically the problem is that we have to find the probability that this quadratic equation will have all real roots. If that probability is m by n, then we need to find m plus n. Also, in this quadratic equation, the unknowns a, b, and c, these are obtained by throwing this tetrahedral dice, and on that dice, the different possible outcomes are 1, 2, 3, and 4. So let us say A is the set which contains these 4 elements 1, 2, 3, 4. So here if I talk about sample space or the number of different quadratic equations that you can create. So for A we have 4 options, and same thing for B and C, right? In this quadratic equation ax square plus bx plus c equals to 0. For coefficient of x square, that is A, we have 4 options. Either you can get 1 or 2 or 3 or 4. And same thing for B and C. So using multiplication rule, the number of quadratic equations will be 4 into 4 into 4, which is 4 raised to 3. So these many quadratic equations are possible. Now we have to find the favorable cases. Favorable case means we have to find that how many quadratic equations will be there, which will have all real roots, right? Both the roots must be real. So we know that condition for real root is that discriminant must be non-negative, right? It should be either positive or 0. Then we can get real roots for a quadratic equation. So here the condition will be for favorable cases b square minus 4ac, this must be greater than or equal to 0. And now we have to see that in how many different ways we can select a, b, c so that this becomes non-negative. Now from here it is difficult to see the different cases, so we can rewrite this equation as we can take AC on other side, and that means we can say that A into C, this must be less than or equal to B square by 4, right? 4AC will be, B square should be greater than 4AC, so that means B square by 4, that should be more than AC or AC less than this number. And now we'll take different values of B and we'll see in how many different ways we can select A and C so that we can satisfy this condition. And remember, ABC can be any number from 1 to 4. So first we'll take different values of B, and then we'll see what are the different cases for AC, and from there we can get the number of favorable cases. So on one side we'll write different possibilities for B, and on other side we'll write the ordered pairs AC. So because it is tetrahedral dice and the different faces are marked 1, 2, 3, 4, So for B, we have these four options. Either B will be 1 or 2 or 3 or 4. Right? These are the four possible values for B. Now remember, if B is 1, AC should be less than 1 by 4, and A and C also we have to select from here only. So the minimum product that you can create for AC will be 1 when A and C both of them are 1. So in this case will not get anything. Right? If B is 1, then you cannot make a quadratic equation with real roots because discriminant will be negative. If I take B as 2, then the condition will be, from here you can see that if B is 2, AC must be less than or equal to 1. So that means there is only one possibility that A is 1 and C is 1. Right? Only when both of these A and C, these two are 1 and 1, then AC will be less than, AC will be equal to 1, and we can satisfy this condition. Similarly, if I take B as 3, then the condition that we need to satisfy is that AC should be less than or equal to 9 by 4. 9 by 4 means 2.25. So A into C, that should be less than or equal to 2 point something. So one possibility is we can take A and C as 1, 1. Another possibility, A is 1 and C is 2. Next possibility, we can have 2, 1. Right, so these are the three possibility. We cannot make 1, 3 because in that case, AC will become more than 2.25. And finally, the last case, if B is 4, AC should be, if B is 4, then if I substitute that value here, so A into C, this should be less than or equal to 4. And now we have to see that in how many different ways we can select A and C so that this will be either less than or equal to 4. So if I take A as 1, then you can have, starting with 1, 1, we can have 1, 1, 1, 2, 1, 3, and then 1, 4. These four cases you can get if A is 1. Similarly, if I take A as 2, then we have 2, 1, 2, 2. We cannot make 2, 3 because in that case we cannot satisfy this condition. If I take A as 3, then we have 3, 1. We cannot take 3, 2. And finally, we can have 4, 1. So these are the different cases if B is 4. Right? These are the different possibilities for AC. Now, here we are getting one case. Then in this one, we are getting 3. And finally, in this last one, we are getting 4 plus another 4. So that will be 8, right? So that means here total number of cases, I mean, if you count all these different cases, you are getting 12 different cases. So those are the favorable cases, right? Now we have to find the probability that this will have uh, all real roots. So probability is nothing but number of favorable cases by total number of cases. So here we are getting 12 favorable cases. There are 12 quadratic equations for which discriminant will be non-negative and therefore they will have all real roots. And total number of cases, this is 4 raised to 3. You can cancel one 4 from here. So this becomes 3 by 16. Right? This will be the probability. This is not the final answer. This will be the probability. Let us say E is the event that we have all real roots. So this is probability of E. And clearly you can see that there is no common factor between these two numbers. So now we can write the answer. The probability is m by n. So that means m must be 3, n must be 16. So m plus n, this will be 3 plus 16, which is 19. So that should be the correct answer for this problem. Right, so this was a problem where we have to, first use this condition that because it has all real root, discriminant must be non-negative. So it will be either positive or 0. And then write the given condition in this form that A into C, this is less than or equal to B square by 4. And from there you can see that for different values of B, what are the different possibilities for AC. So we got 10 favorable cases, sorry, 12 favorable cases, total number of quadratic equations 4 raised to 3. So therefore probability 3 by 16, and hence m plus n, that will be 19, and that is the correct answer for this problem. An unbiased die means chance of getting each face is same, marked with -2, -1, 0, 1, 2, 3 on different faces, is thrown 5 times. We have to find the probability that product of outcome is positive number. So this is a problem where we have to find that in how many different ways uh, we can make the product of 5 numbers from here positive. Also here if we talk about number of elements in sample space, that total number of possibility. So because we are throwing the dice 5 times, for first throw we have 6 options, any one of these 6 numbers. For second row, again we have 6 options and so on. So right, for all the 5th row, we have 6 options each, and therefore the number of different possibilities will be 6 raised to 5, right? That will be the number of elements in sample space. Now we have to find that in how many different ways we can make the outcome positive, right? Now, as you can see that here we have 3 positive number and then there are 2 negative numbers. If we need positive outcome, then there are different possibility. One possibility is that if I make all the 5 outcomes positive, then their result will be positive, then their product will be positive. So this is one case. If I get positive number in all 5 throws, then the product will be positive. Another possibility will be that if any 2 outcomes are negative, if we have even number of negative outcomes, then also we can make product positive. So any 2 outcome, they are negative, and the remaining 3 outcomes, they are positive. This is another possibility. And finally, the last possibility will be that any one outcome is positive and remaining all 4 outcomes, they are negative. So now we have to see that in how many different ways we can do this one. So, and then obviously let us say E is the event that all outcomes are positive. So probability of A, this will be number of favorable cases divided by total number of cases. As we have discussed earlier, total number of cases, this is 6 raised to 5, right? Because for each of the 5 outcomes, we have 6 possibility. Now let us talk about number of favorable cases. So favorable cases means these 3 cases, right? One case where all 5 outcomes are positive. So if all 5 outcomes are positive, for first outcome we have 3 options. We can take any one of these 3 positive number. For next outcome, again we have 3 options. So in this case, you'll get 3 raised to 5 number of favorable cases, right? All 5 outcomes are positive. So first one is positive, 3 options. Next one is positive, another 3 options, and so on. Second possibility is that any 2 are negative and the remaining 5 are positive. So first select any 2 outcome, right? 5C2. This will represent the different, out of 5 outcomes, you can make any 2 negative. So 5C2 is the number of ways of selecting those 2 outcomes, which will be negative. And the remaining 3 outcomes, they will be positive. Now, negative also you can make in 2 different ways, right? For example, let us say first 3 are positive, next 2 are negative. So what is the possible, in how many ways we can make first 3 positive? So first one positive, 3 option, next one positive, another 3 option, next one positive, another 3 option, and 2 outcomes negative, right? So fourth one negative, 2 option, and fifth one negative, another 2 option. So these are the number of cases in this second case, right? 3 cube into 2 square. 3 cube into 2 square, that will represent this particular case that we have first 3 positive, next 2 negative. And you can arrange this in different ways. So this 5C2 is representing the number of ways to arrange those outcomes, right? Again, I'll repeat this point. 3 cube into 2 square. This is number of ways of getting first 3 outcome positive and next 2 negative. First one negative 3, next one, first one positive 3, next one positive, another 3, and so on. And 5C2 is the different ways to arrange these plus minus sign, right? If first 2 were negative, next 3 positive, still will get the positive outcome. So 5C2 is representing that thing. And similarly, next case, 5C1 or 5C4, maybe 5C4 and 5C1, those two will be same. So select any 4 outcome, those 4 will be negative, and the fifth one will be positive. So 5C4 is for selecting any 4 outcomes, and those 4 are negative. For negative, we have 2 options. Let us say, for example, in this case, first one is positive. So for that, we have 3 options. Next one is first one positive, 3 options. Next one negative, 2 options. Right, next 4 negative. For each one, we have 2 options. So 2 raised to 4. So these are the number of favorable cases, or the number of ways in which you can get a positive product, right? All 5 positive, 3 positive, 2 negative, and then 1 positive, 4 negative. And now you can simplify this one. Once you take 1 3 common, then in denominator you can have 2592, and when you simplify this, you will get 521 in numerator, right? So after calculation, you will get this number, and therefore the correct answer for this problem will be second option. So this was a problem where, I mean, you have to consider these three possibilities. If I need positive product, either all five positive, three positive, any three positive, and two negative. This one is representing those different cases. And similarly, last one, any one positive, remaining four negative. And then probability is number of favorable cases by total number of cases. So after simplification, we'll get the second option, and that is the correct answer for this problem. If the numbers appeared on the two throws of a fair fair dice means chance of getting each face is same, and the numbers are alpha and beta. Then we have to find the probability that this quadratic expression x square plus alpha x plus beta, this is greater than 0, right? This one is positive for all real values of x. Now we know that a quadratic expression is always positive if coefficient of x square is positive and the discriminant is negative. That means if I have this quadratic expression ax square plus bx plus c, and if this is greater than 0 for all x, so for that the condition will be that coefficient of x square must be positive and the discriminant must be negative. Coefficient of x square positive means we'll get upward parabola, and d negative means it is not touching or intersecting the x-axis. So in that case, it will be always positive. So here basically, when we are throwing two fair dice, so obviously the number of elements in sample space, this will be for first die we have 6 options, right? And for second die again we have another 6 options. So the number of elements in sample space, this will be 6 square, or the number of different quadratic expressions that you can create here for different values of alpha and beta. For alpha we have 6 value, for beta another 6 value. So number of different quadratic expressions, this will be 6 square. Now we have to find that how many quadratic expressions are there which will be always positive, right? This should be greater than 0 for all real values of x. Now here you can see that coefficient of x square is 1. So the first condition is satisfied. Now we need to satisfy the second condition, that discriminant should be negative. Discriminant will be alpha square minus 4 beta. So this should be less than 0, right? Alpha square minus 4 beta, that should be less than 0. So from here you can say that beta must be greater than alpha square by 4, right? This is the condition that we have to satisfy. Beta must be more than alpha square by 4. So now let us take different values of alpha and then see what are the different values of beta that will satisfy that condition, right? So on one side we'll write values of alpha, and on other side we'll write the corresponding values of beta, satisfying the condition that beta is more than alpha square by 4. Also remember that alpha and beta, this will be any one of these first six natural numbers, right? Because when we are throwing a dice, we can get only these numbers. So let us start with alpha equals to 1. On one side we have alpha, another side beta. And for these type of problem, we have to create the table and then see the favorable cases. So if I take alpha as 1, beta should be more than 1 by 4. So you can take any value of beta starting from 1 up to 6. So these are the 6 different cases. Similarly, if I take alpha as 2, and we have to satisfy that beta is more than alpha square by 4. So now if I take alpha as 2, then beta should be greater than 1, right? So the numbers which you can take is, you can take either 2, 3, 4, 5 or 6. We cannot take beta as 1 because beta should be greater than 1, right? Beta should be greater than alpha square by 4. If alpha is 2, alpha square by 4 will be 1. Next possibility is if alpha is 3, right? If I take alpha as 3, then beta should be greater than 9 by 4. 9 by 4 will be 2 point something. We need bigger than 2 point something. So you can take any one of these 4 values, either 3 or 4 or 5 or 6. If I take alpha as 4, beta should be greater than 4. So either you can take 5 or you can take 6. Finally, if I take 5 or 6, then you can see that if I take alpha as 5, beta should be greater than 6 point something, right? 5 square 25 by 4, so that will be 6 point something. So in this case, you will not get any value of beta. And same thing you can say when you take alpha as 6. Right here, if I take alpha as 6, then also you will not get any value of beta. So you'll get only these cases. Now, how many favorable cases are there? So we have 6 plus 5, that is 11, plus another 6, so that will be 17. Right, that means if E is the event, that quadratic expression is always positive. So total we are getting 17 favorable cases. Also, number of quadratic expression that you can create is 36. Number of elements in sample space. So therefore, the probability of this event that this quadratic expression will be positive for all x, this will be 17 by 36. So the correct answer for this problem will be first option. Right. So this was a problem where when first you should know this condition that a quadratic is always positive if A positive and D negative. And then you can see that here uh, A is always positive because A is 1. And for D negative, this is the condition that we are getting, that beta should be greater than alpha square by 4. Now, for different values of alpha, you can take 1, 2, 3 up to 6. But for 5 and 6, we are not getting any value of beta. So only these 4 cases. And therefore, favorable case is 17, total 36. And the probability will be 17 by 36. Hence, the correct answer for this problem is first option. Three distinct numbers are randomly selected from this set of first 40 natural numbers, right? The numbers 1, 2, 3 up to 40. If the probability that selected numbers are in an increasing increasing GP means that if first term is positive, the common ratio is greater than 1. So the probability that selected numbers are in increasing GP, this is m by n, where m and n, these two are co-prime numbers, their HCF is 1. Then we have to find the value of m plus n. Now again, this is a problem where we have to consider the different cases, right? Here if we talk about number of elements in sample space, so total 40 elements are there and we are selecting any 3 elements from there. So the total number of ways of selecting 3 elements, this will be 40C3. 40 distinct numbers, we have to select any 3 number. Now next we have to talk about favorable cases. Favorable cases are those cases where those selected numbers are in a GP with common ratio greater than 1, right? Increasing GP because all the numbers are positive numbers. So we'll get an increasing GP when the common ratio is more than 1. So here we have to count, basically the problem is we have to count that in how many different ways we can select 3 numbers so that they will form an increasing GP, right? And then our probability will be number of favorable cases by total number of cases. Total number of cases is 40C3. Now see, for finding number of favorable cases, we have to consider the different possibilities. So basically we have to think about the common ratio R, and then we have to see that how many different GP we can create. Also, because it is an increasing GP, common ratio must be greater than 1, right? So on one side we'll write R, and on another side we'll see how many different GPs are possible. Increasing GP, common ratio more than 1, and because all integers are there in this set, so common ratio must be integer, right? It cannot be fraction because then you will not get terms from this set. So if the common ratio is greater than 1 and it is an integer, so it has to be either 2 or 3 or 4 and so on. Now, suppose if I take common ratio as 2, so let us see how many GP we can create with common ratio 2. One possibility is that first term we can take 1. If common ratio is 2, next term will be 2 and then next one will be 4. So this is 1 GP with common ratio 2. Similarly, if I take first term as 2, the next term will be 2R and the next one will be 2R square. So this is the next GP, 2, 4 and then 8. You can see that if first term is 3, then next one will be 3 into 2, 6, and then 6 into 2, 12. So in this manner, we can create number of GPs. And the last one is, if I take 40 as the last term, then the second last term will be half of that. So that means 20. And the third last term, I mean the first term of that GP will be 20 by 2, that is 10. So in this, if the common ratio is 2, then these are the 10 GP that we can create, right? If we see the first term only, I mean, how many GP are here? So just notice the first term, 1, 2, 3 up to 10. So 10 GP we can create if the common ratio is 2. Now think of the next possibility. If the common ratio is 3, then first term 1, next one will be 1 into 3, and next one will be 1 into 3 square. So 139. This is a GP with first term 1, common ratio 3. Another possibility is that we can have 2, 2 into 3, 6, 6 into 3, 18. And you can see that we'll get only a few GP because when here every number we are multiplying with 3, and once you cross this last number 40, then you cannot have terms from here, right? So that means next possibility will be if I take first term as 3, 3 into 3, 9, and then 9 into 3, 27. If I take first term as 4, 4 into 3, 12, 12 into 3, 36. And if I take first term as 5, then next term will be 15, and then 15 into 3, 45. 45 is not there in this set, right? The moment you cross 40, when we have to stop counting. So these are the 4 ZP, common ratio 3. Similarly, if I take common ratio 4, then we'll get 1, 4, 16. This is one possibility. If the first term is 2, then we can have 2, 4 into 2, 8, 8 into 4, 32. And if I take 3, then we'll get 3, 24, sorry, 3 and then 12 and then 48. So again, bigger than this number. So there are only 2 GP with common ratio 4. These are the 2 GP. First term 1, 4, 16, first term 1 and then 4 and 16, or 2, 8, 32. Similarly, if I take first term as common ratio as 5, then first term we can have 1, 5 and then 25. And the next one will be 2, 10 and 50. Now again 50 is not there in that set. So there is only one GP with common ratio 5. If I take common ratio 6, then we can have 1, 6, 36. Again there is only one GP with common ratio 6. And with 7 you can easily see that the even if I take the first term as 1, the GP will be 1, 7 and then 49. Again 49 is bigger than this number. So these are all the different increasing GP. Right, first we have to take the common ratio, and then we have to count how many GP we can create, considering the fact that we have to take numbers, we have to select the numbers from this set, from the first 40 natural numbers. So now these are all the favorable cases, right? We got 10 GP plus here, 10 plus 4, 14, plus 2, 16, plus another 2, 18. So if uh, and it is given that probability that will get increasing GP, this is m by n. So that means m by n, this must be number of favorable cases by total number of cases. Number of favorable cases 18, and then total number of cases, this we are getting 40C3. Total 40 numbers are there. Select any 3 number and that will give us one case. So number of elements in sample space 40C3, favorable cases 18. And after simplification, you can do the calculation on your own. You will get 9 divided by 4940. So these are this will be the value of m by n, and there is no common factor between these two, right? 4940 is not multiple of 3. So these two numbers are co-prime numbers, or their GCD or greatest common divisor is 1. So now we need to find m plus n. So clearly you can see that if I add these two numbers, we'll get 4940 plus another 9. So that is 4949. So this should be the correct answer for this problem, right? So this was not a difficult problem. Just count the different cases. Total number of cases 40C3. And for favorable cases, we have to consider the different common ratios. And because we have increasing GP, so common ratio should be greater than 1. And only integers are involved here, so common ratio cannot be fraction. So we have to start with common ratio 2, 3, 4 up to 6. And then we got 18 favorable cases, total 40C3. After simplification, the answer will be 4949. Let the sum of two positive numbers be 24. If the probability that the product is not less than 3/4 of their greatest possible product is m by n, where again m and n, these two are co-prime numbers. So we have to find the value of n minus m. Now, first here we'll count that how many elements are there in sample space, and then we'll try to calculate the favorable cases. It is given that sum of two positive numbers is 24. So let us say those two numbers are x and y. So x plus y this must be 24, and it is given that x and y, these two are positive integers. So the different cases will be, I mean, if I have to find two positive integer and we need to make their sum 24. So one possibility is that first number is 1, second number is 23. Another possibility is first number is 2, second number is 22. And in this manner, the last possibility will be that first number is 23 and the second one is 1. So clearly you can see that number of elements in sample space or number of ways of finding two positive integers whose sum is 24, this will be 23, right? Now we have to count number of favorable cases, and this one is the interesting part of this problem. We have to find number of favorable cases, and favorable case means that product of those two numbers is not less than 3/4 of, not less than means either greater than or equal to 3/4 of their greatest possible product, right? Now we know that if we have two positive numbers and their sum is constant, then their product is maximum when the two numbers are equal. For example, there are different ways in which you can create 24 here. So one possibility 1 into 3, right? 1 and 23. If you multiply these two numbers, you'll get 23. When you multiply these two numbers, you'll get 22 into 2, 44. So in this manner, the product will be maximum if you make the two numbers equal. That means maximum value of x into y, right? Total 23 cases we are getting, and out of these 24 cases you will get maximum x into y when x is 12 and y is 12, right? Clearly you can see that if I take x 12, y 12, then the product will be 144. If you take x13, y11, the product will be 143. If you take x14 and y10, the product will be 140 and so on. So the product is maximum when you make the two numbers equal, right? Now here it is given that the favorable cases are those cases where the product of these two numbers, that means x into y, this is not less than, that means greater than or equal to 3/4 of their greatest possible product. Greatest possible product is 144. So that means x into y, this must be greater than equal to 36 into 3. So that will be 108. So now we have to count that out of these 23 cases, total we are getting 23 different cases. So out of these 23 cases, how many cases are there where x into y, this is either 108 or greater than 108. Those are the favorable cases, right? So here, if we count the different possibility, we can start with x12, y12, because here you will get the maximum product, and then we'll keep on increasing one number by one and we'll decrease the second number by one so that we can maintain the sum of 24. So next we can take 11 and 13. Product of these two numbers 143, and clearly it is more than 108. And remember, from here you will get two different cases, 11 13, 13 11. Next possibility will be 10 14. 10 into 14 140, that is certainly greater than 108. Next again you'll get two cases from here, 10 14, and by interchanging those two, 14 and 10. Similarly, next one will be 9 and 15. 9 into 15 is 135, which is more than 108. Next one will be 8 into 16. Next possibility will be 7 into 17, right? 7 into 17 will be 119, which is greater than 108. Just decrease one number by one and increase the second number by one and see how many cases we are getting. Next possibility will be 6 and 18. 6 into 18, 108. Here it should be either greater than or equal to, not less than means uh, either more than or equal to that number. So 6 and then 18, this will be 108. If you take 5 and 19, then 19 into 5 will be 95, and then the product will become smaller than this number. So these are all the favorable cases, right? Now first case 12 12, that will give you only one case, but in remaining all cases you are going to get two different cases. So here you can see that 3 plus another 3 6 into 2, because we can interchange those two. So 12 and plus 1, this case 12 and 12. So these are the 13 favorable cases, right? These are the 13 cases where some of the two numbers will be 24 and their product will be either greater than or equal to 108, right? So here this probability m by n, this will be number of favorable cases, which is 13 divided by total number of cases 23. We have to find n minus m, and remember this would be in lowest form. So clearly there is no common factor between 13 and 23. In fact, both of them are prime numbers. So here if you calculate the difference of those two, n minus m, 23 minus 13, that will be 10. And therefore the correct answer for this problem will be first option. Right, so this was again a problem on basic concept that you have to be aware of this fact that product of two number is maximum, two positive number, if their sum is constant, the product is maximum when the numbers are equal. And from there we got this favorable case that x into y should be greater than greater than equal to 108, 13 favorable cases and total 23 cases. So therefore probability will be 13 by 23, and finally the correct answer for this problem is first option. Find the probability that a randomly selected 2 cross 2 matrix with all its entries from the set of first 10 prime numbers is singular matrix, right? Singular matrix means determinant of that matrix is 0. So let us say that these are the different prime numbers. First 10 prime numbers will be starting from 2, 3, 5. Then you have 7, 11, 13. Right? Then next will be 17, 19. Then you have 23 and 29. So these are the first 10 prime numbers. Now the question is that using these 10 prime numbers, of 2 cross 2 matrix is created, and we have to find the probability that that matrix will be a singular matrix, right? Now let us say this is our 2 cross 2 matrix A, and there are four unknowns in that. Let us say those unknowns are A, B, C, D. So here we have this matrix. In first row, let us say we have A and B, and in second row we have C and D. So first of all, let us find the number of elements in sample space, or the number of matrices that you can create. A, B, C, D, we have to select from this set, right? A, B, C, D are selected from first 10 prime numbers. So for A, we have 10 options. We can select any one of these 10 numbers. Similarly, for B, we have another 10 option and so on. So total number of matrices that you can create, this will be 10 raised to 4, right? For A, 10 option, for B, another 10 option and so on. So these are the total number of matrices, or the number of elements in sample space. Now let us count the favorable cases. Favorable case means out of these 10 raised to 4 matrices, we have to find that how many matrices are singular matrix. How many matrices are there whose determinant is 0. Now, see, singular matrix you can create in different ways. One possibility is that you will pick any one number from here and you will use the same number in all entries, right? For example, let us say if I create a matrix like this, where we have selected any one number from there. Let us say we have selected 2 or 3, any number, and then all the entries are same number. Now, what is the determinant of this matrix? Obviously, the answer is 0, right? So, this is one singular matrix. Now, how many such singular matrices are possible? So, let us say n1 is the number of such singular matrices where all entries are same. So, this will be nothing but 10C1, right? Out of these 10 elements, select any one element and will use the same element 4 times. So all of these four variables A, B, C, D will be that same element. So there will be 10 such singular matrices. Another possibility is, second possibility will be that out of these 10 prime numbers, select any two prime number and will keep those prime numbers either in, let us say we have selected these two prime numbers, maybe 5 and then 7. You can select any two from there. So you can keep 5 in first row and 7 in second row. Now again, the determinant of this matrix will be 0, right? If I want, I can keep 5 in first column and 7 in second column, still the determinant will be 0. So let us say N2 is these type of matrices where we are using any two of these 10 elements. Now, how many such matrices are there? So, step 1, from those 10 matrices, select from those 10 elements, those 10 prime numbers, select any two prime number. Let us say we have selected 5 and 7. Now, in how many ways we can do that selection? 10C2. And once you select 5 and 7, there are 4 matrices that you can create. What are those matrices? First matrix where 5 is in first row, 7 in second row. Another matrix where 5 is in second row and 7 in first row. Just interchange these two rows. And same thing you can do column wise, right? Or another way of saying the same thing will be that you need to keep uh, the elements of any one row or any one column same. So one matrix where 5 is in first row, another matrix where 5 is in second row, another matrix where 5 is in first column, and finally the last matrix where 5 is in second column, right? So by selecting these two elements for corresponding to each selection, we can create 4 such matrices, right? 5 in row 1, 5 in row 2, and that means 7 in row 1, 5 in first column and 5 in second column. In all those cases, determinant will be 0. So the number of such matrices will be 10C2 is 45, 10 into 9 by 2, and that multiplied by 4. So 45 into 4, that means 90 into 2, so that will be 180. So these are the number of matrices where we are using exactly 2 of these 10 elements. Now, using 3 or 4 elements, you cannot create a singular matrix for the simple reason that all of these numbers are prime numbers. Right? For example, if I select 5, 7, and 11, so now you cannot make AD minus BC 0, right? For example, I mean, because all of them are prime numbers, so singular matrix means determinant should be 0. Now, if you select any 3 prime numbers from here, you cannot get 0. AD minus BC, that cannot become 0. And similarly, if you select any 4 prime numbers, then also you cannot make AD minus BC 0, right? AD minus BC 0 means AD is same as BC. Now, product of any two prime number, this will not be same as product of any two other prime numbers, right? If I have selected these 4 prime numbers, so A into D is not same as B into C if they are different numbers. So therefore, these are the only two matrices, right? These are the only two possibilities that we have. Either all 4 elements are same or any two are same, remaining two are same, and the same elements are in any one row or any one column. So now the question is, we have to find the probability that the matrix will be a singular matrix. So total number of singular matrix, this we are getting 190, right? 180 in second case, 10 in first case, and this divided by 10 raised to 4. So after simplification, this will be 19 by 10 raised to 3, and therefore the correct answer for this problem will be option C. This was an interesting problem, and because all the prime numbers are involved, so we are getting only these two cases, because product of any two prime number is not same as product of any two other prime numbers. So 190 favorable cases, total 10 raised to 4, probability will be 19 by 10 raised to 3, and hence the correct answer is option C. Let S be this set containing first 6 natural numbers. Then find the probability that a randomly selected onto function means codomain is same as range. So find the probability that a randomly selected onto function g from S to S satisfies this equation, that g of 3, this is twice of g of 1. Now in this problem, we have to first find the total number of onto function from S to S. That will give us number of elements in sample space. And then we have to find that how many functions are there which are satisfying this condition, that z of 3, this is twice of z of 1. And then probability will be number of favorable cases by total number of cases. So the given set, I mean, here the function is defined from S to S. That means domain is S and codomain, that is also S. Right, so first set is S. In this set, we have elements like 1, 2, 3, 4, 5, and 6. These are the 6 elements in first set. And the second set is also same set. Right, second set is also S. The function is defined from S to S. And in the so the codomain is also same set. In codomain, we have these 6 elements. Now remember, whenever number of elements in two sets are equal, right? First set, whenever the number of elements in domain and codomain is equal, then a function is onto function when it is 1 function, right? Number of 1 function will be same as number of onto function, right? So because once you make function mini one, then you cannot make it onto. Onto means codomain is same as range. The meaning of this word onto function will be that codomain and range, these two are equal. So in codomain we have 6 elements, 1, 2, 3 up to 6. And in range you cannot have more than 6 elements, right? Range will be f of 1, f of 2 and so on. And function means for each element we can have only one image, right? For any one element of set A, there will be only one value of f of 1, f of 2 and so on. So if two sets have equal number of elements, then number of onto function, this is same as number of one function. So here if we talk about number of elements in sample space, this will be number of one function from set S to S. And that will be nothing but 6 factorial, because for this first element 1 we have 6 options, right? For this element 1 we can connect either with 1 or 2 or 3, any one of these 6 elements. Let us say f of 1 is 2. Now for 2 we have only 5 options, right? Because we have to make function 1 1. So for the next element 2 we have only 5 options, either it will be 1 or 3 or 4 up to 6. Let us say if f of 2 is 6, then for f of 3 we have only 4 options and so on. So number of functions, this will be 6 into 5, number of one function, which is same as number of onto function when we have equal number of elements in two sets. So this will be 6 into 5 into 4 up to 1. So that is 6 factorial. Now let us try to figure out that how many favorable cases are there, right? If we find a number of favorable cases, so then we can get the probability that a randomly selected function will satisfy this equation, that z of 3, this is twice of z of 1. So favorable cases are all those cases where uh, we have this condition satisfied, that z of 3, this is twice of z of 1. Now the same relation you can write in this form, that z of 1, this should be half of z of 3, right? Now let us figure out that how many different possibilities are there for z of 3. Now because z of 1 has to be half of z of 3, and all of these are integers only, so z of 1 will be integer. So from there we can conclude that z of 3, this must be even number, because if z of 3 is an odd number, then z of 1 will become fraction, and we do not have fractional numbers here. So for z of 3, we can take only those values which are integer, which are even integer. So for example, if I calculate z of 3, you can take z of 3 either as 2, or you can take 4, or you can take 6. But you cannot take z of 3 as 1, because then z of 1 will become 1 by 2. We cannot take z of 3 as 3, because then z of 1 will be 3 by 2, right? So for connecting this element 3, we have 3 options. Let us say E is the event that a randomly selected function is satisfying this condition. G of 3 is twice of g of 1. So number of elements in E, or the number of onto functions satisfying this condition will be, for 3 we have two options. Either you can select 2, or you can select 4 or 6. Right? G of 3 will be either 2 or 4 or 6. We cannot have odd values for G of 3. So for Z of 3, 3 options. Now, once you decide Z of 3, Z of 1 has to be half of that. So for Z of 1, there is only one option. Let us say in this example, suppose if Z of 3 was 2, then G of 1, this must be half of 2, which will be 1. So G of 1 has to be 1. And for remaining 4 elements, there is no restriction, right? So for 3, we have 3 options, either 2 or 4 or 6. For 1, there is only one option. Once you decide g of 3, g of 1 is half of that. And then for remaining 4 elements, we have 4 options. I mean, for this element 2, we have 4 options. For 4, we have 3 options, and so on. So these are the number of favorable cases, or the number of matrix, or the number of functions satisfying this condition, right? So because I mean, for these remaining elements, for example, 2, there are 4 options. You can connect with any one of the remaining 4. Then for 4, we have only 3 options, right? And similarly, for 5, we have only 2 options. Either it will be 4 or 5. And similarly, for last one, we have only one option. So for the remaining 4 elements, we have 4 factorial number of options of connecting with the second set, right? So number of onto functions satisfying this condition, this will be 3 into 4 factorial. Now the question is, what is the probability that a randomly selected function will satisfy this condition? So these are the number of favorable cases, 3 into 4 factorial, and total number of onto function, this is 6 factorial. So probability will be 3 into 4 factorial by 6 factorial. 4 factorial you can cancel, and then you have 3 and 6 and 5. So 1 by 5 into 2, that will be 10. So this will be the required probability, right? 1 by 10 is first option, and therefore that should be the correct answer. So this was a problem from functions as well as probability. First of all, onto function means codomain is same as range, and if two sets have equal number of elements, then number of onto function is same as number of one function. So here number of elements in sample space, this will be 6 factorial. And favorable cases means those onto function which are satisfying this condition, that z of 1 is half of z of 3. So for z of 3 we had only 3 even options, either 2 or 4 or 6. For z of 1 only one option, and for remaining 4 elements 4 factorial, and therefore probability will be number of favorable cases by total number of cases. Finally we got 1 by 10, and that is the correct answer for this problem. In a tournament, a team plays 10 matches with the probability of winning and losing each match 1 by 3 and 2 by 3. Right? This probability is constant. Probability of winning every match, probability of winning each match is 1 by 3 and losing the match is 2 by 3. So, and sum of these two is 1, so there is no chance of draw. These are the only two cases, right? X is the number of matches that the team wins, and Y is the number of matches that the team loses. If probability that mod x minus y, this is less than or equal to 2, this is p, then we have to find the value of 3 raised to 9p. Now this is a problem on binomial distribution, right? We know that uh, if we repeat the same experiment n number of times, then probability of r success in n trials, x is representing the number of success, so probability of r success in n trials, this is given by the formula ncr, p raised to r, where p is probability of success, and q raised to n minus r. Q is probability of failure, which is 1 minus p. So this is the standard formula in case of binomial distribution, right? If we repeat the same experiment n number of times, and p is the probability of success in each trial, q is probability of failure in each trial, and these two are constant for every trial. So then probability of r success in n trial, this is ncr, p raised to r, q raised to n minus r. Now here it is given that probability of winning the match, this is 1 by 3. Probability of losing the match, this is 2 by 3. And then we have to find that difference between win and loss. This should be 2 or less, right? This probability is p. Then we need to find value of 3 raised to 9 into p. Now see here, first let us see what are the different possibilities. When x is representing number of win, for loss, y is representing number of loss, and mod x minus y, this should be less than or equal to 2. So one case will be, the very first case will be that you win 5 matches, lose 5 matches, the difference will be of 0, right? X minus y, that will be 0. Another possibility will be that you win 6 matches, that means you will lose the remaining 4 matches, difference will be of 2. We cannot win 7 matches because then loss will be 3 and difference will be 4. Difference would be less than or equal to 2. Right? This is the important point here, that mod x minus y, that must be less than or equal to 2. That means difference between win and loss, that should be 2 or less. So x cannot be 7. In that case, y will be 3, x minus y will be 4. So another possibility will be x is 4, y is 6, and here also difference is of 2. And again, you cannot win 3 matches because in that case you will lose 7 matches, difference will be of 4. So these are the 3 different cases, right? And now we have to find the probability of this thing. P is the probability of this one, so then we have to find 3 raised to 9 into P. So this thing will be 3 raised to 9, and P is nothing but probability of these different cases. First one is 10 win, that means remaining 10 losses, right? Now we'll find probability of 5 win, 6 win, or 4 win. So probability that you will win 5 matches, this will be 10C5, and then P raised to 5, P is 1 by 3, so 1 by 3 raised to 5, Q raised to 5. This will be the probability that you will win any 5 matches and you will lose the remaining 5 matches. probability of winning 6 matches, this will be 10C6, 1 by 3 raised to 6, right? P raised to R and then Q raised to N minus R. So 2 by 3, this raised to 4. This is the probability of winning any 6 matches. And finally, the last case is 10C4. This is probability of winning any 4 matches. So 10C4, 1 by 3 raised to 4. And then we have 2 by 3, this raised to 6. So these are the 3 different possibility. Now calculation you can do on your own. After calculation, you will find that this number is 8288. Remember, we had to find 3 raised to 9 into P, right? So this will be P. Right, this is the probability of 5 win, 5 loss. Second term, 6 win, 4 loss. And the last term, any 4 win, and then remaining 6 losses. After calculation, you will find that the value of this term will be 8288, and therefore that will be the correct answer for this problem. Right, so in this problem, the important step was to figure out the different cases. So just create this table. 5 win, 5 losses, difference will be of 0. And then either you can have 6 win, 4 loss, or 4 win, 6 loss. Right, in that case, difference will be of 2. And then after that, using the standard formula, uh, this will be the required probability. And finally, when you calculate, you will find 8288 is the correct answer for this problem. Let A be the event that absolute difference, that means modulus of difference between the two numbers, two randomly selected real numbers in this sample space 0 to 60. So we are selecting any two number from 0 to 60, and the difference of modulus of those two numbers is less than or equal to alpha. The probability of this thing is 11 by 36. So then we have to find the value of alpha. Now, this is a problem on 2D probability, right? Here, if you see the sample space, we have to select two numbers in this set 0 to 60. And you can take any two numbers from 0 to 60. It is not necessary that those numbers should be integers, right? So we need to pick two numbers from 0 to 60. The difference between those two numbers, right? The difference between those two numbers is less than or equal to alpha. The probability of this thing is given. Probability is 11 by 36. Then what is the value of alpha? Now, see here, let us say that two selected numbers are x and y. So it is given that x is a number in this interval 0 to 60. You can take any value of x from 0 to 60. Similarly, y is a number from 0 to 60. Again, you can take any numbers from 0 to 60. Now, there are infinite number of numbers from 0 to 60, right? If I mean, it is not given that x and y are integers, so you have infinite possibilities for x and y. And then it is given that the A is the event that absolute difference between those two randomly selected number is less than or equal to alpha. That means mod x minus y. This is less than equal to alpha. And the probability of this thing is 11 by 36. So then what should be the value of alpha? Now this is a question on 2D probability, right? There are two variables x and y, and x and y can take any value from 0 to 60. So first let us first let us plot the sample space here, and then we'll see what is the favorable reason in that. So if x and y are numbers from 0 to 60, so that means for x we can take any value from 0 to 60, and same thing is true for y also. That means we can take any points inside this square, right? The different lines are, this line is x equals to 60 line. Here we have x equals to 0. This is y equals to 69. And this is your sample space, right? Take any point in this region and it will satisfy the condition that x is between 0 and 60, y is also between 0 and 60. So this square is representing the sample space. Let us call these points as O, A, B, and C. So this square is representing the sample space here, right? Now the favorable reason will be that mod x minus y, this should be less than or equal to alpha. That means x minus y, this should be between minus alpha and plus alpha. Obviously, alpha will be a positive number, right? So the favorable reason will be reason satisfying this inequality, that x minus y is between minus alpha and plus alpha. So first let us plot this line x minus y equals to alpha. So when x is, I'll remove this point, and the coordinate of this point will be, point B is 60 and 60, right? This line also we can remove. So if I draw this one line, we have to draw is x minus y equals to alpha. Other line we have to draw is x minus y equals to minus alpha. And then we'll see that which region is represented by this inequality, because this will be the favorable region, right? So here, if I make, for drawing the first line, if I make y 0, x will be alpha. And the line is having slope 1. So basically, this will be the line x minus y equals to alpha, right? This is the line x minus y equals to alpha, and the other line x minus y equals to minus alpha, this will be a line parallel to this one. And if I make y 0, then you will get x as minus alpha, and if you make x 0, then you will get y as plus alpha. So this should be the other line, right? The second line will be passing through this point, these 2 points, and the equation of this line will be x minus y equals to minus alpha. And now this inequality will represent all the points between these 2 lines, right? Clearly origin is satisfying this inequality, so that inequality will represent all the points inside this region. That means take any point in this shaded region, and that point will satisfy the condition that mod x minus alpha is less than mod x minus y is less than equal to alpha. So this is your favorable region, right? The sample space will be the square here, right? Take any point inside the square, and for that point x and y will be between 0 and 60, and the favorable region will be the area shaded in green, yellow color, right? The area between these 2 lines. Now we know that in case of 2D probability, the required probability is favorable area divided by total area, and it is given that the required probability is 11 by 36. So 11 by 36, this must be favorable area, and this divided by total area, and from there we need to find the value of alpha, right? So clearly you can see that total area will be area of a square, and for a square the side is 60, so therefore area of that square will be 60 square, right? So in denominator we'll get 60 square, and the numerator part will be we have, you can see that basically we need to remove these 2 area, right? This area highlighted in green color, this is not favorable area. So if I need the favorable area, this will be 60 square, that is area of a square, minus the area of these 2 triangles. Now this point was 60, 0. This point will be alpha 0. So for this triangle, one side will be 60 minus alpha. And also from symmetry, you can clearly see that these 2 triangles will have equal area. So 2 into area of these 2 triangles, half into base into height. Now base will be 60 minus alpha, and because for this line the slope is 1, this angle will be 45, and that means these 2 sides will be equal. So the other side is also 60 minus alpha. So this is the equation that we are getting, and you can solve this equation on your own. After solving, you will find that alpha is 10. So therefore that will be the correct answer for this problem, right? So in JEE Main, generally you will not find problems on 2D or 3D probability, but when this was one problem from 2D probability, because when x and y can take all the values from 0 to 60, right? So x is a number from 0 to 60, y is a number from 0 to 60. So any point inside this square is a point in sample space, right? And then favorable case will be all those values of x and y satisfying this inequality that mod x minus alpha is between minus alpha is less than equal to alpha. That means x minus y is between minus alpha and plus alpha. So plot these 2 lines, and then that inequality is representing the area bounded between these 2 lines. Probability, in case of 2D probability, the required probability is favorable area by total area. So from there we got this equation, and after solving we got alpha as 10, and hence the correct answer for this problem will be 10. Let A be a symmetric matrix of order 2, means A is a 2 cross 2 symmetric matrix with integer entries. So each entry of that matrix must be some integer. It is given that sum of diagonal elements of A square is 1. Sum of diagonal elements means trace of the matrix. So for matrix A square, trace is 1. Then we have to find the number of possible matrices. Now in this problem, the keywords are that A is a 2 cross 2 symmetric matrix with integer entries. Now remember that in case of symmetric matrix, the definition of symmetric matrix is that A transpose, this is same as A. And another way of saying the same thing will be that element in ith row, jth column, this is same as element in jth row, ith column. That means the matrix is symmetric about its principal diagonal, right? So here, for example, if I have to take a 2 cross 2 symmetric matrix, first we'll start with a general 2 cross 2 symmetric matrix, and the trace of that matrix will be, trace of A square will be 1. So from there, we'll try to find an equation in variables, and then we'll see what are the different integral values of those variables which will satisfy that equation. So in case of symmetric matrix, you can have anything on diagonal, but these two elements must be same, right? Element in first row, second column. This must be same as element of second row, first column. The matrix must be symmetric about its principal diagonal. So let us say this is matrix A. Now, if this one is matrix A, then A square will be matrix A into matrix A, right? A square means A into A. So we'll write the same matrix again, and then we'll see what should be the trace of this matrix or some of the diagonal elements of this matrix, right? So sum of diagonal elements means when for A square, the element of first row, first column will be first row multiplied by this first column. Remember, it is given that trace of A square, this is 1. Now trace of A square means first row, first column. This will give us A square plus C square, right? This will be the element of first row, first column of A square. And similarly, element of second row, second column, this will be C square plus B square, right? And this has to be 1. We are not calculating the element of first row, second column or second row, first column, because trace means sum of diagonal elements only. Now from here we are getting A square plus B square plus 2 square. This must be 1. Now ABC are integer, and A square plus B square plus 2C square, this must be 1. So then we have to see what are the different possible values of A, B, C. Now as these numbers are integer, for this variable C, we have only one option, and that option is C must be 0. Because if you take any other value of C, then you cannot make this sum 1, right? If I take C as 1 or minus 1, then this term itself will be 2, and then we have other positive term, whereas the right hand side is 1 only. So for C there is no option, the value of C must be 0, and if C is 0, then the equation becomes A square plus B square, this equals to 1. Now, what are the different integral solution of this equation? So one possibility is that you can take A as plus minus 1 and you can take B as 0. Or another possibility will be that you can take A as 0 and B as plus minus 1. These are the only two possibilities. In fact, four possibility, plus minus 1 and 0. So one matrix will, I mean, in all of those matrices, the value of C will be 0. So there will be two matrices for which C is 0, B is 0, and A is either plus 1 or minus 1. And there will be other two matrices for which A is 0, C is 0, and B is plus 1 or minus 1, right? So clearly you can see that there will be four such matrices with integral entries, right? 4 2 cross 2 symmetric matrices with integral entries for which trace of A square, that will be 1, right? So therefore, the correct answer for this problem must be second option. So, I mean, this was not difficult problem. All we had to do was start with a general 2 cross 2 symmetric matrix. And in case of symmetric matrix, element in ith row, jth column, this must be same as element of jth row, ith column. So from there we got A square plus B square plus 2C square as 1. And now value of C must be 0. Then the equation was A square plus B square is 1, which means A is plus minus 1, B is 0, or A is 0 and B is plus minus 1. So total there are four such matrices, and therefore the correct answer for this problem is option B. We have this 3 cross 3 matrix A, And in this matrix A, on diagonal we have 1, and the elements which are below the diagonal, they are 0. That means it is upper triangular matrix, right? In case of upper triangular matrix, the elements below the principal diagonal, they are 0. And there are two unknowns, A and B, right? The other three entries, they are A and B. If for some n belonging to this natural number n, matrix A raised to n is this matrix where on diagonal we have 1, 1, 1, and the elements above the diagonal, they are these three elements, and elements below the diagonal, they are 0. Then we have to find the value of n plus a plus b. So basically here we have to calculate this matrix A raised to n in terms of n, and then by comparing the corresponding elements, we need to get the value of n, a and b. Now in this problem, there is one important concept, that because for matrix A, the element below the principal diagonal, they are 0, and on diagonal we have 1. So we can write this matrix A as identity matrix plus some other matrix B, right? And if I break this matrix A as I plus B, then clearly you can see that matrix B will be I means 1 1 on 1 1 1 on diagonal. So the other matrix B, this will be nothing but will have 0 on diagonal. The elements below the principal diagonal, that will be also 0, and you will get only 3 elements above the diagonal which are non-zero elements. And then if you calculate b square and higher power of that matrix, then after a point you will get null matrix, because we are writing matrix A as I plus B. So this 1 1 1 on diagonal, that will be taken care by this identity matrix. So here you will get A and B, and these elements are still 0. So this is our matrix B. And if I have to calculate A raised to n, then we can calculate I plus B raised to n. And we can expand that using binomial theorem, because I and B, these two are commutative matrix, right? Now, if this is matrix B, then let us try to calculate B square. For finding B square, we can multiply this matrix B with B, right? B square means matrix B into B. So here b square will get again 0 0 0 on diagonal. The three elements below the diagonal, they are also 0, and then we have a and b. Now let us see what we are getting for b square, right? So because this is one important concept, there are few PYQ where you will get these type of matrices. Upper triangular matrix where elements below the principal diagonal, they are 0, and we have 1 on diagonal. Now here if you calculate b square, first row, first column, that will give us 0. First row, second column, 0. First row, third column, so that will give us 0, then AB, and then again 0. Second row, first column, 0. Second row, second column will be 0. Second row, third column, that is still 0. Third row is completely 0. So these three elements will become 0. So this is our matrix B square. And you can verify on your own that if you calculate B cube, that means B square into B. So that will give you null matrix, right? If I calculate B cube, this will be null matrix. And the moment B cube is null matrix, any large power, any higher power of that, B raised to 4, B raised to 5, B raised to 6, all of these matrices, they will be null matrix only. So that means now if I have to calculate A raised to n, we can use the binomial theorem for that one. So A raised to n, this we can write as I plus B raised to n, because I and B, these two are commutative matrices. So therefore we can use binomial expansion. So this will become I raised to n, nc1 into b, and then nc2 means n into n minus 1 by 2, this multiplied by b square. And because PQ is null matrix, so after that B raised to 4, B raised to 5, all of them are null matrices only, right? So this is our matrix A raised to n. A raised to n, this will be I plus n into B plus n into B square. And the given matrix A raised to n, let me write that matrix here, and then we can compare the corresponding elements. So for A raised to n, this was given as A raised to n, right? This was our matrix A raised to n. We had 1 on diagonal, and then we have 48, 2, 1, 6, 0, and then 96. So now let us try equating the corresponding elements. That will give us equation in a, b, and n. And by solving those equations, we can get the value of a, b, and n. So a raised to n is this matrix, and a raised to n is I plus n into b, n minus 1 by 2 into b square. So if I equate the corresponding elements, right, this was our matrix B. In matrix B, we had A, and B. This was B. And for B square, we have AB here, right? This is our matrix B square. And in matrix B, we have these three elements A, and B. So 1, 1, 1, that will take care of this identity, that will be taken care by this identity matrix. Now, element in first row, second column, that is 48. So therefore, one of the equations will be 48 equals to, and in second row, first column, sorry, first row, second column, in B square we have 0, and in matrix B we have n. So n into B, and that plus this multiplied by 0. So n into B, and here we have A. So this means 48 is nothing but n into A. This we are getting by comparing the element in first row, second column of A raised to n from here given matrix and from this right hand side. So this is one equation. Similarly, element in second row, third column, this is 96. And on right hand side, the element in second row, third column, that will be n into b. So this is another equation, right? N into a is 48, n into b, this is 96. And finally, element in first row, third column, this is 2160. And from right hand side, we'll get n into b, that means n into a, right? N into matrix b, and in matrix b, we have a here. And that multiplied by n into n minus 1 by 2, b square. And for b square, the corresponding element is ab. So these are the three equations that we have, right? One equation, na is 48, other equation NB is 48, 96, and then this is the third equation. Now after this, it is not difficult to solve these three equations. You can substitute NA as 48. In place of N into B, you can write 96, and then you can solve these three equations. So once you solve these three equations, you will find that the value of A, this will be 4. And because we need this value n plus a plus b, so I'll directly write the answer after this. I mean, the calculation is not difficult, just substitute these values and then you can get the answer. Na is 48 and then Na 48, and in place of b you can write 96 by n. So then first you will get the value of n will be 12. Substitute that value of n in first equation, then you will get a as 4, and then substitute that value n again in second equation, you will get b as 8. So n plus a plus b, that will be 12 plus 4 plus 8. So 12 plus 12, that is 24. So that is the correct answer for this problem. In this problem, the important concept was to write this matrix uh, A as I plus B, where I is identity matrix, and then this matrix B is 0 on diagonal, 0 below the diagonal, and then these three entries A, and B. So once you calculate B square, you will get AB, and B cube will become null matrix. And the moment you have null matrix, any higher power of that matrix, because if BQ is null matrix, B raised to 4 is nothing but B cube into B. B raised to 5 will be B cube into B square. So all of these matrices will become null matrix. And because I and B, these two are commutative matrix, so here you can apply that binomial expansion. So finally, A raised to n, that was I plus n into B, n into n minus 1 by 2 into B square. By comparing the corresponding elements, we got these three equations. And after solving this equation, you will get n 12, a and b as 4 and 8. And therefore, n plus a plus b, that will be 24. And that is the correct answer for this problem. Let A be this matrix. In first column, we have 2, 4, 6. Then in second column, we have these unknowns P. And then in third column, we have Q with some constant also. Now, if determinant of adjoint of 3A, this is 2 raised to m into 3 raised to n, where m and n are natural numbers, then we have to find the value of m plus n. Now, this is not a difficult problem. I mean, one can very easily calculate the determinant of matrix A, and then using properties of adjoint and inverse, you can find this determinant of adjoint of 3A, and from there you can calculate M and N. But in this problem, there is one shortcut method, that because this determinant, this is given determinant of adjoint of 3A, this is given in terms of 2 raised to m, 3 raised to n. There is no p or q in this equation, right? M and n, these two natural numbers, and determinant of adjoint of 3A, this is 2 raised to something multiplied by 3 raised to something. So if there is no p or q for determinant of adjoint of 3A, so that will mean that determinant of matrix A, this must be independent of P and Q. Right? It is not difficult to show that result. I mean, if you want to get rid of P, then in place of C2, you can write C2 minus, and then 2, 4, 6, and here we have 1, 2, 3. So basically half of this column, and that multiplied by P into C1. So that will get rid of these three elements, these three terms P, 2P, and 3P. Similarly, you can get rid of Q also and P from this third column. But here, because the determinant of adjoint of 3A, this is independent of P and Q. The determinant of matrix A, this must be also independent of P and Q. So you can take any value of P and Q, and we should get the same value of determinant of A. So here what we'll do is, in place of P and Q, we can take 0, right? If I take P as 0 and Q as 0, then determinant of matrix A, this will be 2, 4, 6. Then we have 2, 6, 12. And then third column will be 2, 8, and then 20, right? So, I mean, there is no need to show that the determinant of this matrix is independent of PQ. It has to be independent of PQ because otherwise, this thing will not be a constant, right? This will not become 2 raised to m. I mean, it will include P and Q also. And now from here, we can very easily calculate determinant of this one. In place of C1, I mean, if we want, we can create two zeros. So in place of C1, we can write C1 minus C2. And in place of C2, we can write C2 minus C3. So in that way, we can create two zeros in same row, and then we can expand along that particular row, right? So in place of C1, if I do C1 minus C2, then 2 minus 2, that will be 0. Then here we'll get minus 2 minus 6, again 0, minus 2 minus 8, and then we have 2, 8, and 20. And now we can expand this determinant along the first row. So this will give us 2 into, and then 16 minus 12. So 16 minus 12, that will be 4. That means determinant of matrix A, this is nothing but 8, right? That is determinant of matrix A. And now we need to find this thing. We have to find determinant of adjoint of 3A, right? Now we know that this thing will be nothing but determinant of 3A, and this raised to n minus 1, n is 3, so n minus 1 will be 2, and we have adjoint twice here, right? Adjoint of 3A, so that means another 2 in exponent, right? Determinant of 3A raised to n minus 1 raised to k. N is the order of matrix, and k is the number of times we have adjoint. So because we have adjoint 2 times, this raised to 2. So this becomes 3 into, and then uh, this we can, if we want to take this 3 outside, remember we have to take 3 cube outside. So 3 cube into determinant of A, and this raised to 4. Now 3 raised to 3 cube raised to 4, so that will be 3 raised to 12. And determinant of A, this was nothing but 8. 8 is 2 cube, this raised to 4. So ultimately, this will become 3 raised to 12 into 2 raised to 12. That is determinant of adjoint of 3A. So clearly you can see that M is, if I compare with this one, then 3 raised to 12, 2 raised to 12. We needed M plus N. So clearly M is 12, N is also 12. So that means M plus N, this must be 24. So the correct answer for this problem will be option C. Right? This was not a difficult problem, but there was one important concept that if you apply this logic, that because Determinant of adjoint of 3A, this is independent of P and Q. So determinant of this matrix A, that must also be independent of P and Q, and therefore in place of P and Q we can take 0, and then in few lines we can get determinant of matrix A, and then after that we can use properties of adjoint. Adjoint of 3A, determinant of adjoint of 3A. So this will be determinant of 3A raised to n minus 1, and this raised to k. N is the order of matrix and k is the number of times we have adjoint. So from there finally we got 3 raised to 12, 2 raised to 12, m plus n will be 24, and therefore the correct answer for this problem is option C. Let A be this 3 cross 3 matrix, and for some theta belonging to 0 to pi, A square is same as A transpose. Then we have to find the sum of diagonal elements of this matrix A plus I raised to 3 plus A minus I raised to 3 minus 6A. Now, this is a very interesting problem from one important type of matrix, that is orthogonal matrix. Now, in case of orthogonal matrix, generally we learn the basic definition of orthogonal matrix, that a matrix is called orthogonal matrix if A into A transpose, that is identity matrix, right? If you multiply a matrix and its transpose, and if the result is identity matrix, then we say that this matrix is orthogonal matrix. However, this definition is not that much useful when we have to identify whether a matrix is orthogonal or not by observation, right? In case of orthogonal matrix, I mean, this is the definition that A into A transpose, if that is I, then matrix is orthogonal. But the problem with this definition is that only after calculating A into A transpose, uh, you can identify whether the matrix is orthogonal or not. That means first we need to find A into A transpose, and if that is identity matrix, then only we can claim that it will be orthogonal matrix. However, if you are familiar with properties of orthogonal matrix, then simply by observation you can tell whether a matrix is orthogonal or not. So there are two important properties. The very first one is that in case of orthogonal matrix, every row is perpendicular to every other row, right? If you take any row vector, and if you take the dot product of that row vector with any other row vector, then you should get a 0, right? For example, here let us say this is R1, and then this one is R2, and finally this one is R3. Now here if you take R1 dot R2, let us say R1 is this vector where we have cos theta, 0 and minus sine theta as x, y and z component. So if I take R1 dot R2, then we should get a 0. Clearly you can see cos theta into 0, 0 into 1, and then minus sine theta into 0. Or if you take R1 dot R3, then also the result will be 0, right? You can take any one row and any other row, and those two row vectors, they are perpendicular vectors. That means their dot product will be 0. You can take R1 R2, R1 R3, or R2 R3. And same thing you can say for columns also. That means first column C1, this is perpendicular to C2, right? First column C1, this is perpendicular to C3. And similarly, second column C2, this is also orthogonal to C3. Hence the name orthogonal matrix. In case of orthogonal matrix, every row vector and every column vector, they are perpendicular to every other row or column vector, right? R1, R2 are perpendicular, R1, R3 are perpendicular, and so on, right? So, and also all the row vectors and column vectors, they are unit vectors. That means if I take vector R1 dot R1, then the result will be 1. Same thing you can do for R2 dot R2 or C1 dot C1. For example, here R1 is cos theta, 0 and minus sine theta. If I take the dot product with itself, then we'll get cos square plus sine square, which is 1. So if you are familiar with this property of orthogonal matrix, then by observation you can tell that matrix A is orthogonal matrix, and that will imply that if we have orthogonal matrix, then it means A into A transpose, this must be identity matrix, right? So here it is given that A square, this is same as A transpose. Now if A square is A transpose, you can multiply both sides by matrix A, and then on left hand side we have A cube, and right hand side will be A into A transpose, which is identity matrix, because the given matrix is orthogonal matrix. And now the problem becomes much easier. We need sum of diagonal elements or the trace of this matrix. Now let us say this matrix is B. So first we are going to simplify this matrix B, and then we'll calculate trace of matrix B. And for simplifying, we can use A plus B whole cube formula. So this matrix B, this will be, and because these are commutative matrices, we can use those binomial theorem, binomial expansion of A plus I raised to 3. So this will become A cube plus 3A square plus 3 into A plus I. Remember, generally matrix multiplication is not commutative. That means AB and BA, these two are not same. And therefore, we cannot use the standard formula of A plus B square or A plus B cube and so on. But if one of the matrix is identity matrix, then it becomes commutative. A into I, this is same as I into A. And therefore, we can use those formula of A plus B cube or A plus B square and so on. So this will be matrix A plus I cube. Similarly, A minus I cube, that will be A cube minus 3A square plus 3A minus I minus 6A. And now you can see that 3A plus another 3A minus 6A. So these three will cancel. 3A square minus 3A square will cancel. I and minus I, these two will cancel. So basically matrix B, this is twice of A cube, and A cube was same as I. That means after simplification, this matrix B is nothing but 2 into I. We need a trace of this matrix B. So trace of matrix B, this will be twice of trace of identity matrix. And for 3 cross 3 identity matrix, sum of diagonal elements, there will be 3. So therefore trace of I, which is trace of I, that will be 3, and hence trace of matrix B, this will be 2 into 3, which is 6. So the correct answer for this problem will be 6. Now this was important concept because if you are familiar with this definition of orthogonal matrix, then simply by observation you can identify whether a matrix is orthogonal or not. Otherwise, you will have to calculate A into A transpose, right? So always remember that in case of orthogonal matrix, every row is perpendicular to every other row. Same thing for column. And each row vector and column vectors, they are unit vectors. That means if you take dot product of row vector with itself, we must get 1. And also for orthogonal, you can remember one more result, that because A into A transpose, this is identity. In case of orthogonal matrix, A inverse, this is same as A transpose. Because if two product of two matrices is I, identity matrix, then each one is inverse of other. So for orthogonal matrix, inverse is nothing but transpose of the matrix, right? So for this problem, I mean, after simplification, matrix B was 2I, and therefore trace of matrix B, this will be 6. And that is the correct answer for this problem. Let P be this 2 cross 2 matrix. Matrix A is 1 1 0 1, and then we have this matrix Q, which is PAP transpose. If this matrix P transpose Q raised to 2027 multiplied by P, if this is ABCD, then we have to find the value of 2A plus B minus 3C minus 4D. Now, in this problem, if you are familiar with properties of orthogonal matrix, then directly you can see that this matrix P, this is orthogonal matrix, right? For orthogonal matrix, generally we learn this definition that in case of orthogonal matrix, A into A transpose, this is identity matrix. But this definition is not sufficient if I have to identify an orthogonal matrix by observation, right? If I use this definition, then first we have to find A into A transpose, and only when this is identity matrix, then we can claim that this matrix P, that will be orthogonal, right? But if you are familiar with properties of orthogonal matrix, then you can very easily see that this matrix will be orthogonal. Here, that matrix is represented by P, so I'll use the same letter P, right? So there are two very important properties of orthogonal matrix. The first one is that in case of orthogonal matrix, any two row or any two columns, they are perpendicular to each other. That means if I take dot product of R1 and R2, R1 is this row vector where you have, I mean, you can think of this as vector in 2D, and these two are X and Y component. So R1 is root 3 by 2 I plus 1 by 2 j, I and j unit vector along x and y axis, and similarly R2 is this vector. So if I take dot product of these two, clearly you can see that you will get minus root 3 by 4 plus root 3 by 4, which is 0. Right, for 3 cross 3 matrix, R1, R2 are perpendicular, R1, R3 are perpendicular, and similarly R2 and R3, those two are perpendicular. Any two row, they will be perpendicular. And same thing you can say for columns also. That means for this 2 cross 2 matrix, if you take dot product of C1 and C2, C1 means first column, C2 means second column. So again, their dot product will be 0, right? So in case of orthogonal matrix, any two row or any two columns, they are perpendicular. And also they are unit vectors. The row vectors and the column vectors, they are unit vectors. That means R1 dot R2 or the magnitude of this vector R1, this will be one unit, right? You can see that root 3 by 2 and 1 by 2. If I calculate the magnitude of this vector, then we'll get 3 by 4 plus 1 by 4, which is 1. Now, if you are familiar with this result, then many times by observation you can identify an orthogonal matrix. So this matrix P, this is orthogonal matrix, and therefore it will satisfy this condition also, that P into P transpose, this will be identity matrix. Now Q is another matrix which is PA P transpose, and we have to find Q raised to 2027. So first let us try to calculate Q square and then see what is the pattern we are getting here. So if I calculate Q square, then this will be Q into Q, which is PA P transpose, and that multiplied by PA and then P transpose. Now remember, for orthogonal matrix, P into P transpose is identity and P transpose into P, that is also identity. That means product of these two matrices, that will become identity matrix, and therefore Q square, this will be P into A square, and that multiplied by P transpose. In fact, in similar manner, you can show that Q raised to N, this will be P A raised to N and then P transpose. Now this is one very important result, because if I have to calculate Q raised to 2027, so that will be nothing but P A raised to 2027, and that multiplied by P transpose, right? Now let us say that this matrix is matrix B, right? Ultimately, we have to calculate this matrix B. So let us call that matrix as matrix B. So matrix B is P transpose Q raised to 2027. Q raised to N was this one. So Q raised to 2027, that will be P A raised to 2027, and that multiplied by P transpose. This one is Q raised to 27, and that multiplied by P. So this is our matrix B. Now again you can see that because matrix P was orthogonal matrix, P transpose into P, this is identity. P transpose into P, this one is also identity. So that means matrix B, this is nothing but A raised to 2027. And matrix A is given. From there we will calculate A raised to 2027, and then by comparing we can find A, B, C, D, right? So matrix A was 1, 1 on diagonal, right? This was matrix A. We have 1 and 1 on diagonal. Let us try calculating A square. So A square will be A into A. Matrix A was, we have 1 on diagonal, and the off diagonal elements, one of them was 0 and the other one was 1. So A square will be 1 and then 1. I think this element was 1 and here we had 0. Let me check this one. This was matrix A. So A square, this will be nothing but matrix A multiplied by matrix A. And this is again very standard matrix, right? There are many problems where you will find this type of matrix. So here if I calculate A square, then we can multiply first row and first column. So the result will be uh, you will get the same thing. On diagonal, you will get 1 and 1 only. And in place of off diagonal entry, I mean first row, first column, so that will give us 1. First row, second column, that will give us 2. Second row, first column, that will be 0. And second row, second column, that is again 1. This is A square. In similar manner, you can show this on your own, that if you calculate A cube, you will get 3 here and the other elements will remain same. So that means uh, you can calculate A cube, and from there you can see the pattern. So A raised to 2027. Now we can directly write this one, right? For matrix A, we had 1 and 1 on diagonal, and this was 0, and this element in first row, second column, that was 1. For a square, we got 2 here. For a cube, you will get 3 here. Right? That calculation you can do on your own. So for a raised to 2027, we'll have 1 on diagonal. Here we'll have 0, and this entry will be 2027. And now this should be matrix A, B, C, D. So from there, we can calculate A, B, C, and D. Ultimately, we need this value 2A plus B minus 3C minus 4D. So this was our matrix A, B, C, D. So here if I compare the corresponding elements, so 2A, that will be nothing but 2, right? Matrix 2A, this will be 2. Then B will be 2027. And then C, that will be 0, so minus 0. And again D is 1, so that means minus 4D means minus 4. So this number will become 2009 minus 4, which is 2025. So the correct answer for this problem will be option D. Right? In this problem, the important concept was you should know the properties of orthogonal matrix, because this definition is not sufficient to find orthogonal matrix by observation, right? I mean, how it will click during exam that we have to calculate P into P transpose, right? There are so many different type of matrices. So if we are familiar with properties of those matrices, then directly we can see that this is orthogonal matrix, because C1, C2, those two are perpendicular, R1, R2 are perpendicular, and they are unit vectors also. If it is orthogonal matrix, then P into P transpose will be I, therefore Q raised to N P A raised to N into P transpose. So finally this matrix B, this was nothing but A raised to 2027. Matrix A was given, from there we calculated A square, and then we got this pattern that for A square we have 2, for A cube you will get 3. So for A raised to N will get N here. Other elements will remain same. So now by comparing the corresponding elements, we got the value of A, B, C, D. Finally, the correct answer for this problem is option D. Let A be a 3 cross 3 matrix. Determinant of A is 2 and N is determinant of adjoint of A, and here we have this adjoint 24 times. If this number N is divided by 9, then we have to find the remainder, right? So this is another interesting problem from matrices and determinant, and it also involves concepts from binomial theorem, right? How to find remainder when a number is divided by another number. So first of all, this given number n, I'll represent this number by capital N. So let us say this number n, this will be determinant of A raised to n minus 1 and that raised to k. This is the standard formula for finding determinant of adjoint of a matrix, where adjoint is given a number of times. In this formula, n is the order of matrix. For example, here we have 3 cross 3 matrix, so that means n will be 3. And k is the number of times we have adjoint. For example, here we have adjoint 24 times. So that means k will be nothing but 24. So determinant of A is 2, n is 3, so n minus 1 will be 2, and then this raised to 2024. This is number n, and this number is divided by 9. So then we have to figure out the remainder. Now remember, when we are dividing by 9, we have to see that which exponent of 2, that will be multiple of 9 plus minus 1, right? So clearly you can see that 2 cube, this will be 8, and 8 is nothing but 9 minus 1, right? So here basically first we'll try to identify this number 2 raised to 2024, right? We'll try to figure out that 2 raised to 2024, is it multiple of 3, multiple of 3 plus 1, or multiple of 3 plus 2, right? Because that will give us, that will, in that manner, we can write this as 2 raised to multiple of 3 plus something, and then we can use the binomial expansion, because 2 cube is 9 minus 1 and we are dividing by 9. So here 2 raised to 2024, this you can write as minus 1 plus 3, and this raised to 2024. And now if I expand it using binomial theorem, then clearly you can see that minus 1 raised to even power, that will be 1, and after that all the other terms will be multiple of 3. So that means 2 raised to 2024, this is nothing but multiple of 3 plus 1. So therefore we can write this number n as 2 raised to multiple of 3 plus 1, right? 2 raised to 2024. 2024 is multiple of 3 plus 1. So this number n will be 2 raised to 3m plus 1, where m is some positive integer. Now here you can separate this 2, and then this we can write as 2 cube raised to m, and 2 cube is 8. 8 is minus 1 plus 9. So we have minus 1 plus 9 raised to m, right? We are trying to write this number capital N as multiple of 9 plus something, so that we can get the remainder. Now this becomes 2 into, and then if I use binomial theorem here, then we'll get minus 1 raised to m plus, and after that all the other terms will contain at least one 9, right? Next term will be mc1 into 9 raised to 1, next term mc2 9 square, and so on. Alternately we have to change the sign because of this minus 1, but the point is that only this first term will not contain 9. After that all the other terms, there will be multiple of 9 only. So therefore we can write this number as minus 1 raised to m plus 9 into some integer k, right? K is some integer. So now we have to find whether m is odd number or even number, because if m is odd number, then minus 1 raised to m will be odd, and if m is even number, then minus 1 raised to m, that will be even number. So for that we have to see this equation, right? We got 2 raised to 2024. This was multiple of 3 plus 1. Left hand side is even number. 2 raised to 2024, that should be even number. So that means right hand side must be even. If 3m plus 1 is even, then 3m must be odd. And if 3m is odd, m must be odd number, right? Because if m is even number, then 3 into m is even. Even plus 1 will be odd, and the left hand side is even. So then we cannot make the two sides equal. So from here you can very easily see that m must be odd number. Then only we can make the two sides equal, right? So if m is odd number, then this number n, this will become 2 into, and multiple of 9 minus 1, right? Minus 1 raised to odd number, that will be minus 1. So therefore this number n, this will be 2 into multiple of 9 is still multiple of 9 minus 2. Right, so the required number n, this will be of the form multiple of 9 minus 2. And if I divide this number by 9, then the remainder will be minus 2 plus 9. Right, remainder is never negative. If we get negative remainder, that means we have over divided. So that means we need to add 9 here. So if the number is of the form multiple of 9 minus 2, that means it is of the form multiple of 9 plus 7. Right, so if we divide by 9, the remainder must be 7. So therefore the correct answer for this problem, that will be 7, right? So this was one very interesting problem from matrices and determinant, and also it has concepts from binomial theorem. From matrices and determinant, this number n will be 2 raised to 2 raised to 2024, because adjoint was 2024 times and n is 3. And then first we have written 2 raised to 2024 as multiple of 3 plus 1. And then after that, finally we got this number n as multiple of 9 minus 2. If we divide this number by 9, the remainder will be 7. And therefore, the correct answer for this problem is 7. Consider the system of linear equations. There are 3 equations and 3 unknowns x, y, z, right? 3 variables. If this system of linear equation has infinitely many solutions, then we have to comment about another system of linear equation in K, right? Variables are x and y, and we have this system of linear equation, two equations, two unknowns, right? And we have to comment about this system of linear equation, that whether it will have unique solution or no solution or infinite number of solution, right? And also for unique solution, there are two different cases. Now, we know that for infinitely many solutions, right? If we have a system of linear equation, three equations, three unknowns, then for infinitely many solutions, the condition is that determinant of coefficient matrix, this is 0, and then delta 1, delta 2, and delta 3, these three are also 0, right? This is the condition for infinitely many solution. Now, because there is only one unknown in this equation, k, so using this condition, delta equals to 0, we can get the value of that k, right? And once we have the value of k, then we can comment about this system of linear equation, that whether it will have which one of these options: unique solution, no solution, or infinitely many solutions. So first of all, let us equate the determinant of coefficient matrix to 0 and then see what is the value of k that we are getting, right? So because it has infinitely many solutions, the determinant of coefficient matrix must be 0. That is necessary condition but not sufficient condition. Sufficient condition will be that delta is 0 and these three are also 0. But because we have to find the value of this unknown k only, there is only one unknown. So by equating delta to 0, we can get the value of that k. So for delta, the first row will be 1, 1, and then k. Second row will be 2, 3, and minus 1. These are nothing but coefficient of x, y, and z. First row means coefficient of x, y, z in first equation. Similarly, second and third equation. So third row, this will be 3, 4, and 2. So this is the determinant of coefficient matrix. And because the system of linear equation has infinitely many solutions, this must be 0. Right? So if I expand along, first row will get 1 into and then 3 into 2, 6 plus 4. So that will be 10 minus 1 into and then 4 plus 3, that will be 7, and then plus k into 8 minus 9, that is minus 1, and this must be 0. So from here we'll get k equals to 10 minus 7, that is 3. So this is the value of k that we are getting. Right? If the system of linear equation has infinitely many solutions, then k must be 3. And now let us substitute that value here in this equation and try to see what type of equation we are getting. So if k is 3, the first equation will be 4x plus 5y, and this equals to 7. Second equation will be, in place of k, if I write 3, then we have 7x plus here we'll get 3 plus 5, so that is 8y, and on right hand side we'll get 10. Right, so this is the system of linear equation. Now for two equations, two unknown, we know the condition. I mean, if we have this system of linear equation, a1x plus b1y plus c1 equals to 0, and another system of linear equation, a2x plus b2y plus c2 0. So these are nothing but equation of a straight line in 2D, right? Linear equation in x and y, that will represent a straight line in 2D. And if a1 by a2, this is not equal to b1 by b2, then it means the lines are not parallel, and in that case we'll get unique solution. Also, for infinitely many solution, a1 by a2 is equal to b1 by b2. It's same as c1 by c2. And for no solution, these two are equal. a1 by a2 same as b1 by b2, but not equal to c1 by c2. That means in that case the lines are parallel. So here if you notice, we are getting this first case, right? a1 by a2 4 by 7. This is not same as 5 by 8. Or clearly for these two lines, their slopes are different. So that means we'll get a point of intersection between these two lines, and therefore we'll have unique solution. So no solution and infinitely many solution, these two options are incorrect. Now we have to check whether we are getting solution satisfying this condition, x minus y equals to 1 or x plus y equals to 1. So for that, either you can solve these two and then find sum or difference of those two roots. But here directly also you can see that if I do 2 minus 1, right? If I let us call this equation as 1 and this equation as 2. So if you do equation 2 minus 1, then you will get 7 minus 4, which is 3x, and 8 minus 5, which is 3y, and right hand side 10 minus 7, that is 3. Divide by 3, and then we have this option x plus y equals to 1. So therefore, this system of linear equation will have unique solution satisfying this condition, x plus y equals to 1. That means sum of those two, when the sum of solution, that x plus y, that will be 1, right? So this was a problem where first we had to find the value of k using the condition that this system of linear equation has infinitely many solutions. So for that, condition is delta 0, and then delta 1, delta 2, and delta 3, those three are also 0 because there was only one unknown k. So by equating delta to 0, we got k as 3. Once we have k as 3, we got these two equations. And because a1 by a2 is not same as b1 by b2, the lines are not parallel, we'll get unique solution. And if we do 2 minus 1, then the solution will satisfy this condition, x plus y will be 1. So therefore, the correct answer for this problem is option C. If alpha, beta, gamma are the real roots of this cubic equation, it is given that A, B, C belongs to R and A and B, these two are non-zero. If this system of linear equation in U, V, W, we have a system of linear equation in U, V, W, and as you can see that right hand side is 0, which means we have homogeneous system of linear equation. So if this system of linear equation has non-trivial solution, right? For homogeneous system of linear equation, one of the solution is all the three variables are 0, and non-trivial solution means at least one of those three is non-zero, right? So if this system of linear equation has non-trivial solution, then we have to find the value of a square by b. Now this is one very interesting problem from JEE Main 2021. First we'll see, using the condition for non-trivial solution, we'll try to find relation between alpha, beta, gamma, and then those three numbers are the root of this cubic equation. So from there we have to get a, a relation between a square by b. Ultimately we have to find a square by b. So we know that for non-trivial solution, the condition is that determinant of coefficient matrix must be 0, right? Delta must be 0 for non-trivial solution of a system of linear equation, right? Now here if I equate the remember system of linear equation is in u, v, w. So alpha, beta, gamma, they are constant. They are the coefficients of u, v, w. So if this system of linear equation has non-trivial solution, then determinant of coefficient matrix that must be 0. That means alpha, beta, gamma, and then beta, gamma, alpha, and then finally gamma, alpha, and beta. This will be the determinant of coefficient matrix, and this has to be 0. Now here if you notice, this is a cyclic determinant, right? In case of cyclic determinant, we have these terms. You have alpha, beta, gamma, then next row is beta, gamma, alpha, and then gamma, alpha, beta. So this is one standard determinant, right? If you expand this determinant, you will get the value as alpha cube plus beta cube plus gamma cube and then minus 3 alpha, beta, gamma, right? And this has to be 0. Now, using the formula for a cube plus b cube plus a cube minus 3abc, this we can write as alpha plus beta plus gamma, and this multiplied by alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma alpha, and this must be 0. Now, there are two factors here. One is alpha plus beta plus gamma, and the other one is this uh, quadratic factor in alpha, beta, and gamma, right? Now, if product of these two is 0, then there are two possibility. Either alpha plus beta plus gamma will be 0. This is one possibility. Or another possibility will be that this second term is 0, which means alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma alpha. This should be 0. Now remember here it is given that alpha, beta, gamma, they are the real roots. This word real is important here because in basic maths we learned this concept that if we have three numbers, right, three variables which are real numbers, and if a square plus b square plus c square minus ab minus bc minus ca, this is 0, then this one is possible only when all of these three variables are equal, right? Alpha, beta, because this you can write as perfect square, right? If you talk about the second term, so I'll just write the formula for the second one. This becomes half of, and then you have alpha minus beta square, right? The second term, this is half of alpha minus beta square, then beta minus gamma square, and then gamma minus alpha square. And if this thing is 0, and alpha, beta, and gamma are real numbers, so that means each one of these three values must be 0, right? If we have three perfect square, so perfect square cannot be negative, right? It will be either positive or 0. And if their sum is 0, then each one of these three terms must be individually 0, which means alpha and beta are equal and beta and gamma are equal, right? So from here, you can remember this as standard result that the cyclic determinant is 0 if alpha plus beta plus gamma is 0, or alpha, beta, gamma, all of these three variables are equal. right? This is one standard result that you can remember for cyclic determinant. Now notice here that alpha, beta and gamma, they are the roots of this cubic equation. So if I apply the formula for uh, sum of roots, so alpha plus beta plus gamma, and this must be minus a by 1, right? Minus coefficient of x square by coefficient of x cube. So this must be minus a, and it is given that a and b, these two are non-zero, right? That means we cannot have the first possibility, right? For non-trivial solution, the cyclic determinant will be 0. If this one is 0, then either alpha plus beta plus gamma is 0, or all of these three, they are equal. Now, in this quadratic equation, sum of the three roots will be minus a, and because it is given that a and b are non-zero, so we cannot have alpha plus beta plus gamma 0, which means all of these three must be equal. So from here, if beta and gamma are same as alpha, you can say that a must be minus 3 alpha. So this is the value of A in terms of alpha. A has to be minus 3 alpha. And now here if I use uh, alpha into beta, right? Sum of product of root taken two at a time. So alpha beta plus beta gamma plus gamma alpha. So this must be b by coefficient of x cube, right? Coefficient of x by coefficient of x cube. So this must be b. And because it is given that alpha, beta, and gamma, these three are same. So each one of these three terms will be alpha square. That means b has to be 3 alpha square. Right. So now a is minus 3 alpha and b is 3 alpha square. We have to find a square by b. Right. So just substitute the value here. A square means we have 9 alpha square and b means 3 alpha square. Alpha square you can cancel. Ultimately, you will get 9 by 3, which is 3. So the correct answer for this problem will be option B. Right. So in this problem, using the condition for non-trivial solution, delta will be 0. Right. For homogeneous system of linear equation, for non-trivial solution, delta must be 0. And delta was the cyclic determinant. The cyclic determinant is 0 only when alpha plus beta plus gamma is 0, or alpha beta gamma, all of these three are same. Now because alpha plus beta plus gamma is minus a, right, using the relation between roots and coefficient of this cubic equation, and it is given that a and b, these two are non-zero, so therefore alpha plus beta plus gamma cannot be 0. That means all the three roots must be equal. From there we got a as minus 3 alpha, b as 3 alpha square, a square by b, that will be 9 alpha square by 3 alpha square. So finally the correct answer for this problem will be option B. Consider the system of linear equation. We have three equations in three variables, and in third equation there are two unknowns, lambda and nu. Right, first two equations are given, and in equation 3 there are two unknowns, lambda and nu. These two are real numbers. If this system of linear equation has infinitely many solutions, then we have to find the number of solution of this system of linear equations satisfying this condition that x plus y plus z, this is between 7 and 77, and x, y, z are integers. Now, the general method of solving this problem is to find the value of lambda and nu using the condition that this system of linear equation, this has infinitely many solutions. We know that for infinitely many solutions, the condition is delta is 0, that is determinant of coefficient matrix is 0. So from there you will get the value of lambda, and then delta 1, delta 2 and delta 3, these three are also 0. This is the condition for infinitely many solutions, right? But if you are familiar with the basics of system of linear equation and their condition for consistency and so on, then there is no need to find lambda and nu from here, right? If this system of linear equation has infinitely many solutions, then this third equation is not any independent equation. Equation 3, or in 3D, three equations equations in XYZ, linear equations in XYZ in 3D, that is equation of plane. So if we have infinite number of solutions or infinitely many solutions for this system of linear equation, then basically this third plane, this is passing through the line of intersection of first two planes. So therefore this third equation will not give us any independent information, right? Equation 3 will be some combination of equation 1 and 2. So here basically we need to focus on equation 1 and 2 from here try to find values of any two variable in terms of third variable and then substitute in this equation. For example, you can write x and y in terms of z, or you can write y and z in terms of x, right? Any two variable we have to express in terms of third variable and then substitute that value here. So from there we can see what are the different possibilities, what are the different integral values of these variables which will satisfy this condition, right? So for doing that, let us try solving equation 1 and 2. Let us try to write any one variable in terms of third variable using equation 1 and 2, and there is no need to calculate lambda and nu here. So if I want to eliminate any one variable, let us say if I want to get rid of z, then we can multiply this first equation by 3. That means we can write that 3x plus 5y plus, if we multiply by 3, then 3x plus 15y minus 3z, this will be 3. And the second equation, this is 4x plus 3y minus 3z, this equals to 7. And now we can do 2 minus 1, right? If we do 2 minus 1, then you can see that 4x minus 3x, that will be x. 3y minus 15y, so that is minus 12y. Z will cancel, and 7 minus 3, that will be 4. So from here we can write x in terms of y, right? We can write x as 12y plus 4. Our aim is to express any one variable in terms of other two variable. We got x in terms of y. X is 12y plus 4. Now substitute that value in any one of these two equations. Let us say first equation. So in place of x, I'm writing 12y plus 4 and then plus 5y minus z, this is 1. That means from here we'll get z in terms of y. In fact, z will be 12 plus 5, that is 17y, and 4 minus 1, 3. So this is the value of z in terms of y, right? So we got x in terms of y, we got z in terms of y, and now the given relation is that x plus y plus z, this is between 7 and 77. So that means x is 12y plus 4, then y, and in place of z we have 17y plus 3, and this should be between 7 and 77. And now let us see how many integral values of y are possible from here. So 7 we can remove, so then we have in 4 plus 3, that will be 7, and then 17 plus 1, 18 plus 12, right? Maybe we can write few more lines here. So 7, and here we have 30y plus 7, and the right hand side, this is 77. Now subtract 7 from here, so then we have 30y, this is between 0 and 70. So from here clearly you can see that the integral values of y, because it is given that x, y, z, they are integers only. So you can take y as 0, or you can take 1 or 2, right? If I take y as 3, then it will not satisfy this inequality. So these are the three possible values of y. And corresponding to these values of y, you will get values of x from here and values of z from this relation, that z was 17y plus 3. So basically, these are the three integral values of y, 0, 1 and 2. And each integral value of y will give us some value of x from here and some value of y from here. The problem was that we need to find number of solution of this system of linear equations satisfying the given condition. So there are three integral solutions, y, 0, 1 and 2. And then x and z we can calculate. We do not need the exact solution, we need number of solution. So there are three solutions, right? So therefore the correct answer for this problem will be option C. Now in most of the solutions you will find that they will first try to calculate lambda and nu using these conditions for infinitely many solutions, but there is no need to calculate those things. You can directly start with equation 1 and 2, because if we have infinite number of solutions, then this plane 3, this is passing through line of intersection of plane 1 and 2, and that will mean that plane 3 will not give us any independent equation, right? It will be some combination of equation 1 and 2. So we can solve 1 and 2 using equation 1 and 2, write any one variable in terms of third variable. Here we have expressed x and z in terms of y, and then substitute in this equation. right? So from there we got three integral values of y, and hence the number of solution for this system of linear equation under the given condition, that will be 3. A is this 2 cross 2 matrix. If sum of the diagonal elements of A raised to 13, this is 3 raised to n, then we have to find the value of n. Now, in most of the resources, you will find that for calculating the trace of this matrix A raised to 13, sum of diagonal elements is nothing but the trace of the matrix. So for finding trace of A raised to 13, they will multiply this matrix A. First, they will calculate A squared, then A raised to 4, A raised to 8, and so on. And then they will calculate the sum of diagonal elements. But there is another much easier method of solving these type of problem. And in last few years in JEE Main, you will find that there are a number of PYQ where some matrix is given, and you have to find sum of diagonal elements of that matrix raised to some large power like 13, 15, and so on. So these type of problems one can easily solve if you are familiar with the concept of eigenvalues of a matrix and properties of eigenvalues. Right, first we'll talk about what is eigenvalues of a matrix. We already know about characteristic equation, right? We learned about characteristic equation of a matrix in Cayley-Hamilton theorem. So from there we can find eigenvalues of a matrix. And then there are few properties of eigenvalue that you should know. So then these type of problems you can solve within few seconds. So basically eigenvalues are nothing but they are but roots of characteristic equation of a matrix. And what is characteristic equation? Determinant of A minus lambda equals to 0. So that means from diagonal elements, we subtract lambda and then equate the determinant to 0. So from there, we get a polynomial equation in lambda. For 2 cross 2, we'll get quadratic equation. For 3 cross 3, we'll get cubic equation and so on. So that equation is called characteristic equation of the matrix. And the root of this characteristic equation, they are called eigenvalues, right? Also for 2 cross 2 matrix, there is one direct formula also to write characteristic equation, lambda square minus trace of A into lambda plus determinant of A, this equals to 0. Using this formula in one line, you can write the characteristic equation of any 2 cross 2 matrix. And the root of this characteristic equation, they are called the eigenvalues of the matrix, right? So let us say for this quadratic equation, the roots are lambda 1 and lambda 2. So these lambda 1 and lambda 2, they are eigenvalues of this matrix A. Now, there are few properties of eigenvalue that you should know. The very first property is that if you multiply the eigenvalues of a matrix, then you will get determinant of the matrix, right? Product of eigenvalue, this is always determinant of A, which is obvious from here also. For this quadratic, product of root lambda 1 and lambda 2, that will be determinant of A. Similarly, if you find the sum of eigenvalues, right, if you calculate the sum of eigenvalues of a matrix, I'm writing for 2 cross 2, but this is valid for any general n cross n matrix. So product of eigenvalue, this is determinant of the matrix, and sum of eigenvalue, this is nothing but trace of matrix, right? So these are the two most frequently used properties. And for solving such type of problem where you need trace of A raised to n, there is one more property that you should know, and that is for a matrix A, if the eigenvalues are lambda 1 and lambda 2, again I'm writing for 2 cross 2, but valid for any general n cross n matrix, then for A raised to n, the eigenvalues are lambda 1 raised to n and lambda 2 raised to n. Now, this is very important result because uh, suppose if I know eigenvalue of matrix A, they are lambda 1, lambda 2. So for A square, it will be lambda 1 square, lambda 2 square. For A cube, lambda 1 cube, lambda 2 cube, and so on. So here what we'll do is we'll find the eigenvalues of matrix A, and then for A, let us say for matrix A, the eigenvalues were lambda 1, lambda 2. So what should be eigenvalues of A raised to 13? This will be lambda 1 raised to 13 and lambda 2 raised to 13. That will be eigenvalue of this matrix A raised to 13. And then the trace of this matrix A raised to 13, that will be nothing but sum of the eigenvalues, right? So that means lambda 1 raised to 13 plus lambda 2 raised to 13. So that will be the sequence of steps. First find the eigenvalues of matrix A. From there find the eigenvalues of A raised to 13, and then uh, the trace of matrix A raised to 13, that is nothing but sum of eigenvalues. So Here if I have to find eigenvalues of matrix A, then it will be lambda square minus trace of matrix A. So for matrix A, trace means sum of the diagonal elements. So that will be 2 plus 1, 3. Right? So lambda square minus 3 lambda plus determinant is also 3. So this is the characteristic equation for matrix A. Right? For matrix A, the characteristic equation using that standard formula is lambda square minus 3 lambda plus 3 equals to 0. And now let us try to find the roots of this equation. So clearly you can see that for this equation, the discriminant is negative. So therefore we'll get imaginary roots. The roots will be minus b plus minus root over b square minus 4ac and that divided by 2a, right? So that means one of the eigenvalue, this is 1 by 2 we can take outside. So one of the eigenvalues is 3 plus root 3 iota and the other eigenvalue lambda 2, this is 3 minus root 3 iota. These are the two eigenvalues of matrix A. So now trace of this matrix A raised to 13, this will be nothing but sum of eigenvalues of A raised to 13. And for A raised to 13, eigenvalues are lambda 1 raised to 13 and lambda 2 raised to 13. So now basically we have to calculate this sum and then we'll get trace of matrix A raised to 13. Also this is given as 3 raised to n. So by comparing, we'll find the value of n. Now, in most of the problems, you will get simple eigenvalues, right? Simple integers, but here we are getting a complex number. So if I have to calculate any large power of a complex number, then we know that we have to express that complex number in polar form or Euler's form, and then use the De Moivre's theorem, right? So if I say that this complex number, let us say lambda 1, this I'm representing as Z1. So this is 3 by 2 plus root 3 iota by 2. So now how to write this complex number in polar form or Euler form? So for that we need the modulus and the argument of this complex number. Now modulus of this complex number will be 9 by 4 plus 3 by 4, that is 12 by 4. So root over 3, right? So modulus is root over 3 and the argument is uh, 1 by root 3, so that will be 30 degrees. So that means argument is pi by 6. So the first complex number in Euler form, this will be root 3 e iota pi by 6, this raised to 13. And the second one is conjugate of this one. So that means root 3 e minus iota pi by 6 and this raised to 13. Now root 3 raised to 13, with this we can take common. And then you have e iota 13 pi by 6 and plus the other one will be e iota in fact, e raised to minus iota and then we have 13 pi by 6. Now 13 pi by 6, this we can write as 2 pi plus pi by 6. 2 pi we can remove pi by 6. So cos pi by 6 plus iota sin pi by 6 and from here the imaginary part will cancel. So basically you will get 2 into, in fact this number outside, this was root 3 raised to 13 and here you will get 2 into cos pi by 6 because the iota sine pi by 6, that term will cancel with this conjugate, right? And the real part you will get twice. So cos pi by 6 root 3 by 2, that means ultimately this is root 13 raised to 13 into root 3. That means 3 raised to 7. So from here clearly you can see that value of n, this will be nothing but 7, right? So using this concept of eigenvalues, one can very easily solve this problem. And there are multiple PYQ in JEE Main as well as in JEE Advanced, where using this concept of eigenvalue within few lines, you can solve these type of problems. So for that, just remember these three properties. First of all, eigenvalues, they are roots of characteristic equation. For 2 cross 2 matrix, this is the standard formula to write characteristic equation. Sum of eigenvalues trace, product of eigenvalues determinant, and for a raised to n, the eigenvalues are lambda 1 raised to n, lambda 2 raised to n. So first we calculated eigenvalues of matrix A, then from there we got eigenvalues of a raised to 13, and then trace of this a raised to 13, this is nothing but sum of the eigenvalues. Ultimately, this trace was 3 raised to 7. So therefore, the value of n, this will be 7, and that is the correct answer for this problem. In the binomial expansion of 2 raised to 1 by 3 plus 1 by 3 raised to 1 by 3 and this raised to n, where n is some natural number, if the ratio of 15th term from the beginning to 15th term from the end, this ratio is 1 by 6, right? So then we have to find the value of NC3. So basically, using this ratio, the ratio of 15th term from beginning to 15th term from end is given. This is 1 by 6. So from there, we need to find the value of n. And once we have n, then we need to calculate NC3. Now, before we attempt this problem, there is one simple concept here. If I need a particular term from end in a binomial expansion, so there are two ways of finding that one. One general method is that if I need rth term from end in the binomial expansion of a plus b raised to n, so if the exponent is n, the total number of terms that will be n plus 1. So if I need tr from end, then you can say that this will be t n minus r plus 2 from beginning. Right, this is the general method of finding a particular term from end. However, there is another much easier method where you don't have to deal with these terms. You can directly write a particular term from end. So basically the concept is that if I need a particular term from end in the expansion of a plus b raised to n, so then you can just interchange a and b. Right, so instead of writing a plus b raised to n, you will write b plus a raised to n. And then instead of finding the particular term from end, you will find the term from beginning. That means tr from end in a plus b raised to n. This will be same as tr from beginning in b plus a raised to n. So using this concept, in one line you can write a particular term from end. You don't have to worry that which term is this particular term from beginning, right? So we are going to use that concept here. It is given that T15 from beginning, right? T15 from beginning, and this divided by 15th term from end. So that means T15 from end, and this ratio is given as 1 by 6. Now we have a standard formula for finding a particular term from beginning. If I need T15 from beginning in this expansion, then it will be nothing but 15 NC14, right? The formula for general term is that if I need TR plus 1, maybe I'll write the general formula also. If I need TR plus 1 in A plus B raised to N, then this is NCR a raised to n minus r and then b raised to r. This is standard formula for finding a particular term from beginning. Tr plus 1 ncr a raised to n minus r b raised to r. So if I need 15th term from beginning, it will be nc14 and then first term. So that means 2 raised to 1 by 3. This raised to n minus 14. And then second term, so that means 1 by 3 raised to 1 by 3 and this raised to 14. This is 14th term from beginning in binomial expansion of this one. And similarly, sorry, 15th term. Similarly, if I need 15th term from end, so now we'll just interchange these two. Right now, first term will become 1 by 3 raised to 1 by 3, and this will become second term. So again, T15 from end, this will be NC14. And now the first term is this one, 1 by 3 raised to 1 by 3, and this raised to n minus 14, right? NCR, a raised to n minus r, b raised to r. So this will be a, and then b will be 2 raised to 1 by 3, and this raised to 14. And this ratio is given as 1 by 6. Now from here, we have to find the value of n. Once we have n, then we can calculate NC3 from there. So now let us simplify this one. Clearly you can see that NC14 will cancel, and then you have 2 raised to and n minus 14 minus 14. So that will become n minus 28 and this divided by 3. Right, n minus 14 minus another 14 and this is 2 raised to 1 by 3. So n minus 28 by 3. And similarly, here you will get this term will go in numerator. So that means you have 3 raised to, and again n minus 14 minus 14 from here. So that means n minus 28 and this divided by 3. And on right hand side, we have 6 raised to minus 1. Now for these two number, exponent is same. So you can come basic exponent is same. So you can combine the base. That means this left hand side is 6 raised to this number. So now just equate the exponent and we'll get n minus 28 by 3. This equals to minus 1. So from here clearly you can see that n will be 25, right? That will be the value of n. Now we needed NC3. So NC3, this will be nothing but 25C3. And 25C3, anyone can calculate. After calculation, you will find that this value is 2300. So therefore, the correct answer for this problem will be second option. Right. So in this problem, it was not difficult problem, and the important concept was that whenever we need a particular term from end in binomial expansion of a plus b raised to n, then just interchange a and b and then find the term from beginning. So tr from end in a plus b raised to n, this will be same as tr from beginning in b plus a raised to n. Also, there is another important point here, that while interchanging these two, you will take care of sign also. That means instead of a plus b, if I have a minus b, so then you cannot write this as b minus a, right? Then you will write minus b plus a. You have to change with sign. So if I have a minus b raised to n, and if you need a particular term from n, then you will write minus b plus a raised to n, and then you will find that particular term from beginning, right? So this you have to keep in mind. Now, by taking the ratio of 15th term from beginning, 15th term from end, we got the value of n as 25. We had to calculate NC3, that means we have to find 25C3, which is 2300, and therefore the correct answer for this problem is second option. Find the remainder if this number is divided by 17. Now, in JEE Main, the problem on remainder calculation is very common. Right, if you see the PYQ from last 4 or 5 years, you'll find a number of problems on remainder calculation. Right now, generally, when we are solving problems on remainder calculation, we have one number raised to some other exponent, and this base is a small number, right? But here, if you see this example, we have 2021 raised to 3762. Right, this is the number which is given. N is 2021 and this raised to 3762. Now here our aim will be first to decrease this base, right? First we have to, instead of 2021, we have to convert this into a smaller base, and from there we can see how to find the remainder. Now, in order to decrease this base, basically we'll divide 2021 by 17, right? We'll divide this number by 17. Now, when you divide by 17, you'll find that this number will become 17 into 118 plus 15, right? When you divide by 17, you'll get remainder as 15. So, one way of writing 2021 will be 17 into 118 plus 15. Another approach will be that you can write the same number as 17 into 119 minus 2. Now, we should always prefer this second form. Why? Because in this form, we are dealing with a smaller base, right? If you convert 2021 in this second form and apply binomial expansion, so then at the second stage, you are dealing with minus 2 raised to something. Whereas in first form, we'll get 15 raised to something. So obviously, we have to prefer the second one instead of first one. So we can write this number as minus 2. We'll write in terms of increasing power of multiples of 17. So we'll write this as minus 2 into, and let us call this as 17 into some integer, 17k. So minus 2 plus 17k, and this raised to 3762. Now, when I expand this number using binomial theorem, then the very first term will be minus 2 raised to this number, and because this is even, so we'll get plus sign. So 2 raised to 3762. And after that, only the first term will not contain 17. After that, in the second term, we'll have 17k. Next term will be 17k square and so on. So all of those numbers, they are multiple of 17. Right, only the first term is not multiple of 17. After that, all the subsequent terms, they are multiple of 17. And when you divide this term by 17, the remainder will be 0. So now basically we have to focus on this number 2 raised to 3762. Now again, here we have to see that which exponent of 2 is either 17 plus minus 1 or multiple of 17 plus minus 1. So clearly you can see that 2 raised to 4, this will be 16, and 16 one can write as minus 1 plus 17. Aim is to write multiple of 17 plus 1 or minus 1, or multiple of 17 plus 1 minus 1. So here basically we'll try to write this number as 2 raised to 4, because we want to create 17 here. So 2 raised to 4, and then 3762. 3760 will be multiple of 4, and in fact you will get 940, and this multiplied by 2 square, right? Because this number is not perfectly divisible by 4, so we have taken 2 squares, we have separated 2 square, and then 3760, that will be 4 into 940. And now we have 2 raised to 4, which is minus 1 plus 17, right? 2 raised to 4 will be 16, so that is minus 1 plus 17, that multiplied by, that raised to 940, and this multiplied by 4. 4 we can keep separate. Minus 1 raised to even power, so that will be plus 1. And again, after that, all the subsequent terms, right? The second term will be minus 9c, 940c1, this multiplied by 17. After this, next one will be 940c2, and this multiplied by 17 square, and so on. So only this first term is not multiple of 17. After that, all the other subsequent terms, they are multiple of 17. So basically this number n, this will become 4 into 1, that is 4. And then all these numbers will contain at least 117, right? 17, 17 square, and so on. So all of them are multiple of 17. That multiplied by 4 is still multiple of 17. So basically that given number is of this form, right? Number n, this will be some multiple of 17 plus 4. And when you divide this number by 17, the remainder will be 4. So that is the correct answer for this problem, right? So in this problem, first important concept, that we need to decrease this base. And for decreasing the base, we'll always prefer this second form, because then we are dealing with 2 raised to something. But if we write this in first form, then we'll get 15 raised to this number, right? So obviously, we'll have much easier calculation if I have a smaller base. And then once we have 2 raised to something, 2 raised to 4 is 16, 16 is minus 1 plus 17. And after that, apply binomial theorem. Finally, the number is multiple of 17 plus 4. When you divide by 17, remainder will be 4. And that is the correct answer for this problem. Find the remainder when 19 raised to 200 plus 49 raised plus 23 raised to 200 is divided by 49. Now, before we attempt this problem, there are few important observations. The very first thing is that 49 is a perfect square, right? 49 will be 7 square. Also, you can notice that for these two numbers, we have same exponent 200. One number is 19 raised to 200, other number is 23 raised to 200. So for these type of problem, what we'll do is that we'll try to break this symmetrically, right? We'll try to break 19 and 23 symmetrically about some multiple of 21, right? Between 19 and 23, we have 21, and 21 is multiple of 7. So 19 we can write as minus 2 plus 21, this raised to 200. And 23 you can write as 2 plus 21, and this raised to 200. Because we have same exponent, we are dividing by 49, which is 7 square. 21 is multiple of 7. So here we can break 19 and 23 symmetrically about 21. We can write 19 as 21 minus 2 and 23 as 21 plus 2. Also, I'm trying to write this is expansion in increasing powers of 21, right? So therefore, first I have written minus 2 and then 21. Now you can see that if I expand it using binomial theorem, then in this first expansion, you will get alternate positive and negative terms. In the second one, you will get all positive terms. And the negative term of this first one, that will be cancelled by the positive term of this second expansion. So basically, the expansion will be twice of, and this first term you will get twice. Second term will cancel because it will have same magnitude, but in this first one you will get minus sign, in second one you will get plus sign. And similarly, T3 you will get twice, T4 will again cancel. So the expansion will be 2 into right? All the positive terms you'll get twice and negative term will cancel. So you'll get 2 into 2 raised to 200. 200 C1 term will cancel. So next one will be 200 C2. And this multiplied by minus 2 raised to even power 198. That is 2 raised to 198. And then 21 square. Again 200 C3 term will cancel. And after that you will get 200 C4. 2 raised to 196. 21 raised to 4. Now we are dividing this number by 49. 49 is 7 square. In 21 square, we have 3 square into 7 square. So that means this term is multiple of 21 square and hence it is multiple of 7 square. After that, next term will be 21 raised to 4. That is also multiple of 7 square. So in fact, except for this first term, all the other subsequent terms, they will be multiple of 49. So you can combine all of these terms and you can say that this will become 2 into and then 200 plus another one, so 201 plus some multiple of 49, right? All of these terms, they are multiple of 49, multiplied by 2, they are still multiple of 49. And if you divide the multiple of 49 by 49, the remainder will be 0. So from this term, you will not get any remainder. So now basically we have to focus on 2 raised to 201. And again, we have to think that which power of 2 is 7 plus minus 1 or multiple of 7 plus minus 1, because we are dividing by 49 and 49 is 7 square. So clearly you can see that 2 cube will be 8 and 8 we can write as 1 plus 7. So therefore we'll write this as 2 raised to 3 and this raised to 67. 201 is multiple of 3. 3 into 67 will be 201. So now we'll get 2 cube, this we can write as 1 plus 7 and this raised to 67. Expand it using binomial and we have 1 plus 67 C1 into 7. Next term will be 67 C2 into 7 square. After that, all the other subsequent terms and the last term will be 7 raised to 67. So except for the first two terms, all the other terms, they are multiple of 7 square and hence multiple of 49. Right, 7 square, next one will be 7 cube and so on. So all of these numbers, they are multiple of 49, right? So if I divide this one by 49, the remainder will be 0. So basically we are left with this number. The number n will be 1 plus and then we have 67 into 7 plus some multiple of 49. When divided by 49, they will give us 0 remainder. Now here again you can see that, I mean, in this number we can manually calculate the remainder, multiply these two numbers and then see what is the remainder when we are dividing by 49. But if you want, you can save some time in calculation. 67 you can write as 49 plus 18 and this multiplied by 7. And again 49 into 7, that is multiple of 49. So that you can neglect. So basically we are left with 18 into 7 plus 1. Now 18 into 7 will be 126 plus 1, so that will be 127, right? So basically this number is 127 plus some multiple of 127 plus some multiple of 49. Ultimately the number is of this form. And now just find the remainder in 127 when we are dividing that number by 49. So clearly you can see that if you divide 127 by 49, you will get 98. So 2 and another 27. So that is 29. So if you divide 127 by 49, the remainder will be 29. So that is the correct answer for this problem, right? So I mean, this was a very interesting problem where first we had to break this number symmetrically about 21, because 21 was 3 into 7 and 49 is 7 square. After that, when you expand it using binomial, only this first term is not multiple of 49. All the other terms, they are multiple of 21 square and hence multiple of 49. Now again, this 2 raised to 201, this you can write as 1 plus 7 raised to 67. Expand it using binomial. And now first two terms, they are not multiple of 49. All other terms, they are multiple of 49. So finally, we got 127 plus multiple of 49. When you divide 127 by 49, the remainder will be 29. And that is the correct answer for this problem. Find the remainder when 2023 raised to 2023 is divided by 35. Now, generally we solve these type of problem using binomial theorem, but for this particular problem, there is another interesting approach of attempting this problem. So we'll discuss that another method of solving this problem. First of all, 35 is 5 into 7 and 2023, this is multiple of 7, right? So let us say this number is n. So we can write this number n as 2023 and this multiplied by 2023 raised to 2022. Why I'm separating 12023? Because this is multiple of 7. In fact, you can write this number as 7 into, and then we have 289 and this multiplied by 2023 raised to 2022, right? Now our aim will be to write this number as multiple of 5 plus something, right? 7 we already have outside, and if I can write the rest of this number as multiple of 5 plus some number lambda, where lambda can take any values between 0 and 4, right? Lambda will be either 0 or 1 or 2 or 3 or 4, because if we are dividing a number by 5, then you can have remainder between 0 and 4. So our aim will be to write this number 289 into 2023 raised to 2022. And because we already have one 7 outside, in next step you can see that this will become 7 into 5, that is 35m plus 7 lambda. And 35 into m is obviously multiple of 35. So from here we can get the remainder. So now basically the problem becomes that what is the remainder when this number, let us call that number n1. So now the problem becomes that we have to find the remainder when 289 and this multiplied by 2023 raised to 2022, this is divided by 5. We have to write this number as multiple of 5 plus some remainder, so that in next step we can get the remainder when the number is divided by 35. Now in order to find the remainder when a number is divided by 5, we have to find the digit at unit place of that number. If I can get the digit at unit place of this number n1, then we can easily see what will be the remainder when we divide this number by 5. Also, for finding the digit at unit place, only the unit digit is significant, right? For example, that means that digit at unit place of this number 2023 raised to 2022 will be same as the digit at unit place of this number 3 raised to 2022. All the other numbers, they are irrelevant when we are calculating the digit at unit place. And for finding the digit at unit place of this number 3 raised to 2022, we can use cyclicity. That means if you see the digit at unit place in different exponents of 3, 3 raised to 1 is 3. For 3 square, the digit at unit place will be 9. For 3 cube, the digit at unit place will be 7. For 3 raised to 4, the digit at unit place will be 1. And once you get 1, you will get the same pattern again. That means the digit at unit place in different exponents of 3 will be 3971. Again, you will get 3971 and so on. So whenever the exponent of 3 is multiple of 4, the digit at unit place will be 1. That means 3 raised to 4, 3 raised to 8, 3 raised to 12 and so on. At unit place, you will get 1. Whenever the exponent is multiple of 4 plus 1, that means 3 raised to 1 or 3 raised to 5 or 3 raised to 9 and so on, the digit at unit place will be 3. Similarly, whenever the exponent is multiple of 4 plus 2, the digit at unit place will be 9. Here this number 2022, this is nothing but multiple of 4 plus 2, right? 2022 you can write as 2020 plus 2. So the exponent of 3, this is multiple of 4 plus 2, and whenever the exponent of 3 is multiple of 4 plus 2, the digit at unit place will be 9. So basically in this number 2023 raised to 2022, the digit at unit place will be 9. That 9 multiplied with 289 will give us 1 at unit place. So that means in this number n1, the unit digit will be 1. And if we divide this number by 5, then what should be the remainder? If we have 1 at unit place, and if we divide that number by 5, the remainder will be 1. right? So this number 289 into 2023 raised to 2022, that you can write as multiple of 5 plus 1, and that means this number n will be 5m into 7, so that is 35m plus 7. So finally the number n is of this form. The number n will be multiple of 5 plus 7, and if you divide this number n will be multiple of 35 plus 7, and if you divide this number by 35, the remainder must be 7. So that is the correct answer for this problem, right? So you can see that without using binomial theorem, simply by using the cyclicity, we got the remainder in this problem. First observation, this number 2023, this was multiple of 7, and 35 is 5 into 7. So we have taken one 7 common, and then we have written rest of the numbers as multiple of 5 plus something. When we divided that number by 5, because we had 1 at unit place, we got 1 as remainder. So therefore this number will be 5m plus 1. Finally the number n will be multiple of 5, multiple of 35 plus 7. When you divide by 35, remainder will be 7. And that is the correct answer for this problem. We have this number n equals to 25 raised to 190 minus 19 raised to 190 minus 8 raised to 190 plus 2 raised to 190, and we have to check whether it is divisible by 14 and whether it is divisible by 34. Now before we attempt this problem, there is one important concept that we have to learn, because here you can see that for all of these numbers we have same exponent 190, right? So whenever you have same exponent, then you can use the following concept that we are going to discuss. In fact, there are two concepts. So the very first one is that if I have a raised to n minus b raised to n, where n is some natural number, some positive integer, so this is always multiple of a minus b, right? A raised to n minus b raised to n, this is always multiple of n, multiple of a minus b. N is any natural number. And if n is even number, then this is multiple of a plus b also. And using factor theorem, one can easily prove this result also. So if n is even number, then it will be multiple of a plus b. So a raised to n minus b raised to n, that is always multiple of a minus b. That means a square minus b square, or a cube minus b cube, and so on. They will always have this factor a minus b. And if the exponent is even number, for example, a square minus b square, or a raised to 4 minus b raised to 4. So all of them, they are multiple of a plus b also. And there is another related concept, although not useful in this problem, but in some other problem you can apply, that if I have a raised to n plus b raised to n, so in that case, this will be multiple of a plus b, right? This is multiple of a plus b if n is any odd natural number, right? So for example, if I have a cube plus b cube, or a raised to 5 plus b raised to 5, so then it is always multiple of a plus b. So these are the three things that you should know. Now we can proceed with this problem. The given number is 25 raised to 190 minus 19 raised to 190 minus 8 raised to 190 plus 2 raised to 190. And you can see that for all of these numbers, we have same exponent, and we have to find whether it is divisible by 14 or 34 or both of them. Now here, first of all, you can very easily check that whether this number is odd number or even number, right? Because then if I have to check whether a number is multiple of 14 or not, so a number will be multiple of 14 if it is multiple of 2 as well as multiple of 7. Similarly, it will be multiple of 34 if it is multiple of 2 and multiple of 17. So here 25 raised to 190, this will be odd number. 19 raised to 190, another odd number. Odd minus odd will be even. And the other two numbers, they are even number. So that means this given number n, this is even number. And once we have established that it is even number, now we do not have to check for 34 and 14. We need to check for 7 and 17, right? So first we'll check whether this number is multiple of 17, and then we'll check whether it is multiple of 7, because It will be multiple of 34 if it is multiple of 17 as well as multiple of 2. We have already established that even number is even number. Now, in order to check, in order to show that it will be multiple of 17, we can use this first result, a raised to n minus b raised to n. This is always multiple of a minus b. So here let us try to create 17. For that you can combine 25 and 8, right? 25 minus 8, that will be 17. So 25 raised to 190 minus 8 raised to 190. And you can combine the other two terms. That means 19 raised to 190 minus 2 raised to 190. Now clearly you can see that this first term, this is multiple of 17. This will be multiple of 25 minus 8, that is 17. Similarly, the second number, this is also multiple of 17, and therefore their difference is also multiple of 17, right? So this number n is multiple of 17 as well as it is even number. So it must be multiple of 34. That means option B is incorrect. 14 but not 34. This is also incorrect. Now we need to now we have to check for 14. And because we have already established that it is even number, so we need to check for 7. Right, so second part of this problem will be we need to check whether this number is multiple of 7 or not, right? Now, for that one, let us see that if we divide this number by 7, then what is the remainder we are getting? Also, we can combine some of these terms and see which of the above results are applicable here. So, 25 and 8, that will give us 17. 25 and 19, if I take difference of those two, we'll get 6. 2 and 8, that will also give us 6, but we need 7. So maybe we can combine these terms. We can write 25 raised to 190 minus 8 raised to 190, and 19 and 2. If you combine these two, 19 and 2, so their sum will be 21. And a raised to n minus b raised to n, this is multiple of a plus b also, if n is even number. So clearly we have even exponent. So if I combine these two terms, 19 raised to 190 minus 2 raised to 190, so then we can show that this will be multiple of 19 plus 2, which means multiple of 21. And if it is multiple of 21, it has to be multiple of 7 also. So we can neglect this part, right? When we divide this one by 7, remainder will be 0. So now we need to focus on this number only. We have to see what will be the remainder when you divide this number by 7. So for that, 25 you can write as 4 plus 21 raised to 190, and 8 you can write as 1 plus 7 raised to 190. And now use binomial theorem. So it becomes 4 raised to 190. All the remaining numbers, they will be multiple of 7. So you can again neglect that one, and then minus 1 raised to 190, right? This we can write in this form. And now we have to see that which power of 2, right, which exponent of 2 is multiple of 7 plus 1 or minus 1. So for that we can do 4 cube. 4 cube will be 64. 64 is 1 plus 63, and 63 is multiple of 7. I'm not writing multiples of 7 here. I mean, the next term will be 190 C1 into 7. After that, 7 square and so on. Similarly, here also 21 square and so on. All of them, they are multiple of 7. So we can neglect that part. Now, this one you can write as 4 into and 4 cube raised to 189 divided by 3. So that will be 63. And 4 cube is 64. 64 is 1 plus 63. So 1 plus 63 raised to 63 minus 1. And now clearly you can see that when you expand it using binomial, you will get 1 plus and then multiples of 63, which are also multiple of 7 minus 1. So finally this number n, this will be of the form 4 into 7n. So it is multiple of 7, and 4 minus 1, that will give us 3. And when you divide this number by 7, the remainder will be 3, which means the number is not divisible by 7 and therefore not divisible by 14, right? So the correct answer will be that this number is divisible by 34 but not divisible by 14. This should be the right answer, right? So you can see that whenever you have the same exponent, different terms are there and the exponent is same, then you can use these three results. A raised to n minus b raised to n, always multiple of a minus b, And if n is even, then multiple of a plus b. And a raised to n plus b raised to n, this is multiple of a plus b if n is odd natural number. So from there directly you can see that this number was multiple of 17, and for 7 we had to use binomial theorem, right? We had to, I mean, for this part we can directly claim that it will be multiple of 7, but for the other two terms using binomial we established that when you divide that number by 7, the remainder will be 3, and hence it is not multiple of 7. So the correct answer for this problem will be option D. If the coefficient of a raised to 7, b raised to 8 in the multinomial expansion of a plus 2b plus 4ab raised to 10 is k into 2 raised to 16, then we have to find the value of k. Now, the most common method of solving this problem is to use general multinomial theorem. However, one simple trick and you can solve this problem within few seconds, right? Here, instead of using that general multinomial theorem, what we can do is, I mean, we need coefficient of a raised to 7 and b raised to 8. So from these three terms, we can take AB common, right? If you take AB, we need coefficient of a raised to 8, b raised to 7 in this one. Now just take AB common from here. And then we have, if you take A common from AB, you will get 1 by B. Similarly, if you take A common from this one, AB common from the second term, you will get 2 by A and plus 4 and this raised to 10. So that means we need coefficient of A raised to 7, B raised to 8, n, and now A raised to 10, B raised to 10, and this multiplied by, we have 2 by A plus 1 by B plus 4, this raised to 10. Now in the next step you can see what we have to do. If I need A raised to 7 and we already have A raised to 10, so that means in this one we need 1 by A cube, right? 1 by A cube multiplied with A raised to 10 will give us A raised to 7. And similarly, if I need B raised to 8 and we already have B raised to 10, so in this expansion we need 1 by B square. So basically in the next line you can write that we need coefficient of 1 by A cube and coefficient of 1 by A cube into 1 by B square, because we have to create B raised to 8. We already got B raised to 10 here. So in this multinomial, we need 1 by B square. Similarly, we need A raised to 7. We already got A raised to 10. So in this multinomial, we need multinomial expansion of this one, we need 1 by A cube. So that means we need coefficient of 1 by A cube into 1 by B square in the expansion of 2 by A plus 1 by B plus 4, this raised to 10. And now think of 1 by A as alpha, 1 by B as beta. So basically the problem is we need coefficient of alpha cube beta square in 2 alpha plus beta plus 4, this raised to 10. And now you can very easily see what should be that coefficient. We have to distribute this exponent among these three terms. And if I need alpha cube, the exponent of this one must be 3. Right, if I need alpha cube, then exponent of 2 alpha must be 3. Similarly, if I need beta square, then exponent of beta, this must be 2. And total we have 10. If exponent of these two terms are 3 and 2, then exponent of 4 must be 5. Right. So now it is given that coefficient of this term is k into 2 raised to 16. And from here you can see that coefficient of that particular term, that will be 10 factorial. And this divided by 3 factorial, 2 factorial, 5 factorial, and then 2 alpha raised to 3 alpha cube, coefficient part will be 2 cube. Similarly, beta square, so coefficient will be 1 square, which is 1, and then 4 raised to 5, and this thing is given as k into 2 raised to 16. And now all we have to do is we need to simplify this one, and from there we have to find the value of k. So you can do the calculation part on your own. Once you simplify this one, after the calculation, you will get k as 315. Calculation is not difficult to do. 10 factorial you can write as 10, 9, 8. 5 factorial you can cancel, and then rest of the calculation you can perform. Also, this will become 2 raised to 13, right? So from there, finally, you will get k as 315. So the correct answer for this problem will be, we needed value of k is 315. So you can see that one simple trick, just take AB common from here, and then how easily we can directly solve this problem, right? Obviously, we need to know multinomial theorem for that one, but now you can directly see what should be exponent of these three terms, alpha, beta, and the constant term, right? Because once you take this one common, and if I need a raised to 7, we got a raised to 10 here, so that means we need 1 by a cube. Similarly, 1 by b square. So we need to distribute this exponent in this manner, 3, 2, and 5. So finally, after calculation, you will get k as 315, and that is the correct answer for this problem. If sum of this series 40C0 plus 41C1 plus 42C2 and so on to 60C20, this is m by n into 60C20, where m and n, these two are co-prime numbers. That means there is no common factor between m and n. The HCF of m and n will be 1. So then we have to find the value of m plus n. I mean, whenever you have one integer divided upon another integer and we have to find m plus n, we need to find unique value of m and n. So then this condition is added that m and n, these two are co-prime number. So therefore there is no common factor between those two. If there is any common factor, you have to cancel that one and write this fraction in a smallest form. So here first we need to simplify this left hand side, and then we'll compare with this right hand side and we'll see what should be the value of m and n. Now, before we attempt this problem, there is one important property of binomial coefficient that we must know. The property is that if I have NCR plus NCR plus 1, then this is nothing but n plus 1 CR plus 1. Right? This is one very important result related with binomial coefficients, that NCR plus NCR plus 1. This is n plus 1 CR plus 1. In order to apply this property, you can see that these two must be same, and here there should be difference of 1. If one term is r, other one should be r plus 1. So then we need to add 1 in this one. So this becomes n plus 1 and then CR plus 1. Now, in these type of problem where you have sum of binomial coefficients and this thing is changing, C0, then C1, C2 up to C20. So then you can think of this property. See here, 40C0, next term is, let us write the left hand side. Left hand side is 40C0 plus 41C1 plus 42C2. I'll write few more terms. Next will be 43C3. And in this manner, it will continue up to 60C20. Now, in order to apply this property, as I said earlier, that these two numbers must be same, n and n. Right now, one is 40C0, other one is 40. Here we have difference of 1. One is C0, other one is C1. But these two must be same, then only we can apply this property. So for that, we are going to use one interesting trick, that 40C0, this will be same as 41C0. Right, 40C0 or 41C0, those two are same, and their value will be 1, right? NC0, whatever be the value of n, is always 1. So instead of 40C0, I'm writing 41C0, and now you can combine the first two terms, right? You can see that if we combine these two terms, then sum of these two terms, one is NCR plus other one is NCR plus 1. So this will become n plus 1 CR plus 1. That means sum of these two, this will be nothing but n plus 1. So from 41 you will get 42 and then C1. Now you can see what will happen if I combine it with the next term. Right, now if I combine the first three terms, sum of first two term is 42C1. Now add 42C1 with the next one. Right, so 42C1 plus 42C2, this will become 43C3. Now add sum of first three term, this is 43C3, C2 in fact. right? We have to add 1 and then we have to take the bigger number here. So 42C1 plus 42C2, this will be 43C2, and 43C2 added with this next one. Right now we are going to add the first four terms. Sum of first three term is 43C2. 43C2 plus 43C3. This will become 44C3. Right. So you can see that you can add this term with the next one and you can use this property. So ultimately, when you add all the terms on left hand side, you can see that 43 became 44. C3 is same as C3. 42 became 43. So you can see that if I continue this operation till the last term, then this 60, this will become 61 C20, right? You can see that this number is not changing. If I add the first four term, then the result is 44 C3. So if I add all of these terms, the result will be 61 C20. So that is the sum of left hand side, right? The left hand side will be 61 C20. And now on right hand side, we have m by n, this multiplied by 60 C20. And now we have to use the definition of NCR. So 61 C20, this is 61 factorial, and this divided by 61 factorial, and that divided by 20 factorial, multiplied by 60 minus 20, that is 41 factorial. And on right hand side, we have m by n, and then this will become 60 factorial divided by 20 factorial into 40 factorial. So from here clearly you can see that m by n, this will become 20 factorial, you can cancel 41 and 40. So you will get 41 factorial in denominator, right? 41 factorial you can write as 41 into 40 factorial. So and similarly 60 and 61. So you will get 61 there. So that means m by n, this is 61 and that divided by 41. And as you can see that there is no common factor between 61 and 41. In fact, both of them are prime number. So m and n, 61 and 41, these two are co-prime or relatively prime, or their HCF is 1, right? So now the problem was we have to find m plus n. So clearly you can see that m will be 61, right, in a smallest form. This is the fraction 61 by 41. Now m is 61, n is 41. Sum of these two, this will become 102. So that is the correct answer for this problem, right? So as you can see that this was a very interesting problem. We're using this simple result that NCR plus NCR plus 1, this is n plus 1, CR plus 1. We can combine all the terms on left hand side. The important trick was that in order to start that series, these two must be same. We must have n at these two places. But here in first term we had 40C0 and next one was 41C1. So 40C0, this you can write as 41C0. Now sum of first two, 42C1 added with the next one, 43C2 and so on. So left hand side was 61C20. Now compare with this right hand side. Finally m and n, 61 and 41, their sum will be 102, and therefore that is the correct answer for this problem. If sum of this series 1 square into 15C1 plus 2 square into 15C2 and so on up to 15 square into 15C15, this is 2 raised to m, 3 raised to n, and then 5 raised to k, where m and n and k, these three are natural numbers. So then we have to find the value of m plus n plus k. Now, there are multiple ways of solving such type of problems. Before we attempt this problem, there is one important formula that you should know. NCR, this you can write as n by r and this multiplied by n minus 1 CR minus 1. We'll solve this problem using sigma notation. So for that, we need this formula. NCR is n by r and then n minus 1 CR minus 1. So here let us say this sum on left hand side, this is S. So using sigma notation, you can say that this sum will be summation. In first term, we have 1 square into 15C1. Second term is 2 square into 15C2, right? And so on. So clearly you can see that rth term will be r square and this multiplied by 15CR. And the value of r, this will start from 1, right? For first term, we have C1, then we have C2, C3, up to 15. So R will be from 1 to 15, right? This is the sum that we have to calculate. Now here our aim will be to get rid of this variable R. Once I get rid of this R or R square, then we have standard formula for finding this sum, right? I mean sum of first n binomial coefficient nc0 plus nc1 up to ncn. This is 2 raised to n. So that formula we can use, but for that first we need to remove this R square from here. And for removing R square, we are going to use this result, that ncr n by r n minus 1 cr minus 1. That means you can write this sum as R square and this multiplied by 15 cr, so that is 15 by r, and this multiplied by 14 cr minus 1, right? N by r, and then just decrease both of these by 1. So 15 by r into 14 cr minus 1. The range for r is from 1 to 15, right? In final step, we'll consider this one. For all of these, sigma R is least value of R is 1, right? R can take all the values starting from 1 up to 15. Now 1 R you can cancel. 15 is constant that you can take outside, and now we are left with R into 14 CR minus 1. Now the problem is that if I use the formula in next step, in denominator you will get R minus 1, right? This thing you can write as 14 by R minus 1 and then 13c r minus 2, right? But so in denominator you can create r minus 1, but here we have r. So now for that what we can do is we can write this as r minus 1 plus 1, and we'll create two sum from here, right? One will create r minus 1 into this term and the other one will be 1 into this term, so that we can get rid of that variable r, because once I remove that one, then we have a standard formula for that. So this is one again very important step. R minus 1, this is one term, and plus 1, this will be another one. So now we can write this as 15 sigma r minus 1, this multiplied by 14 cr minus 1, and this you can write as 14 by r minus 1, and then 13 cr minus 2. And the other term will be 15, you can keep common, and then we have 1 into this term, so that means sigma 14c r minus 1. And now you can see this r minus 1 also we can cancel, so ultimately we have 15 into 14 into sigma 13c r minus 2, and the other term will be 15 into sigma 14c r minus 1. Now we can write the sum of this series, right? This series will become, remember R is starting from 1 up to 15, right? Here the limit for R, this will start from 1 to 15. Here also the limit for R is from 1 to 15. Now if you take 1, then obviously you will get negative minus 1 here, which is meaningless. So we'll start from 2. At 1 we are getting meaningless term. NCR is defined only when N and R, both of them positive integer or 0, right? It cannot be negative number or fraction. So for this one, although the limit is from 1 to 15, but at 1, we are not getting anything, right? So we'll start from 2. Now, if you substitute 2 here, you will get 13c0, right? If I substitute 3 here, then we'll get 13c1. And this will continue up to 13c13. And I mean, you must be familiar with this result, but again, I'll write this one, that if I have nc0 plus nc1 plus nc2 up to ncn, right? Sum of all binomial coefficients starting from 0 up to n, this is 2 raised to n. So that means here, this first sum, this you can write as 15 into 14, and then this series will start from 13c0 up to 13c13, so that will be 2 raised to 13. And similarly, the second one will be 15 into, and then again, if you take R as 1, then it becomes 14c0. Then at 2, you will get 14c1. So here we have 14c0, 14c1 up to 14c14. So this is nothing but 2 raised to 14. And now you can take 2 raised to, in fact, from here you can take 15 into 2 raised to 13 common, right? In fact, 2 raised to 14 you can take common, 15 we can take common, and then 2 raised to 14. So this becomes 7. And from here you will get 1, right? So finally this will become this is 8, so 14 plus another 3, that is 2 raised to 17, and then 15 one can write as 3 into 5. So this is the sum that we are getting finally. Now we need to compare this sum with 2 raised to m, 3 raised to n, and 5 raised to k. So clearly you can see that m will be 17, right here the value of m, this is 17, n is 1, and k is also 1. So that means this sum will become 19, right? So the correct answer for this problem will be second option. So I mean these type of problem, they are not difficult. First you need to write using the sigma notation, and then we have to get rid of this r or r square. So first we have written 15 cr as 15 by r, when r will cancel, and in next step you will get r minus 1, right? Because here we have 14 cr minus 1. If we apply the same formula, we'll create r minus 1 here, and that means we need to write r minus 1 plus 1, and now again separate and create two summation. Finally the sum was 2 raised to 17 into 3 into 5, and therefore m plus n plus k, this will be 19, and that is the correct answer for this problem. If the sum of this series, we have some function of r multiplied by 11c r plus 1, r from 0 to 10. If this is alpha raised to 11 minus 11 raised to 11, and this divided by 10 raised to 10, then we have to find the value of alpha. So basically we need to find the sum of this series, and then by comparing with the right hand side, we have to find what should be the value of alpha. Now, before we attempt this problem, there is one important formula that we should know. The formula is basically that if I have sigma NCR and this multiplied by a raised to r is from 0 to n, right? So this is nothing but binomial expansion of 1 plus a raised to n. I mean, clearly you can see that if you take r as 0, then you will get 1, which is the first term. If you take r as 1, then you will get nc1a, right? The left hand side, I mean, this will be 1 plus nc1a, nc2a square, nc3a cube, and so on, up to ncn a raised to n. So that is binomial expansion of 1 plus a raised to n. Now, there are a few PYQ where using the simple result, you can get the sum of this series. Notice the important thing here is that if I have NCR, the exponent of A must be R, right? Then only you can combine these two, and also R must be from 0 to n. If R is starting from 1 or from 2, then we have to account for those terms also, right? So here, let us say that this sum is S. So S you can write as sigma R from 0 to 10. In last step, we'll talk about this limit. First, let us simplify this function. So here if I separate these two, that means one I'll create 10 raised to r plus 1 by 10 raised to r, and the other one minus 1 by 10 raised to r. So 10 raised to r plus 1 divided by 10 raised to r, that will be nothing but 10 into, and then this other term is 11c r plus 1. So this is one sum, and then minus sigma 11c r plus 1, and the other term will be 1 by 10 raised to r. Now, for first one, we'll use a standard formula. And in this second one, you can see that in order to apply this formula, here we have 11cr plus 1, and this one is 1 by 10 raised to r. Now, our aim will be to create, we must have same number here and here, right? If this is 11cr plus 1, we must have 1 by 10 raised to r. So, for that, we can multiply and divide by 10. If we divide by 10, it becomes r plus 1. And if we multiply by 10, that we can write in numerator. So this is one important step here, because if I have to create plus 1 and then into 10, so now this becomes, these two numbers are same. Here we have r plus 1, and here also we have r plus 1. And now we can use that standard formula. Also, limit for r, this is from 0 to 10. And here also limit for r, this is from 0 to 10. So this will become, first term will be 10 into, if you take r as 0, this will become 11c1, right? At r equals to 0, we'll get 11c1, then 11c2, and so on. Last term will be 11c, and then if we substitute 10 here, we'll get 11. So this is the first sum, minus the second one will be Now here again you can notice that if I start with r equals to 0, then we'll get 11c1 1 by 10 raised to, in fact 10 we can keep common, right? 10 we can separate, and then this sum becomes, if I uh, substitute r as 0, then this will start from 11c1, right? So the first term 1 in the expansion of this one, the first term will be nc0 a raised to 0. So that term is missing. After that, you will get all the terms 11c1, 11c2, 1 by 10 square, 11c3, 1 by 10 cube, and so on, all the way up to 11c11, right? At 10, you will get 11. So 11c11, 1 by 10 raised to 11. So this sum, using the previous formula, you can write this as 1 plus, in place of a, we have 1 by 10. So 1 plus 1 by 10, this raised to 11, right? The last one will be 1 by 10 raised to 11, and minus 1. Minus 1 because we are not getting 11c0 10, right? This series is starting from 11c1. So therefore, we have to do minus 1. Now, this side will be 10 into 2 raised to 11 minus 1. Again, a standard formula, sum of all these, when nc0 plus nc1 up to ncn, this is 2 raised to n. Again, this is starting from 1, right? So 11c0 we have to subtract from here, and then minus 10 into, and this will become 11 by 10 raised to 11 minus 1. Now this minus 1 you can cancel, right? If you take 10 common from all of these, so then you can get rid of that minus 1. So basically this is 10 into 2 raised to 11 minus, and if you separate these two, then you have 11 raised to 11, and this divided by, you can get rid of 10 from here, so 10 raised to 10. And this minus 10 and minus 10 from here, those two you can cancel, right? Minus 10 plus 10, so that will cancel. And now we can take 10 raised to 10 as LCM. You can see that if I take 10 raised to 10, 1 by 10 raised to 10 common from all of these, then this will become 10 raised to 11, and 10 into 2, that will become 20 raised to 11 minus 11 raised to 11. So this is what we are getting. Now let us compare with the given expression. This sum, 1 by 10 raised to 10, and then we have alpha raised to 11, 11 raised to 11. In place of alpha, clearly you can see that we are getting 20 raised to 11. So that means the value of alpha, this must be 20, right? So the correct answer for this problem will be second option. So this was a problem, I mean, not difficult problem. First, we have to use this formula. NCR a raised to r, that is 1 plus a raised to n. R from, this is important, r must be from 0 to n, and also these two must be same. So, I mean, we created two sum here, and in order to create same number r plus 1, we had to multiply and divide by 10. And now we had a standard formula for first one as well as second one. After simplification, finally we got this sum. So if you compare with the given result, given expression, then alpha is 20, and therefore correct answer for this problem is second option. If sum of all the roots of this equation in e raised to x, this is log p, then we have to find the value of p. Now, this is a problem from relation between roots and coefficients of a polynomial equation. In fact, a cubic polynomial. In order to solve this problem, first in place of e raised to x, we are going to substitute alpha so that we can get a polynomial equation in alpha. If we replace e raised to x with alpha, then this first term e raised to 2x, this will be alpha squared minus 11 alpha minus 45, and e raised to minus x means 1 by e raised to x, so that means 45 by alpha plus 81 by 2, this equals to 0. Now multiply everything with alpha so that we can get a cubic polynomial. So we have alpha cube minus 11 alpha square plus 81 by 2 into alpha minus 45, this equals to 0. And because it is a cubic equation, let us say for this equation, the roots are alpha 1, alpha 2, and alpha 3. These are the three roots of this cubic equation in alpha. Also, for the given equation, let us say the roots are x1, x2, and x3. Because the given equation is also a cubic equation in e raised to x. So if we have three roots for this equation, for this cubic also, we'll get three roots. So let us say roots are x1, x2, and x3. So now x1 plus x2 plus x3, this is log p, right? Sum of all the roots, this is log p. So that means x1 plus x2 plus x3, this is log p. So we have to find sum of the three roots of this first equation, right? We need to calculate x1 plus x2 plus x3. Now, if alpha is e raised to x, right? So if alpha 1, alpha 2, alpha 3 are the roots of this cubic polynomial, then alpha 1, this is nothing but e raised to x1, because alpha is e raised to x. So alpha 1, if x1, x2, x3 are the roots of given equation, alpha 1, alpha 2, alpha 3 are the roots of this cubic polynomial in alpha, then alpha 1, this is nothing but e raised to x1. Similarly, alpha 2, this will be e raised to x2. And finally, alpha 3, this will be e raised to x3. So if I need sum of these three roots, if I need x1 plus x2 plus x3, then in this cubic equation, we need the product of roots, right? If I calculate alpha 1 into alpha 2 into alpha 3, and alpha 1 is e raised to x1, alpha 2 is e raised to x2, and similarly, alpha 3 is e raised to x3. So if I need sum of roots of this first equation, then in second equation, we need to calculate the product of roots, right? So that means, and using the relation between roots and coefficients of a cubic equation, the product of these three roots, this will be minus the constant term and that divided by coefficient of leading term. So that will be minus 45 by 1, right? This should be the product of three roots. And now alpha 1 is e raised to x1. Similarly, alpha 2, this is e raised to x2. So in place of alpha 1, we can write e raised to x1. Alpha 2 is e raised to x2, alpha 3, this is e raised to x3, and this will be 45. Again, we have common base, so we can add the exponent. That means e raised to x1 plus x2 plus x3, this will be 45. Take log on both sides, so that means x1 plus x2 plus x3, this will be nothing but log 45, right? ln 45 or log 45 to base e. So that will be the sum of three roots of that given equation. We have to compare these two values. It is given that x1 plus x2 plus x3 is log p. Just now we have calculated that this is log 45. So that means the value of p, this is nothing but 45. And that is the correct answer for this problem. So in this question, the important concept was that if I need sum of roots of first equation, then we need to find the product of root of the second equation. And because alpha 1 was e raised to x1, similarly alpha 2 and alpha 3, and they have common base, so we can add the exponent. And finally, after taking log, sum of the three roots will be log 45. If we compare with this one, p is 45, and that is the correct answer for this problem. If a plus b plus c is 1, ab plus bc plus ca, this is given as 2, and abc, this is 3. Then we have to find the value of a raised to 4 plus b raised to 4 plus c raised to 4. Now, this is a problem from basic mathematics. A plus b plus c is given. So, from here, by squaring this one, we can calculate a square plus b square plus c square. And again, after squaring, we'll get terms containing a raised to 4, b raised to 4, c raised to 4. Right. So, first let us square this one. A plus b plus c is 1. So, that means a plus b plus c square, this will be 1 square, which is 1. From here, we'll get a square plus b square plus c square, and then twice of ab plus bc plus ca, and this is 1. Now, this value is given to us, right? ab plus bc plus ca, this is given as 2. We can substitute that value here. So, we'll get a square plus b square plus c square, and this will be, if I substitute for AB plus BC plus CA, then 4 and minus 4, that will be minus 3. Now, at this point, you should not think that how A square plus B square plus C square is negative, right? A square, B square and C square, if A, B, C are real number, then only these are non-negative terms, right? Here in the problem, nowhere it is given that A, B, C are real numbers. So that means we can have imaginary value for ABC. In fact, ABC will be imaginary only, then only we can satisfy this equation, right? So a square plus b square plus c square, this will be minus 3. Now we have to calculate a raised to 4 plus b raised to 4 plus c raised to 4. So for that, let us square this one again. Let us call this equation 1, and now we are going to square this one, so that we can create a raised to 4 plus b raised to 4 plus c raised to 4. So now if we square this one, then we'll get square of a square, so that will be a raised to 4 plus b raised to 4 plus c raised to 4, and then again 2 we can take common, we have a square b square plus b square c square, and then plus c square a square, and this will be minus 3 square, which is plus 9. Now how to calculate this one? So for that they have given that AB plus BC plus CA, this is 2. Now if you square this one, then we can create terms containing a square b square plus b square c square plus c square a square. So let us square this result now. AB plus BC plus CA is 2. So that means we have AB plus BC plus CA square, and this will be 2 square is 4, right? Now if we square this one, then we are going to get a square b square plus b square c square plus c square a square, and then twice of. Now if you multiply these two terms, then you will create a b square c. Next two term will give us b c square a, and then first and third term, this will give us a square bc. So that means you can take abc common from all of those three, and then you are left with a plus b plus c, and this thing should be 4. Now this is something that we have to calculate. So if I substitute the values of these things, right, we'll write one more line here. If I have to find a square b square plus b square c square plus c square a square, then we can substitute the value of ABC. ABC is 3, and a plus b plus c, this is given as 1, right? So this will become 2 into 3 into 1, which is 6, and then 4 minus 6, this will be minus 2. So the value of a square b square plus b square c square plus c square a square, this is minus 2. Now substitute that value here, right? In place of this expression, we can substitute minus 2. So now if we take this term on other side, so then we have a raised to 4, b raised to 4, c raised to 4, and this will become 9, and this term will be 2 into minus 2, which is minus 4. 9 plus 4, that will be 13. So therefore the correct answer for this problem will be 13. This was not a difficult problem, but the important thing is sometimes we start thinking that how this became negative, right? How a square, because if we have any real number, then any even power of that number is always non-negative, right? If a belongs to real, then you can say that a square, this must be greater than equal to 0. But here, because it was not given that ABC are real numbers, so therefore we can have imaginary value for ABC also, and hence a square plus b square plus c square, this was minus 3. Again, after squaring that, we created a raised to 4, b raised to 4, c raised to 4, but we also got a square b square, b square c square, and c square a square. So for finding value of that one, we can square this result. AB plus BC plus CA is 2. So from there we got this value as minus 2. After substituting here, finally the correct answer for this problem is 13. Find the sum of all the real values of x for which these two rational functions are equal. On left hand side, we have a quadratic by quadratic, and on right hand side also another quadratic by quadratic, and we have to find sum of all the real roots of this equation. So in this problem, there is one interesting observation which will make this problem much easier. So, I mean, the general thought is that we try to cross multiply and then create a polynomial equation and solve that equation. But here you can see that if you cross multiply these two, it will become complicated, right? In this problem, the important observation is that if you do difference of numerator and denominator on both sides, whether left hand side or right hand side, you will get the same result, right? On left hand side, if I do numerator minus denominator, then 3x square minus x square, that is 2x square, minus 9x minus 3x, that will be minus 12x, and 17 minus 10, that is 7. On right hand side also 5x square minus 3x square, so that is 2x square. Then similarly minus 7 minus 5, that is minus 12, and then 19 minus 12, that will be 7. So on both side, left hand side as well as right hand side, the difference of numerator and denominator is same. So here what we'll do is that if we subtract 1 from both sides, then we can create the same numerator. And after that, we can do cross multiplication and we can take this as common factor, right? So here what we'll do is that we are going to subtract 1 on left hand side and same thing we'll do on right hand side, right? Now if I do this one, then on left hand side you can see that you will get, I mean, if I subtract 1 from here and if you take x square plus 3x plus 10 as LCM, so then 3x square minus x square, that will be 2x square. Similarly, minus 9 minus 3, so that will be minus 12x plus 7. This will be the left hand side after subtracting 1. And on right hand side also we'll do the same thing. So that means on right hand side the denominator will be 3x square plus 5x plus 12, and numerator after doing minus 1, if you take this as LCM, then we have to do numerator minus denominator, so that is 2x square minus 12x plus 7. And now we can cross multiply these two, and while cross multiplying we can take this one common, right? This thing we can take common, so then we are left with difference of these two terms, so that means 3x square. In fact, we can I mean, write the in the same line we can write this result, that if you cross multiply and then take 2x square minus 12x plus 7, so then you will get 3x square plus 5x plus 12 and then minus x square plus 3x plus 10 after taking this one common, right? So 3x square minus x square, that will be 2x square, 5x minus 3x, that is 2x, and then 12 minus 10, so that will be 2. So this is the equation that we are getting. Now in this equation, as you can see that we can take 2 common from here. So then you will get 2x square minus 12x plus 7. And if you take 2 common, then we have x square plus x plus 1 equals to 0. Now remember, in the problem it is clearly given that we have to find sum of real values of x. Right, now here we have two quadratic factors. If I equate them to 0, one possibility will be that 2x square minus 12x plus 7, this will be 0. The other possibility will be x square plus x plus 1 equals to 0. Right, we have product of these two factors, and if it is 0, then either the first one is 0 or second one is 0. But for this second equation, you can see that you will get imaginary roots because the discriminant is negative, right? In fact, the roots of this one will be imaginary cube roots of unity, omega and omega square. But anyway, we are interested only in the real roots. We are not going to get real roots from the second equation. So uh, we have to focus on this first equation, and clearly for this first equation we'll get real roots because discriminant will be positive, right? B square minus 4ac, so that will be 36 minus uh, b square, so that will be 12 square 144, and then minus some small number. So discriminant is positive, that means we'll have real and distinct root. And because we need sum of real roots, so we do not have to calculate the actual root. We can use the relation between roots and coefficients of a quadratic equation. So here if I calculate sum of these two roots, alpha and beta, then we'll get minus b by a. That means 12 by 2, that will be 6. So therefore, sum of all the real values of x satisfying this equation, this will be 6. Right? So this was a very interesting problem, and one simple observation, and after that, the problem is not that difficult. Right? The observation is that on both sides, the difference between numerator and denominator is same. So simply by doing minus 1, we have created common numerator, and then we got these two quadratic equation. Now for the second one, the roots were imaginary, and for first one, if the roots are alpha, beta, then sum of those two roots, that will be minus b by a. So therefore, the correct answer for this problem will be 6. Find the sum of cubes of all the roots of this biquadratic equation. Biquadratic equation means a polynomial equation of degree 4. Right? So here we have to calculate the roots of this equation, and then we need to calculate sum of cube of all the roots of this equation. So that means if the roots are alpha, beta, gamma and delta, then we need to calculate alpha cube plus beta cube plus gamma cube plus delta cube. Right? This is something that we have to find. Now in this problem, one simple trick, and you can very easily create factors of this biquadratic expression. Here if you notice, the coefficients are 1, minus 3, then you have minus 2, 3 and 1. So if we split this minus 2 as minus 1, right? If we write minus x square minus 2x square as minus x square, then you can very easily get the factors. So that means we'll write this equation as x raised to 4 minus 3x cube, and this 2x square we can write as x square, right? Minus x square, and then we have 3x plus 1 equals to 0. Now from first three terms you can take x square common, right? If you take x square common, then we have x square minus 3x minus 1, and from these three terms again if you take minus 1 common, then we have x square minus 3x minus 1 equals to 0, right? And now you can take this one common, so we have x square minus 3x minus 1, and this multiplied by x square minus 1, this equals to 0. The general method of solving this one will be to find two roots using hit and trial, and from there we can get the quadratic factor, right? Once we have two linear factors, then using that one we can create the quadratic factor. But this simple trick can save some time. uh, Split this minus 2x square as minus x square, and then we have these two quadratic factors. Now it is not difficult to solve this one. If product of these two is 0, so either the first factor will be 0 or second factor will be 0. So either x square minus 1 is 0, or x square minus 3x minus 1, this one will be 0. From first one, you can very easily see that the values of x will be plus minus 1, right? One root will be minus 1, other will be plus 1. And in this second equation, if you try to find the roots, then you will get irrational roots because discriminant is not a perfect square. And then calculating this one will take some time, right? So instead of using that one, we can use the relation between roots and coefficients of a quadratic equation. That means if for this equation roots are alpha and beta, so sum of root alpha plus beta, this will be 3, and alpha into beta, this will be minus 1. So we can use this result, right? Ultimately, we do not need the actual root, we need sum of cubes, right? We need alpha cube plus beta cube, and let us say these two roots, they are gamma and delta, right? The other two roots, we got minus 1 and 1. So these two roots are one of them gamma, other one delta, and from this quadratic, the roots that we are getting, they are alpha and beta. So alpha cube plus beta cube, this you can write as alpha plus beta whole cube minus 3 alpha beta, and this multiplied by alpha plus beta, right? Standard formula for a cube plus b cube. So alpha plus beta whole cube minus 3 alpha plus beta, and then plus gamma cube plus delta cube. Now alpha plus beta is 3, so that means 3 cube, this will become 27, minus 3 into alpha beta is minus 1, alpha plus beta is 3. Let us say gamma is 1 and delta is minus 1. So 1 cube and then minus 1 cube. So from here clearly you can see these two will cancel, and 27 plus 9, that will be 36. So the correct answer for this problem will be 36, right? Also, this was not a difficult problem. Using other approach also you can solve this one. But if you make the simple observation that by splitting this step, we can easily get the factors. So then you can save some time. Also at this stage, for solving this other equation, we are not using quadratic formula and then substituting the value. Instead of doing that, alpha cube plus beta cube, that we can write as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. And then we can use the relation between roots and coefficients of quadratic equation. Sum of root minus b by a, product of roots by a. So finally, the correct answer for this problem is 36. Let x1, x2, x3 and x4 be the solution of this biquadratic equation in x, and the value of this expression, the product of these four terms, this is 125 by 16m. Then we need to find the value of m. Now there are few important concepts involved in this problem. The very first one is that if I have to create factors of this one, if I have x square plus a square, and then we need factors of that. Let us say if I have x square plus 4, and we want to create factors of x square plus 4. So obviously there is no linear factor for x square, no real linear factor for this one. But using iota, one can write the factors as x plus 2 iota and this multiplied by x minus 2 iota. Because iota square is minus 1, so this will become x square plus 4. So this is one concept. Now here if I have to create this product, then x1 square plus 4, that is x1 plus 2 iota into x1 minus 2 iota. Similarly, the other three. Another important concept that let us say this polynomial on left hand side is p of x. That means the given equation is px equals to 0. So because the roots of this polynomial equations are given, the roots are x1, x2, x3 and x4. So we can always write this polynomial in terms of x1, in terms of its roots. That means one can write px as lambda into x minus x1, and because one root is x1, so one linear factor will be x minus x1 using factor theorem. Similarly, another will be x minus x2. Next factor will be x minus x3, and then we have x minus x4. One can write px in terms of lambda in this manner. Also, by equating the coefficient of x raised to 4, coefficient of x raised to 4 is 4. So by equating the coefficient of x raised to 4, you can get the value of lambda, right? For px, the coefficient of x raised to 4 is 4, and on right hand side, when you multiply all of these terms, for x raised to 4, the coefficient will be lambda. So lambda must be 4, right? Because then the coefficients of x raised to 4 on two sides will be equal. So this is p of x. Now if I want to create these type of terms, then in place of x, once we have to substitute 2 iota and then minus 2 iota and then multiply those two. Because just now we have seen that x plus 2 iota into x minus 2 iota, that will give us x square plus 4. So here, if you substitute iota in place of x, then p of 2 iota, this will be 4 into, and let us write this product using pi representation. So this one you can write as pi of x. In place of x, we have 2 iota. So 2 iota minus xi, where I is from 1 to 4. That will be the product of these four terms, 2 iota minus x1, 2 iota minus x2, and so on. In place of x, if we write minus 2 iota, then we'll get 4 into, and again product of these four terms. So that means we have pi of 2 iota. In place of x, we are writing minus 2 iota. So minus 2 iota minus x1. And now multiply these two. Let us call this equation 1. Pi we are using to represent the product of these four terms. Now if we multiply 1 and 2, then clearly you can see that equation 1 into equation 2, this will give us p of 2 iota, and this multiplied by p of minus 2 iota, and on right hand side you will get 4 into 4 16, and then x2 iota minus x1, this multiplied by minus 2 iota minus x1. Now again, because there are four terms in this, you can take minus sign common, right? 4 minus will make it plus sign. So basically this is 2 iota plus x1. When you multiply these two terms, you will get 4 iota square minus x1 square, and again you can take iota common from all the four terms. So then you will get x1 square plus 4, x2 square plus 4, and in this manner there are two other terms, x3 square plus 4 and x4 square plus 4. So this is the product that we are getting. Now it is given that this product is 125 m by 16. So that means p of 2 iota, maybe we can take 16 on other side, or directly also we can calculate. So p of 2 iota and this multiplied by p of minus 2 iota, and on right hand side we have 16 into, and this product is given, this is 125 m, 125 by 16, and this multiplied by m. So now from here one can get the value of m, right? M will be nothing but 1 by 125, right? 16 you can cancel, so 1 by 125. And in this is the expression for p of x, right? This was p of x. Now in place of x, you need to substitute 2 iota and minus 2 iota. So when you substitute 2 iota in place of x, then p of 2 iota, this will be 141 minus 88 iota. This calculation you can do on your own. That will be the value of p of 2 iota. And now p of minus 2 iota, that will be nothing but conjugate of this complex number, because conjugate you can extend over any algebraic operation. So minus 2 iota is conjugate of 2 iota. Therefore, p of minus 2 iota will be conjugate of this complex number. So we'll get 141 plus 88 iota. So this will be the value of m. Now, after calculation, you will find that this number will be 221. So therefore, the correct answer for this problem will be 221. Right. So this was a problem where first we had to be familiar with this concept that for x square plus 4, the factors will be x plus 2 iota into x minus 2 iota. And if x1, x2, x3 are the roots of this polynomial equation, this biquadratic polynomial, then these are the factors. Now, in place of x, write 2 iota minus 2 iota and then multiply those two. And after simplification, you will find that the value of m is 221. And that is the correct answer for this problem. Alpha and beta are natural numbers and they are the roots of this quadratic equation in x. If lambda by 2 and lambda by 3, these two are not a natural number and lambda takes the minimum possible value, then we have to find the value of this expression. We need to find the value of alpha, beta and the value of lambda, where lambda is the least possible value. And alpha and beta are the roots of this quadratic equation. Now, this is a very interesting problem and there are a number of concepts involved here. The very first concept is obviously the sum and product of roots. For this quadratic equation, the roots are alpha and beta. So, alpha plus beta, this must be minus b by a, that is 70. And alpha into beta, this must be lambda. Now, it is also given that lambda by 2 and lambda by 3, these two are not integer. That means lambda is not multiple of 2, right? Lambda is neither multiple of 2 because lambda by 2 is not an integer. So, lambda cannot be even number. And similarly, lambda is also not multiple of 3 because if lambda is multiple of 3, then lambda by 3 will become an integer. So the meaning of this line will be lambda is neither multiple of 2 nor multiple of 3. Now the question is that if alpha and beta are natural numbers and their sum is 70, so there are different ways in which you can create the sum 70. For example, one possibility will be that you can take alpha as 1, beta as 69. Another possibility will be that you can take alpha as 2, beta as 68 and so on. In this manner, you have different possibility. I'll just write a few possibilities here. Alpha 4, beta 66, alpha is 5, beta is 65. And in this manner, the last case, maybe I'll write one case in middle also. Alpha is 35, beta is 35. And then the last possibility is that alpha is 69 and beta is 1. So these are the different cases. If we talk about total number of possibilities, then total there are 69 different cases, right? Alpha you can take any number from 1 to 69 and beta will be 70 minus alpha because alpha plus beta is 70. Now we know that when sum of two positive number is constant, then their product is maximum if the two numbers are equal. For example, if I needed maximum value of lambda, then we'll take alpha as 35 and beta as 35 because lambda is nothing but alpha into beta. So if I needed maximum value of lambda, then we'll take alpha and beta both as 35. But here the question is that lambda is taking the minimum possible value. Now, minimum possible value you can get if you take alpha as 1 and beta as 69. In this case, the product will be 69. In next case, you are going to get 2 into 68. So that will be 136 and so on. So basically, the idea is that when you start from 169, 268, 367 and so on, gradually the product will increase and it will become maximum when you take alpha and beta equal. When you take alpha as 35 and beta as 35, we'll get the maximum product. And again, for the last pair, 69 and 1, the product will be 69. So gradually the product will increase. In middle, when alpha and beta are 35, 35, product will be maximum. It will be 35 square. Now, Minimum value of lambda you will get when alpha is 1, beta is 69. But there is another condition, and that condition is that alpha and beta should not be multiple of 2 or 3, because lambda is not multiple of 2 and not multiple of 3. Right? In this first case, if you take alpha is 1, beta is 69, alpha into beta, which is lambda, will become 69, and 69 is multiple of 3. Similarly, 136 or 2 into 68, that is multiple of 2. So this one also we cannot take. Next possibility, 3 into 67. Now again, this number will be multiple of 3. So we cannot take this case also. Next possibility, uh, 4 and 64, which is again multiple of 2 as well as multiple of 3. So we cannot take this one. So the least value of lambda you will get when you take 5 and 65, right? Because none of these numbers are multiple of 2 or multiple of 3. Neither 5 nor 65 is either multiple of 2 or multiple of 3. So basically the least value of lambda satisfying the given condition will be 5 into 65, and this product you will get when you take any one root as 5, let us say alpha as 5 and beta as 65. So here basically these are the values of alpha, beta and lambda. Alpha you can take 5, beta you can take 65, and lambda will be 5 into 65. That will be the least value of lambda, because lambda is neither multiple of 2 and also not multiple of 3. Otherwise, least value will be 69, greatest will be 35 square. So now we are in a position to write the answer for this problem. Root over alpha minus 1, alpha is 5, so this will become 2. Root over 4, beta minus 1, so 65 minus 1, that will be 8. And lambda plus 35, lambda is 5 into 65 plus 35. And this divided by denominator we have mod of alpha minus beta. Alpha is 5, beta 65, difference will be 60, modulus difference will be minus 60, modulus will become 60. And now when you simplify this one, these two you can cancel, you will get 10 here, and then 5 also you can take common. So after final calculation you will find that this quantity will be 60, and therefore that will be the correct answer for this problem. So this was a problem where you have to be familiar with this concept that if sum of two positive number is constant, then their product is maximum when the numbers are equal. And in this direction, the product will keep on increasing, right? Product will become maximum in middle, and then after that, again, it will start decreasing, right? So, and because lambda is not multiple of 2 and 3, so the least value of lambda you will get when alpha is 5, beta is 65. This was the minimum value of lambda. After substituting the value, we got the final answer for this problem at 60. Find the sum of common terms of following three arithmetic progression. The first one is 3, 7, 11 up to 399. The next one is 2, 5, 8 up to 359. And the last one is 2, 7, 12 up to 197. Now we know that if we have a number of APs and if we find the common terms of all the given AP, then this will form another AP. And for that common terms or the AP of common terms, the common difference is LCM of common difference of all three APs, right? So here for the first AP, the common difference is of 4. For the second AP, the common difference is of 3. And for the third AP, the common difference is of 5. So for the AP of common terms, the common difference will be LCM of 4, 3 and 5, that is 60. Now, because we need a sum of common terms, so we have to identify the first common term and the common difference of that AP, and then we have to see that how many terms we are going to get, and we need to calculate sum of all those terms. Now, finding common difference is not difficult because it will be LCM of common difference of all three APs. So we got LCM as 60. However, finding the first common term, that is A, right? Finding the first term which is common in all three AP, that can be tricky. For 2 AP, again by observation, you can very easily see if I have only first and second AP, then you can see 11 is the first common term. Or if I have first and or maybe second and third AP, then this 2 is the first common term. But here we need a term which is common in all three AP, and this can be tricky sometimes. So for that, here what we'll do is that instead of finding the common term of all three AP, first find the AP of common terms of any two APs, right? First find the common term of any two AP. So for example, let us say if I consider the second and third AP, so first common term is 2, right? So the common terms of second and third AP, first common term is 2. And then after that, for this one else, for second AP, the common difference is 3. And for this one, common difference is 5. LCM of 3 and 5, that will be 15. So that means next common term will be 17, right? 2 plus another 15. Similarly, 17 plus another 15, that will be 32. 32 plus 15, that will be 47. 47 plus 15, that will be 62, and so on. So this is the common term of second and third AP. Now write the general term of first AP and then identify which is the term, which is the first term of this common AP of second and third AP, which is also present in first AP. Right, so you can see that in first AP, the common difference is of 4. So the common term will be 4m, the general term will be 4m minus 1. Right, all the numbers are multiple of 4 minus 1. You can see that 7, 11, 15 and so on. All of these numbers, they are multiple of 4 minus 1. So that means for first AP, the general term is 4m minus 1. Now try to identify that which is the first term, which is of the form multiple of 4 minus 1. 2 will not work. 17 is multiple of 4 plus 1. 32 is multiple of 4. 47 is 48 minus 1. And 48 is multiple of 4. So this is the first term which is of the form multiple of 4 minus 1. That means the first term which is common in all three AP, this will be 47. So in this manner, one can very easily find the first common term in all three AP. Write the common AP of any two AP and then write the general term of the third one and then identify which is the first term which is present in that the third AP, right? So 47 is clearly present in all the three APs, right? 40 and it will be the first term which is present in all three AP. So the first common term is 47, common difference is 60. The question was we need sum of all the terms. So first term is 47 and there are only few terms here. You can see that last term is 197. So common term cannot be more than 197. So directly we can find the sum. Right, there is no need to use the general formula for sum of n terms. So first common term is 47. Next one will be 47 plus 60. So that will be 107. 107 plus another 60, that will be 167. And 167 plus 7 plus 60 will be more than 197. So therefore this sum will become, after adding this, you will get 321. So therefore sum of all the terms common in the three AP, this will be 321, and that will be the correct answer for this problem. The interior angles of a polygon with n sides are in AP with common difference 6. If the largest interior angle is 219 degree, then we need to find the value of n. Now, before we attempt this problem, there is one simple formula that you should know, that in case of any polygon, sum of all the interior angle, this is n minus 2 into 180 degree. For example, if I have a triangle, then sum of all the angles will be 180 degree. So that is 3 minus 2 into 180. In case of a quadrilateral, 4 minus 2 into 180, that will be 360. In case of a pentagon, 5 minus 2 into 180, that will be 540 and so on. So in case of a polygon of n sides, in case of polygon of n sides, sum of all the interior angle, this is always n minus 2 into 180. Now here it is given that the angles of a polygon are in AP with common difference 6 and the largest angle is 219 degree. So if the largest angle is 219 degree and common difference is 6, so the next is, angle will be 219 minus 6, that will be 213 degree. This will be the second largest. Similarly, the third largest will be 213 minus another 6, so 207. up to, let us say that last term is nth term. We have n-sided polygon, and so now these are the different angles of the polygon 219, 213, and so on up to Tn. And we know that sum of all angles must be n minus 2 into 180. So now we have to use formula for sum of n terms of AP, equate with this number, and then find the value of n. So n minus 2 and this multiplied by 180, this is sum of all the interior angles. And if I use the formula of sum of n terms of AP, then n by 2, 2 into A plus n minus 1 and into common difference D. Now, because we are writing the AP in decreasing form, we are writing the first term, we are writing the last term first. So common difference will be of minus 6, right? And now we need to solve this equation. So n minus 2 into 180 degree, and on right hand side you will get n into 2, we can cancel. So we have minus 3n and then 3 plus 219, so that will be 222 degree. Now 3 you can take common from here, so then we have n minus 2 into 60 degree, and this will be equal to n into minus n and 222 divided by 3, so that will give us 74 degree. So from here I think we are getting n square plus 60 minus 74, so minus 14n, and then minus 120, this equals to 0. This is the quadratic that we are getting, and you can very easily see that we can split at minus 20 and plus 6, so the factors will be n minus 20 into n plus 6 equals to 0, because n is representing number of side, n cannot be negative. So from here we are getting n as 20. So that will be the correct answer for this problem. Total there will be 20 sides in that polygon, right? So this was a very basic problem, you can say. If you know this formula, that sum of all the interior angles in a polygon of n side is n minus 2 into 180, then this is the sum that we'll get using a standard formula. And on right hand side we have sum of in terms of AP, with first term 219 and common difference minus 6. After solving, we got n as 20, and that will be the correct answer for this problem. The three successive terms of a GP with common ratio R, where R is greater than 1, are the length of sides of a triangle. And this box is representing the greatest integer less than equal to R. Then we need to find the value of this quantity, 3 into greatest integer of R plus greatest integer of minus R. So let us say that we have a triangle ABC, and in that triangle the smallest side is, let us say, A, and because the common ratio, let us say that this side BC is small a, and because the common ratio is greater than 1, common ratio is R and it is greater than 1. So the next side will be A into R, and A into R, that will be bigger than A, right? And let us say that the third side is AR square. Now we know that in any triangle, sum of two sides is always greater than the third side. That means A plus AR, this should be greater than AR square. Similarly, A plus AR square, this should be greater than A into R. And finally, AR plus AR square, this should be greater than A. So basically, we need to solve these three inequality, and from there we need to find the range of A. And then we have to see what should be, we have to find the range of R, and then we have to see what should be the greatest integer of R and greatest integer of minus R. However, one simple trick, and you can save considerable amount of time in solving these inequalities. The trick is that because for the given GP, the common ratio is greater than 1. So in that triangle, the smallest side is A, next the smallest side is AR, and then the biggest side is AR square. So if I satisfy the first inequality, that sum of two smallest side is greater than the biggest side, then other two inequality will always be satisfied, right? If I satisfy inequality 1, that sum of two smallest side is greater than this biggest side AR square, then obviously out of these two, AR square and AR, AR square is a bigger number, and in that we are adding A. So the second, and using similar logic, you can show that this third inequality, this is also always satisfied. So basically we need to solve the first inequality. There is no need to solve second and third inequality because this will be always true. Now for solving the first inequality, you can take A common and you can cancel A because A is positive. So then we are getting R square minus R minus 1 less than 0. Right? We can take everything on one side. A we can cancel. So R square minus R minus 1, that will be 0. And now we need to solve this inequality using number line. So, and also it is given that common ratio is bigger than 1. So we have to focus on R greater than 1 only. Now, if you solve this, then the roots that you'll get is 1 plus root 5 by 2, and the other one will be 1 minus root 5 by 2. But 1 minus root 5 by 2 will be smaller than 1, right? So the positive root will be 1 plus root 5 by 2. And when R is bigger than that number, we'll get positive sign for this one. And between 1 and 1 plus root 5 by 2, this will be negative. That means the range for R, this will be from 1 to 1 plus root 5 divided by 2. Right? Between the roots, we'll get the negative sign. And because it is given in the problem that R is greater than 1, so we are solving the inequality only when R is bigger than 1. There is no need to solve for R less than 1. So between these two roots, between the roots, we'll get minus sign. So, and because R is greater than 1, so the range for R will be from 1 to 1 plus root 5 by 2. Now 1 plus root 5 by 2, this will be less than 2, right? Root 5 will be slightly more than 2, certainly less than 3, right? So this number is uh, less than 2, right? This number 1 plus root 5 by 2, this is less than 2. So now if we talk about greatest integer of R, so R is between 1 and 2, more than 1 and less than 2. So greatest integer of R will be 1, and greatest integer of minus R. Now minus R will be between minus 2 and minus 1. So greatest integer of that will be minus 2. So 3 minus 2, that will be plus 1. And that is the correct answer for this problem. Right. So in this problem, the important take was that because common ratio is greater than 1, so AR is the smallest, A is the smallest side, then AR, and then AR square. And once I solve the first inequality, the other two inequality, these two are always true. Right. So from there we got range for R from 1 to 1 plus root 5 by 2. And hence, when you calculate the value of this expression, you will get 3 minus 2, that is 1. And that will be the correct answer for this problem. Let Sn represents this sum 1 by 2 plus 1 by 6 plus 1 by 12 and so on to n terms. If sum of the first 6 terms of an AP with first term minus 6 and the first term minus p and the common difference plus p is this one, root over 2026 and this multiplied by s of 2025, then we have to find the magnitude of difference between the 20th term and 15th term of this AP. Now in this problem, first we need to calculate this Sn so that we can figure out the value of S 2025. And once we have this value, then we'll see that how to find sum of an AP with first term minus p and common difference plus p. So here, first we need to see the pattern in Sn. So you can see that we have 2, then 6, then 12, 20 and so on. This 2 is 1 into 2. 6 is 2 into 3, right? 12 will be 3 into 4, 20 is 4 into 5. So that means if you write the general term Tn, then clearly you can see that this will be 1 by n into n plus 1, right? In first term, we have 1 into 2, then we have 2 into 3 and so on. So this is the general term Tn. And these type of problems are very common in JEE Main, where using method of difference, we have to find the sum of n terms of this series. So the first step will be that we need to write Tn as Vn minus Vn minus 1. This is the standard method, that we need to write Tn as difference of two consecutive terms. We also call this Vn method or method of difference. So here, write the general term as difference of two consecutive term, and then when we add, the alternate terms will cancel. So for that, this 1 in numerator that you can write as n plus 1 minus n, and this divided by the denominator part will be n into n plus 1. And now you can see that when you separate the two terms, then you will get 1 by n minus 1 by n plus 1. So this is the general term Tn, right? Now here if I calculate T1, the first term itself, this will be 1 minus 1 by 2. Similarly, the second term 1 by 6, this one can write as 1 by 2 minus 1 by 3. The third term 3 into 4 or 1 by 12, this you can write as 1 by 3 minus 1 by 4. And in this manner, the last term Tn, this will be 1 by n minus 1 by n plus 1. So this will be Sn, right? These are the different terms. Their sum will be Sn. So now clearly you can see that if you add all of these terms, then 1 by 2 will cancel, 1 by 3 will cancel, and so on. So from here, when you add all of these terms, you will get Sn as you have 1 from here, right? And 1 by n plus 1. All the other terms, they will cancel. 1 by 2 will cancel, 1 by 3 will cancel, and so on. And the second last term, the second term will be 1 by n, so that will cancel this 1 by n. So ultimately we have 1 minus 1 by n plus 1, and this will become n by n plus 1. So this is sum of n terms of that series, right? Now it is given that sum of first 6 terms of an AP with first term minus p and common difference plus p is that number is 2026, and this multiplied by s of 2025. So sum of 6 terms of AP, that will be 6 by 2, and this multiplied by 2 into A is minus p, and plus n minus 1, n is 5, so n minus 1 will be 5. Common difference is p, and this sum is square root of 2026, and this multiplied by s 2025. Now s 2025 means 2025, and this divided by 2026, and this raised to 1 by 2. And now by solving this one, we need to find the value of p. So clearly you can see that 2026 will cancel, and from here you will get 3 into 3p, and root over 2025, that will be 45. So from here we'll get the value of p as 5, right? Now the problem is we need the difference between, so the value of p is 5, and for the given AP, the common difference is of 5. Now we need the absolute difference between the 20th term and the 15th term. So clearly you can see that difference will be nothing but 5d, right? 20th term means a plus 19d, and 15th term means a plus 14d. So the difference will be 5 times the common difference. Common difference p is 5. So therefore this will become 25. So the correct answer for this problem will be fourth option. So this was a very standard problem of method of difference. First write the general term as difference of two consecutive terms. Then from there we got Sn as n by n plus 1. And now after that, standard formula for sum of n terms of AP. So finally the correct answer for this problem is 25. If the sum of first 20 terms of this series is m by n, where m and n, these two are co-prime numbers or relatively prime numbers, then we have to find the value of m plus n. Now, this is another interesting problem on Vn method. Right here, whenever you have a number of terms in denominator, then we have to write the general term as difference of two consecutive terms. And then once you start adding them, the alternate terms will cancel. So here first let us write the general term Tn, and then we'll see how to write that as Vn minus 1, right? So in numerator you can see that we have 4 into 1, 4 into 2, 4 into 3. So in nth term it will be 4 into n, and this divided by, in denominator the first term is always 4. Then next one is 3 into 1 square, 3 into 2 square, 3 into 3 square. So it will be 3 into n square. And 1 raised to 4, 2 raised to 4, 3 raised to 4. So this will be n raised to 4. So this is Tn. Now, as you can see that in denominator, we have a biquadratic polynomial. Now, in these type of problems, the standard technique is that write Tn as Vn minus 1, and then when you add, the alternate terms will cancel. Now, in order to write in that form, first we need to create factors in denominator, right? So here we can write this one as 4n, that will be the numerator part, and in denominator we have n raised to 4 plus 3n square plus 4. Now, in order to create factors here, this 3n square, this you can write as 4n square minus n square, right? If I write 3n square as 4n square and then minus n square, then you can see that first three terms, this will form a perfect square. And then we can use the formula of a plus b, a minus b. So 3n square, I'm writing as 4n square minus n square. And now when you combine these three terms, then it becomes n square plus 2 square of this one, and then minus n square, right? N raised to 4 plus this 4n square, this is 2 into 2n square, and here we have 2 square. So this is Tn, right? Now in next step, in denominator you can easily see the factors a plus b. If I use a plus b into a minus b, then you have n square minus n plus 2, that will be one term, and the another one n square plus n plus 2. Also, if you see the difference of these two terms, the difference, I mean, if I take the difference of these two factors in denominator, you will get 2n. So the 4n in numerator, that you can write as 2 into 2n, and this 2n you will write as n square plus n plus 2 minus n square minus n plus 2. Why? Because our aim is to write this as difference of two consecutive terms. And now you can see that if you separate this one, then you will get twice of, and in first one n square plus n plus 2, that will cancel. So we have n square minus n plus 2, right? In first term you will get this thing in denominator, and in second one the other term will cancel, you will get this one in denominator. So this first one you can write as 2 plus, and if you take n common, then you have n into n minus 1. This is first term, minus the second one will be 1 divided by, and in denominator again you can take n common, so you have 2 plus n into n plus 1. So finally this is the general term Tn, and clearly you can see that this is these are two consecutive terms, because if I replace n with n plus 1 in first one, right, in this one, in place of n, if I write n plus 1, then you will get the next term, right? So this is Tn as Vn minus Vn minus 1. And now the question is, we need sum of first 20 terms. So here if I write T1, T1 will be twice of, and in place of 1, if I write 1, then it will be 1 by 2 minus 1 by 4. This is first term. Similarly, second one will be twice of. Now in place of n, if you write 2, then this will become 4 minus 2 into 3, 6 plus 2, that will be 8. Similarly, you can see the pattern here. If I write T3, this will become twice of, then 1 by 8 minus, and 3 into 4, 12 plus 2, that will be 14. And in this manner, if I write the 20th term, then this will be twice of 1 by, and then 20 into 19. So that will be 380 plus 2. So that is 382 minus, in place of n, if I write 20, then we have 20 into 21. So that will be 420 plus 2, 422. So these are the expression for T1, T2 and so on. Now if I calculate Sn, or rather S20, sum of all these 20 terms. So this will be 1 by 4 will cancel, 1 by 8 will also cancel. Everything will cancel except this 1 by 2 from first term and 1 by 422 from the second term. So sum of these 20 terms, this will be twice of 1 by 2 minus 1 by 422. This will become 1 minus 1 by 211. So this will be 210, this divided by 211. This is S. This is sum of 20 terms. Now, as you can see that there is no factor between these two terms, right? So these two are relatively prime number, or their HCF is 1, and we are getting 210 by 211. The question is, we need the value of m plus n, right? So m plus n, m is 210, n is 211. If you add these two, then you will get 420. 1. So the correct answer for this problem will be second option. Right. So in these type of problem, the important concept is that you need to write the general term Tn as Vn minus 1, and for that you need to create factors in denominator, and then whatever difference you have here, create that difference in numerator, and now Tn is Vn minus 1 or Vn plus 1. It should be two consecutive terms. Now, when you add all of these terms, you will get only these two terms, one from the first, one from the last. After adding, S20 was 210 by 211, and there is no common factor between those two. So finally, m plus n will be 421, and hence the correct answer for this problem is second option. An arithmetic progression is written in this manner. In first row, you have only one element 2. Then in second row, you have 5 and 8. In third row, you have 3 elements, and so on. The question is, what is the sum of all the elements in 10th row? Right? Now, as you can see that in first row, we have one element. In second, we have 2. Third one, 3. So in 10th row, we'll have 10 elements. All of those 10 numbers will be in AP. And for that AP, the common difference will be of 3, because you can see that we have all the terms, the different terms of an AP with common difference 3. So in 10th row, we'll have 10 elements. For all of them will be in AP with common difference 3. Now we know that formula for sum of n terms of AP is n by 2, and then you have 2a plus n minus 1 into d. This is the standard formula for finding sum of n terms of AP. Now, as you can see that there are three unknowns in this formula, n, a, and d. Common difference d, this will be 3. Number of terms n, this will be 10, because we have 10 elements in 10th row, right? The question is, what will be the first term of 10th row, right? We need to find this a here, and then we can easily get sum of 10 terms, right? Now, for finding the first term, there are different methods, right? Here the major part of the problem is to find the first term a, right? Once we get a, the first term of 10th row, right? The first element of 10th row, then we can easily get the sum. Now, for finding the first term, one approach will be that if you notice the first term here, 2, 5, 11, 20, and so on, for these terms, their difference is in AP, right? For example, difference between 2 and 3, this 2 and 5, this will be 3. Difference between 5 and 11, this is of 6. Difference between 20 and 11, this will be 9. So as you can see that difference, if we talk about the series of the sequence of first term, for that one, difference is in AP, right? And we know that if difference is in AP, then we have this standard formula that nth term will be an square plus bn plus c, right? This is the standard formula for finding the first term. And how to get the value of ABC? So for that, when you can use the different equation, that first term is 2. So that means a plus b plus c, this will be 2, right? Similarly, for this sequence of first term, the second one is 5. First one 2, the next one 5. So T2, this should be 5. That means 4a plus 2b plus c, this will be 5. And T3, this is 11, right? We are talking about the sequence of first terms. So because for them common difference is in AP, the general term will be an square plus bn plus c. First term is 2. In place of n, if we write 1, we'll get a plus b plus c, so that will be 2. Second term is 5. And third one is 11. So in place of in place of n, if we write 3, then we'll get 9a plus 3b plus c, this equals to 11. And now by solving these three equations, three unknowns, we can easily get the value of a, b, and c. Once you have a, b, c, you will get Tn, and then you can calculate T10, right? Because the first term of 10th row, that will be the 10th element of this sequence. That will be one method. However, there is another interesting method of finding this a, right? Or maybe I'll just replace this a with alpha, because a we are using for here. So let us say alpha is the first term of 10th row. So here alpha, there is another easier method of finding this one. One method will be, you can use this general method, an square plus bn plus c. Another approach will be that in first AP we are using one term, In second one, we are using two terms of this AP. Now we are talking about this AP 2, 5, 8, 11, 14, and so on. Right? This is the AP that is there. Right? Now, in first row, we have one element. So we have used one term of this AP. In next row, we have two elements. So we have used the next two element of the AP. Similarly, by the time we complete the ninth row, we have used the first 1 plus 2 plus 3 up to 9 elements of this AP. So the first element of 10th row, that will be nothing but this particular term of this AP 2, 5, 8 and so on. So here if you calculate this number, this will become 9 into 10 by 2. So it is 45 plus 1, 46. And T46, this will be A plus 45 into D. Right? Now A is 3, A is 2 and the common difference is 3. So that means in place of A, we can write 2 and the common difference is of 3. So 45 into 3, that will be 135 plus 2, that will be 137. So this should be the first term of 10th row, right? Alpha or the first term of 10th row, that will be 137. And now we can easily get the sum of all the elements in 10th row using this standard formula. So we have n by 2, that means 10 by 2. 2a, so 2 into 137 plus n minus 1, n is 10, so n minus 1 will be 9 and this multiplied by common difference 3. So from here, we can get the value of S10. This will become 5 into and 137 into 2, so 274 plus 27, so that will be 301. 301 into 5, so 1505. Right, so finally the correct answer for this problem will be 1505. That will be the right answer for this problem. Right, so in this problem, the important concept was, to find this first term A, this was the important part of this problem. Number of term will be 10, common difference is also 3. All we have to do is find the first term or first element of 10th row. For that, one method you can use is that because for the sequence of first term, the difference is in AP. Tn is, let us say, an square plus bn plus c, and now three equation, three unknown. By solving this, you can get ABC. Another easier approach will be that because in first row we have used one element, in second row we have used two elements and so on. So by the time we have completed 9 row, we have used the first 45 elements of that AP. So the first element of 10th row, that will be the 46th element of that AP. And by using the formula of nth term of AP, we got alpha as 137. And once you substitute the value of alpha here, sum of all the elements will be 1505. And that is the correct answer for this problem.